Anna Hoffman.
Hey friends, I'm Nikolai.
Hi, I'm Mustafa Turaman.
Hi, I'm Tanya Janka.
Hello.
And I'm excited to be the speaker at Azure Summit 2021.
It's a fantastic event that will be 11 days live streaming,
where more than 100 speakers from all over the world.
I'm excited to speak at Azure Summit about Power BI and Synapse Analytics.
And I'm going to talk about security.
And also a Microsoft MVP for Azure.
I'm speaking at Cloud Summit about automated release of .NET application.
And the best part is that this is a free event.
Come join me live at Learn TV on September 17th.
Come join me live on Learn TV on September 14th.
Come join me on Learn TV on the 14th of September this year.
A bunch of other Microsoft and community speakers.
So if you want to learn how to secure Azure, come to my talk.
Join us, it will be a lot of fun.
See you there.
See you there.
See you there.
See you there.
All right, everyone, welcome back for the final time for Cloud Summit 2021. It is day number 11. I still cannot believe it. We made it, but last 10 days have been incredible. I was telling the other day that I have hosted most of the days and I have now become an Azure full stack developer. Can you imagine Azure full stack developer? And if you want to hire me, you can hire. And if you hire me, you'll be hiring an entire team. I can do anything. I've had free Azure training from past 10 days. Having said that, I'm really excited and looking forward for today, because today is the other day and today has been the longest days we are streaming for about 12 to 13 hours each day. We are covering the entire ecosystem of Azure. We have covered almost the entire ecosystem of Azure, but today is going to be a lot of learning. We have sessions around cloud scalability, Azure SQL, Power BI, Azure Machine Learning Studio, AI, SQL Server VMs, and IoT, and a lot more. Having said that, quick and gentle reminder, thanks everyone who's joining in. Santosh, I did say it last day, and you says morning from UK, welcome. Hasnan says, final day, but not the least. Great speakers, amazing sessions, absolutely great, and great hosting. Oh, thank you, I appreciate it. And we have very exciting news coming up. Stay tuned on our website and on our Twitter handles. Less than a week, we have very exciting event coming for you directly from Microsoft. It would be an official Microsoft event that we will be streaming on this platform. So stay tuned for that. Having said that, as always, I say a gentle reminder to follow code of conduct and be kind to everyone. I've been looking into the comments. You guys and girls are spot on, so no problem with that. And as always, 3 contests that's always running up. The first one is live comment contest, that whenever you ask a question to a speaker or share your thought in the comments for a session, please use #CloudSummit, and we'll make sure that we pick the winners towards the end of each part. And there's a Twitter and LinkedIn contest always going on. So take a selfie, be creative in any way, and tag us on Twitter and LinkedIn with @CloudSummitLive and using #CloudSummit. And we'll make sure we pick the winners towards the end of the day. Now, this brings me to invite a very first speaker of the day, Mikey. Mikey is going to talk about Azure SQL Database. It's about automate management tasks using Elastic Job in Azure SQL Database. And it has been Azure SQL. We have had many sessions around Azure SQL. and people really love learning Azure SQL and working on it. So without any further ado, let's bring our very first speaker of the final day, Mikey. Oh, sorry.
That's okay. Thank you, Simon. It's
Sorry,
excellent to be here.
I messed with your name.
Ha! I
It's
did the
different,
same.
right?
I did the same with your name. Remember?
Yeah. I mean,
So
it's different on LinkedIn and it's different over here. So never mind. So Mikey,
yeah,
today, yeah.
yeah, sure. Go on.
Yeah, so today you're going to talk about Azure SQL Database, right? And I'm just telling before you join that it is something that people have shown a lot of interest when we were taking registration forms. So I believe I'm really looking forward for your session, and also you're talking about automation. So that's great. I see you have shared your screen. I'm going to add it to the stream now. Everybody else can see it. And next, Mikey, maybe you like to click on that height pop-up of StreamYard.
Oh yeah, sure.
Yeah, this one. Yeah, next
Awesome.
45 minutes is all yours.
Is it 45 minutes or 25 minutes?
25 minutes. It's up to you. 25.
Yeah, well,
yes, sorry,
yeah,
I messed up.
That,
It's 25.
yeah, that's okay. No worries. So welcome to the excellent Cloud Summit 2021. It's an incredible event spanning over 10 days, 11 days. Wow, that's a lot of knowledge, and you can become Azure expert if you followed all the days. So my name is Mikey Bronowski. I'm a data platform MVP and Microsoft trainer, and I'm going to talk about the elastic jobs in Azure SQL Database. So before we go to the agenda, a few words about me. I live in the UK currently. I'm working as a database engineer. I have a 2 years old son and beautiful wife who's sitting in the other room. That's the home office for last year. So that's me, and I will share my contact details in the end. So the agenda for today is what are the elastic jobs in Azure, how we can configure them, and why one would need to use them. So the first bit is what. The elastic jobs are the scheduling service to execute SQL scripts on one or more targets. And the targets can be Azure SQL databases, elastic pools, and Azure SQL database in shard maps. So think about something like a SQL agent, which is not available for Azure SQL databases, but with the flexibility of master and target services. So if you've never used the master MSX or TSX, it's master server and target servers, then I encourage you to check that. It's available on-prem, and you can configure the central place for your jobs to be executed on your target servers. So basically, the elastic jobs do the same thing, but they also work as the agent job replacement for, not replacement, just alternative for the Azure SQL databases. The feature is still in preview. I think it was introduced, now it will be 3 years or so, but it's still in preview, so just keep that in mind. There are main components of the elastic jobs. It will be the elastic job agent that we need to configure on the job database, which has all the procedures, tables that manage the work. And if you look into the objects, you will see some similarities to MSDB on premises SQL Server. And we also have target groups where we define the sets of our targets. We can set the whole server, we can set the pool, we can specify just the databases, or we can specify the whole server and exclude some databases, which is cool. And with MSX and TSX, I think there's a way just to put the servers. So that's that's perfect here. And we also need job, and the job will run the T-SQL scripts, and the script has to be written this way that whenever it runs, it just completes. It cannot just fail. It has to complete. So the logic has to be like, if you have a logic to create a table and the table exists already in the database, the next time it runs, it has to check either if the table is there and if you need to drop it or just skip it. Depends on what you need. So how we are going to do this? Well, I usually present longer version. So there are two ways we can set up this in Azure portal, but it does need some extra work outside Azure portal, and it can be done in PowerShell. So in this presentation, I'm just going to show you the Azure portal, which will be probably make more sense to present the whole thing. I don't know. Do you see my presentation? Oh yeah, because my screen went black. Well, looks like it's there.
Script Runner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to Script Runner, the #1 for PowerShell management. Script Runner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With Script Runner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
I'm back. Sorry for that. My Edge crashed with the streaming app. I don't know what happened. So I think I was starting just about to talk about how we configure that. So we can do this in PowerShell and Azure Portal, and we need the targets, of course. The jobs need to do some work on the targets, and we need the job database, and the requirement is the SO minimum. It cannot be the basic one. So for the job database, the targets can be lower than that. We also need the Elastic Job Agent on the job server, and we also create a set of credentials. So we have a master key on job database. Then we create the database scope credential on job server, and the suggested way is to, well, the best way is to separate all the credentials to have this list needed permissions, rights. So in this example, I have one credential that is responsible for job execution, and the other one is responsible for server refresh, which is the database list on the server refresh, and we need to create them on the job server. Then we create the logins on target servers in master database, and the user corresponded to the login on the master database, just the one that refreshes the list of the databases, and the job execution credential in every database on the target server where we need to work. That seems a lot, but I will show you that we can do this with T-SQL because it's not possible to do this in the portal. At least it wasn't yesterday. And we need some extra permissions for the job to do something. So if we need the job to create the tables or do some DML operations, we need to specify those permissions. Finally, we need to create the target groups and add the members, and then create the Elastic job. So that's the plan for us. So I'm going to switch to Azure portal now. Let me see if I can. I had to restart my whole browser. Okay, I'm logged in. Perfect. So you can see there is a resource called Elastic Job Agents, but we will start with creating the SQL databases. I have some already created, just a backup in case I cannot manage the Azure time or something happens like web browser crashes. So let's create a SQL database. I'm going to create two. One will be the job and one will be target, just to show you the basics of the feature. So in SQL databases, I'm going to create just a basic. Wow, that's slow. Let's create brand new. That's the backup. So let's create Cloud Summit, and it's black again. Can you see me?
Yeah, Mikey, I can see you. Mikey, I can see you.
My browser just crashed. Oh, sorry. My browser just crashed. So I don't know if. So please let me know if it happens again. So I'm just creating the Cloud Summit 21 resource group, and now I'm going to create a job database. So it will be Cloud Summit Job DB. Hi again. Sorry for that. I'm using different browser now. Yeah. Well, we'll see if that helps. So I was about to create the first SQL database and for the job, and I need to create a server. So I'm going to create my admin account, and that's it. Perfect. I don't care about the location right now. I just create this as you can see me. And now here in this place, I'm just going to change this to the minimum. I don't want to pay too much, so I'm going to change for the standard, and that will be S0. So I can just make it. Doesn't matter really for the demo. And so I'm ready to go. Now, few changes here. I need to have access from my laptop, so I need to change this to public endpoint. And I'm going to allow the Azure services to talk to each other, and then add my IP address. And I think that's all. I don't need to configure anything at this point now, so I'm just going to create that. The estimated cost would be €12 per month. So I changed that from the more expensive server. And that's the job database. So I need a target database. So I'm going to create a target database now. We still have some time, so I'm going to create that. But if it's taking too long, I will just show you the backup thing I have. So we're going to this resource group. Cloud Summit. Okay, let's skip the big letters. Cloud Summit target DB, and we create a new server. And the credentials, so I can connect from my management studio. And changing this, the target can be the basic one. So I'm just changing this to save some money, and it will be much cheaper than the default one. Again, changing the permissions. That's all. Security, no, nothing changes here, and it will be for around €4 per month, which is 3 times less than the job database. And usually it takes a couple of minutes. So while it's being created, I'm just going to show you how it looks like in the Azure. So from my other backup solution, I have 2 databases, job DB and target DB. They are just databases, SQL databases, and you can see the types I've picked before. But the more interesting part is the Elastic Job Agent. So I have created one here, and it has few options like jobs, and I can see there is a job, but I cannot really change anything. It's just read only. It's just a list of jobs. I can see the target groups, the one I've created, but I cannot see what's inside. That's the limitation of this preview feature. I can see the credentials I've created, but also nothing else. And that's pretty much it I can do in Azure portal. So not much, and I cannot even create the credentials here. So I have to use some T-SQL to use that to create them. One server has been created. Is it the? Let me see if that's the. Go to resource. It's the job database. So at this stage, I'm going to connect to my job database server. And we can see that this database is empty. It's just empty database created here. No tables and no store procedures. That's just the job database. So now I'm going to create the agent. And if I go here to the Elastic Job Agents and click Create, excellent. It was much faster than yesterday. And I'm going to name it like Cloud Summit 21 Agent. I need a name, I need a subscription, and I need a job database. Since I have both servers, I can show you why we need the better specs. So I picked the target one was the basic one, and it doesn't show me any databases. So I cannot use that really. And I have to go to the job where I use the standard SO pricing tier. So now I can use that database, just click it. It will highlight the OK button and click OK. The automations options are just for templates and stuff like that, so we don't need that here. So just create. And about a minute later, it will create the agent. And what it does, it will create all the tables here. So we should be able to see once it's going to create, it will create the tables. So now I'm just going to connect to the target. It's also empty database. And my goal for the demo is to create a table with the Elastic Job and the target. So it's empty here. Let's see if we have anything showing up. No, it's still being created. So that's fine. We can do the other bits. So I have a script to add the credentials here, and I have exactly the same script here. So I'm going to connect on the left-hand side to the job database. I just need to change that's the job database, because all these scripts is a mixture of scripts to be run on job and on the target server. And I'm going to connect to the target. So they are in one file, but it can be done in order. So while the agent is still being created, it's done. Yeah, perfect. So we can see when I refresh the tables, we should see the internal tables. And they look very similar to what we have in MSDB. And when we refresh the stored procedures, we also have some stored procedures here. So now I'm going to create the credentials on a job server, on a job database. I'm going to create the master key in the master database, which is interesting now. What happened? Am I connected to the proper Classic Cloud Summit job database? Oh, sure, job database, not master. Master key, but in the job database. And now we need to create the scoped credentials for the job database, because job database is the one that controls the jobs. And now we switch to the target server, and here we create this on the master database, and we need the login for refresh, to refresh the databases, refresh credential for the database, and job login for job credential to execute the jobs. And we also need the target database. If you try to use the use word, it won't work. It doesn't work in the SQL, Azure SQL. So I have to change the context. My timer is gone now. I hope you can wait a few more minutes with me. Just to show you, if we go this, it shouldn't work. The US statement is not supported between here in Azure SQL Database. So I've created the login master database, now user in target database, and I want the credential to have DDL rights to create the tables. Next, I'm going to create in the job database. I'm going to switch to the job database, the target group, just called target group for demo, and add some members. And because I'm using different server now, I need to have this server. So it's my target. And I created add the target, the members. I can check them, check the group, check the members. It says include. That's one type of the membership. If I add the exclude word here, it will exclude a specific database. And now I'm going to add the job. It will just run once, and then I'm adding a step. It will be just one step. And you can see the logic. If not exist, the object table, create table. Just a simple table, nothing really fancy here. And when we query the jobs and job steps as in similar to MSDB, we can see the details of our job. And here we can execute the job from T-SQL. So I'm going to start the job, and it started now. Now we can observe the executions. So in the job executions table, it will show us the progress. And if for some reason it fails, it will retry, and we will see which retry is that, which number is that. But it succeeded. So let's switch quickly to our target database, and the table is here. And if I run the job again, it won't fail, because I have the logic to make sure if the table doesn't exist, then create. If it exists, then do nothing. And in the portal, when I go to the agent, the one I just created and it was empty, you can see that I have the job here, and my targets and my credentials, and that's pretty much it. And that was the presentation how to create that in portal. As you can see, it's not fully possible to create the whole solution just in portal. You need some T-SQL, but it's not that bad. You just need portal and T-SQL. With PowerShell, you can create the whole solution within PowerShell. You don't have to go to the portal. And why would you like to create the Elastic jobs? Because for the main reason, it's the SQL Server agent is not available for Azure SQL Database, and the other stuff are like automating management tasks. If you want to do maintenance, then on multiple Azure SQL databases, then do this way. And you can also collect data in a central data table. So if you ever have chance to see the other demo when I presented the full PowerShell stuff, there is an example where I'm running a query against all the multiple servers, and the results are going to be stored on the job server, and then you can query the job server. And this is brilliant for so many cases. And sorry for overrunning a little bit. Sorry for the troubles. Looks like Edge didn't like the website, but Opera liked it more. So I'm happy that I finally made it. And yeah, just remember Azure Portal and SQL. You need some SQL. With PowerShell, you don't need anything else. Just use the AZ SQL PowerShell module. And I was using also DB tools to run some T-SQL, but again, it can be done within PowerShell. You don't have to leave the PowerShell session. Thank you very much once again. Thank you for having me, Simon. That's a great conference. If anyone wants to get in touch with me, my email is Mikey Bronowski, no space, @gmail.com. The same handle I have on Twitter or on LinkedIn. And I also occasionally write blog on bronowski.it. And that was my pleasure to share something about Elastic Jobs at your conference. Thank you very much.
That was great, Mikey. No doubt you were chased by some of the demo demons. Demo gods were not with you, but never mind. But so working with SQL agents, right? We had some search around SQL. I've been looking from past 10 days. What is the most challenging thing you find working with SQL agents?
SQL agent or the Elastic Jobs?
Elastic Jobs. Let's see you're searching around Elastic Jobs. Yeah.
Well, the first, when you start, the challenge is that you need to mix the portal and something else. You cannot do this within the portal. If someone is not familiar with PowerShell, and there is some hacking involved, as you've seen. I had to have the T-SQL scripts that needs to be run one time on target, one time on job, and we cannot do this in portals. It would be great for some people who like to just playing around in portal. So that's great. And also if the job fails, it retries multiple times. I couldn't find the exact number, but at least it was 9 times. So it just retries. And when I was playing with that before, I had to stop it or force it within PowerShell just to stop the job. I had to find the exact GUID. I think the execution, there is a job execution ID. It's a GUID, so I had to find the exact GUID and then use some PowerShell to force the stop. So there is no also the, like in SQL Server, you have the SQL agent part where you can see the jobs and you can see if it's running, and you can right click and stop or do something. It's not possible here right now. We cannot do that. So it's a bit different, but yeah.
I hope someone at Microsoft is
it's still
feedback.
So hopefully
you're an MVP.
It will be sorted.
Yeah. You're an MVP, so definitely you can share feedback with program managers. Having said that, Mikey, it was absolutely great to host you. We'd love to have you back. We do many events across in the whole year, 21 conference in 2021, and many live shows. We'd love to host you back. We work very closely with Microsoft Learn TV, Channel 9 over there. So we'd love to host all those events too. Thank you so much for joining, and have a nice week ahead, and see you soon. Ta-ra. Bye. Take care.
Thank you very much. Have a good last day of the conference.
Thank
you are doing incredible work. So
thank you. Really appreciate it, Mikey. Bye. Take care.
Bye.
All right. Now we move to our next session from the Azure SQL. We now move to our session that's on the art of possible in cloud scale analytics and hosting for the very first time. Jayendra is the senior cloud solution architect at Microsoft, and it's very interesting. I'm based out of India, but there are not many speakers from Asia Pacific. I would say out of 150 speakers, we just have about, maybe if we leave the student track, we just have about 8 to 10 speakers from Asia Pacific. So I'm really excited to host him for the very, very first time. So let's welcome Jayendra to Cloud Summit 2021.
Hey, thank you so much, Simon. I'm equally excited to be part of the Azure Cloud Summit, right?
Yeah. So Jayendra, go ahead.
No, so yeah, really excited and looking forward.
Yeah, so Jayendra, where are you joining us today from?
So I'm joining from a place called Srirampur. That's my native. That's in Maharashtra, in India.
Oh wow, I love Maharashtra. I've been there a couple of times. Pune, Nagpur.
I had
the opportunity to visit Pune. If I'm not wrong, it was Rajiv Gandhi Tech Park or something. That's where I did visit. So yeah, beautiful, beautiful place. Jayendra, I won't take much of time. I know I'm already 5 minutes in your session, so I'm gonna add your screen to the stream. Maybe you would like to click on that hide stream at hide link, pop up. Yeah, click on that hide. Yeah. All right, everybody can see your screen, Jayendra, and next 45 minutes is all yours.
All right, thank you so much, Simon. Right, and I thought I'll take this opportunity to talk with audience about the possibilities in the cloud scale analytics, right? The art of possible. And let me know if it's okay. It's moving on. All right. So nowadays every small or big company is after the core business object of being able to unleash the value of their data, right? And analytics exactly allows you to do the same, right? To achieve and unleash the value of your data. So I thought I'll spend some time talking about one of the key Azure services that allows you to do all of that you would want to do in terms of analytics with your data, and show some art of possible with an interesting demo that I have. All right. So big data is paving the way for the next industrial revolution. I think this is no news for anybody by now, right? Everybody is, and our industries, various industries have never been short of data, right? Data has always been around. The challenge has been, how do you put together this data from different systems, this disparate data across various line of businesses? How do you bring them together, and how do you take advantage of this big data that has been there always around, right? And if I look at some of the analytics and BI customers, right, what they are looking to invest in, they want visualizations, advanced visualizations, they want ad hoc reporting, they want ability to create dashboards to solve business challenges, right? Or give them a just-in-time or a continuous view into how they are doing as a business, right? Important business matrices. But the challenge is the data systems are siloed. Their data is underutilized. So there is a lot of dark data that they are not even aware about, right? As to how to get to that data, and how do they make use of that data to solve business challenges. And the other constant challenge is it is slow to provide insights, right? So typically, even when you know that there is data, but that data is structured, unstructured in various disparate systems and disparate formats. So to bring that together, to be able to do an efficient ETL or ELT to create a single source of truth itself is a very slow process because of the tooling that has been available. And with Microsoft Azure technologies and services in the analytics space, we have tried to address exactly these problems to solve for our customers, right, all of their analytics requirements. And I'll talk more about that in coming slides. So let's first take a look at some of the stats that a Harvard Business Review study has published. What these stats state is analytics and AI is the #1 investment for business leaders today, right? However, they struggle to maximize on the ROI of their investment. 80% of them report that they are struggling to become mature users of the data, while 55% report that data silos and data management difficulties are the key roadblocks towards their analytics and AI journey. And how do we at Microsoft try to address that, right? So this is what our BI and analytics customers need. They want to unify all their data. They want a one source of truth, single source of truth, right? And instant insights on the fly. So how can you, enable customers to process petabyte scale of data, right? And be able to get instant insights out of this data to be able to take data-driven business decisions across all your line of businesses. And the key service that I'm going to focus on today is Azure Synapse Analytics. And there is much more to that with respect to analytics landscape on Azure. So I'll give you a brief about an overall, right, a bird's eye kind of view of how analytics services on Azure look like, and then talk a little bit more in detail about Azure Synapse Analytics. Of course, like I mentioned, it allows you to process petabyte scale of data, insights for all kind of data users across the organization, advanced analytics and AI, and of course it is super fast, right? It is critical when you are processing such a humongous amount of data that your system should be very performant, and Synapse Analytics solves that problem with its MPP architecture. All right, so first take a look at a kind of 10,000 feet data landscape, data analytics landscape on Azure, right? So I have a number of services listed on here. So let's go left to right and understand these in detail, right? Azure Data Factory, that's a key data integration and data ingestion service that allows you to ingest data by using 90 plus connectors that are readily available to be able to connect to any of the source systems that you may have your data in, right? And these could be on-premises legacy data sources. These could be very popular and the cloud data sources such as Azure data sources, or even compete data sources such as, let's say, Amazon Redshift or Google's BigQuery. So you with 90 plus connectors that are available to you, you can directly connect to these data sources and start ingesting your data. Also, it allows you to orchestrate your data pipelines, right? So you can schedule your data pipelines to run at set frequency that you demand, that your workload demands, and it's a serverless system, provides you serverless compute so that you can not only do orchestration and ingestion, but also do a lot of transformation in both code first and code free way, right? And this service comes integrated natively within Synapse, called Synapse Pipelines, and I'm going to show you in detail as to as part of the demo. Now, Azure Event Hub, Azure IoT Hub, and Kafka, which is an Apache Kafka open source engine on Azure HD Insights. Now, these are some of the services that you may look at using when you are looking to ingest streaming data, right? Real-time data sources such as Clickstream, or you may have data coming in from Twitter feeds, or any other, or for that matter, let's say IoT devices. So these are the services that help you to bring in streaming data or real-time data. Now, fundamental to the analytics framework, right? You have blob storage and Azure Data Lake Store. So these are the two key storage systems. Blob storage, it's more of a general purpose storage that can allow you to store all sorts of data, right? It could be structured and unstructured data. It could be media files. It could be log files. It could be, just think of any data that you want to store. It could be log archives and whatnot. Azure Data Lake Storage, on the other hand, is also a blob storage, but hierarchically created on top of HDFS system that allows you to do big data processing in an optimized way, right? So this storage is an optimized blob storage that allows you to do big data processing at scale. And Azure Purview is a data governance service, again, that cuts through and natively integrates with a number of other Azure services. But Azure Purview is a data governance and data lineage kind of data discovery, data governance, and data lineage service that connects internally with a lot of these services and allows you to discover your data, understand how your data is being used within your organization, right? Who are different users of the data, even go ahead and classify the data. Out of box, with its out of box available features, you can also classify which is the PII data and which is not. Now let's talk about Azure Synapse Analytics. This is a one-stop solution for all your analytics requirements, and I'll just say that much for now because I have coming slides that will talk about Synapse Analytics in detail. Now let's take a look at Azure Databricks and Azure HD Insights. So if you are a customer who is keen to or who is well versed with Spark, right, then Azure Databricks is the analytics workload that you can go, because Azure Databricks is a first-party Databricks service available on Microsoft Cloud or Azure Cloud, and that is 10x faster compared to Apache open source Spark, right? And the other advantage of using this service on Azure is because it's a first-party service, so you do not have to worry about whether Microsoft has to provide you the support for this or Databricks, right? So you just have to go to Microsoft for any kind of support requirement, and Microsoft and Databricks engineering teams work hand in hand very closely to create an optimized Spark engine, and there is a lot of innovation going on continuously on this. Azure Stream Analytics and Azure Data Explorer. These are the two services that allow you to do real-time analytics on streaming data. So you have a streaming data coming in from IoT devices or data coming in from Clickstream, and you want to do on-the-fly analytics. You want to run some ML models on top of that and be able to do solve use cases such as fraud detection in real time. So that are the use cases that you can solve with Azure Stream Analytics. Azure Data Explorer, while it also allows you to do real-time data analytics, additionally, what Azure Data Explorer does that Stream Analytics probably doesn't do is it can allow you to combine the streaming data that is coming now and here, right, in this moment, with a lot of historical data, with let's say 2 years historical data or 5 years historical data, so that you can get a complete trend of the data that is coming in now compared to how the data trend looked like from past 2 years or from past 5 years. So you can check that data trends at scale, right, to identify if there are any anomalies that are coming in the streaming data. Azure Analysis Services and Power BI need no introduction. Analysis Services is nothing but what you had as SQL Server Analysis Service on-premise. Compared to that, this is the cloud version of that, which allows you to create multidimensional models to quickly that help you to quickly visualize data in different possible ways. Power BI needs no introduction. That's a state-of-the-art BI service or visualization service that helps you to create dashboards. And with Power BI embedded, you can create dashboards that are embedded within your application, right? Without your end customers or end users needing to have a Power BI license, you can take advantage of Power BI embedded service and embed the state-of-the-art visualizations and dashboards within your applications. To augment all of these analytics, right, we have state-of-the-art Azure machine learning services. Azure Databricks can also be used with its Spark ML to perform the ML and AI related workloads. You have ML server that support R, Python, and all sorts of popular frameworks. And Azure Search is also a data mining service. This is powered by a cognitive search service. So all of what you see on Bing search is essentially powered by Azure Search. So it allows you to do data mining across your disparate data, right? So I know this was a busy slide and we talked about a lot of these services, but this is just an overview of all the services in this space or other key services in this space that allow you to do or implement various business scenarios and use cases when it comes to analytics, right? Now, to understand what is the art of possible or what are the different possibilities with just one service, Azure Synapse Analytics, let's move further. So before we get there, right, let's first understand Azure Synapse Analytics as an analytics service on Azure in detail, right? And some of its architecture components. So powering this analytics service, a really limitless service, is a common data model layer that's built on top of Azure Data Lake Storage, right? Now, as I mentioned earlier, this is an optimized big data storage that allows you to process data and store the data in a hierarchical way and be able to process petabyte scale of data in a very fast and efficient way. To explore the data that you have brought into Azure Data Lake Storage, you have two types of runtime engines that you can use, a SQL engine as well as a Spark-based engine. So you get to query the data that is available in a MPP storage that you can use the SQL dedicated pools for. At the same time, all your big data processing, all your transformations as a data scientist, you can take advantage of Spark engine to run, let's say, your Python scripts and notebooks on top of the big data, and also combine it with the data that is available into the SQL pool. Now, with Azure Synapse Studio, all of data integration, data management, monitoring, and security come together, and you are able to implement an end-to-end analytics use case, right from ingestion of the data to transformation of data using both SQL and Spark capabilities to further creating visualization, right? Creating denormalized data sets or analytic data set, storing them in a MPP based SQL, dedicated SQL pool, and further taking advantage of that to create powerful visualizations and dashboard using Power BI, and all of this from within just one integrated development experience that's called Azure Synapse Studio. And I'm going to show you that, so hold on to it. But before we get there, let's also understand how is this service positioned with respect to some of the compete services that we have, right? And this is not the stats that I am showing you as a Microsoft employee. This is publicly available statistics that were, on the basis of the study or assessment done by a third-party system called third-party organization called GigaOM, and it is also available on their website, by the way. So basis the TPCH benchmark analysis that GigaOM did, here are the stats where less is better, right? So Azure Synapse Analytics for a given workload can be as fast as 14 times faster compared to Google's BigQuery, and it could also cost your customer 94% lesser price compared to some of the competitors. And also there is a comparison available with respect to Redshift and Snowflake, right? And like I mentioned, you can check these data on GigaOM website as well, or simply by searching it on any search engine. Okay, now what are some of the common scenario in the space of analytics and AI, right? So number one is you have customers who are looking to create a modern data warehouse, right? So they want to integrate all of their data, including big data, within the data warehouse. So there is a concept of just the data warehouse these days, right? People are creating a data warehouse and a data lake, wherein they will not only store the structured, relational, traditional data, but also bring together a lot of real-time unstructured data sources, as well as a lot of big data sources to be able to take advantage of both structured data as well as unstructured data coming in from various line of businesses. Advanced analytics, wherein we don't want to just create a descriptive analytics to understand what happened and why it happened, but we want to enable the customers to be able to predict, right? Do predictive analytics as to, okay, if this happened in history, this is what that can happen in a near future, right? And from that also go to a prescriptive analytics, right? So descriptive to predictive to prescriptive analytics, wherein you are able to process various data points that are coming from various data sources in real time to be able to make decisions in real time to help your customers achieve more. For example, product recommendation use cases, right? Or product placement use cases in the case of in case of retail customers. Or talk about a BFSI customer, it could be fraud detection, right? With the help of prescriptive analytics, you can identify accounts that may go default on their next credit card payment, right? Or identify transactions which are more likely to be fraudulent compared to others. So all of this real-time analytics. So these are at a high level some of the solution scenarios that we are seeing our customers are trying to solve for their respective industry. All right, so for the purpose of the demo today, and to show you the real art of possible with Azure Synapse Analytics, I'm taking an example of a fictitious customer, right? Let's say Wide World Importers is a fictitious customer in the retail domain, and they have hundreds of brick and mortar stores as well as an online store where they sell absolutely all sorts of merchandise and products. Now, what this customer would like to do is they want to gain business insights using historical data, real-time data, and do predictive analytics using structured and unstructured data. That's not all. They want to enable their business analysts to connect to various line of business applications and unify all their disparate customer data into a unified customer profile that gives you a 360-degree view of their customer to be able to make better decisions for the customer. They want to also enable their IT team of data engineers as well as data scientists to bring in and run complex queries over petabyte scale of structured and unstructured data and enterprise operational data. Now they also want to enable business analysts and IT team to share a single source of truth, right? And have a single workspace to be able to collaborate and work with enterprise data and enrich customer data. Now, how do they do that? So let's say we want to solve this business use case for this retail customer. Now let me show you with Synapse how the dashboard, like think of this as an end product to solve some of these analytics use cases that we just talked about, right? This is the end product that is created. Now this dashboard gives them complete insights into their historical data as well as real-time data, and also enables them to be able to predict for the future. How? Let's understand this. Okay, so on the left side, right, I have this campaign and social analytics that gives them data about the efficiency of various campaigns that they're running across their outlets. What is their marketing cost looks like, what is the total revenue, total number of customers, and some interesting insights into how their business is doing, right? The health of their business. Now, if you look at this net sales by fiscal year, now when a data engineer or data scientist is enabled with the help of this kind of dashboard to analyze the data, the insights that they are getting are their net sales is dropping every year over year for past 3 to 4 years, right? Till by the time this dashboard was created, from FY16 to FY19, their data or their net sales and revenue is falling. Now they want to understand and analyze this further to be able to figure out what are the causes of the fall in the net sales, right? And the data, bringing together data from different line of businesses, bringing together data from point of sales services, data from various operational data stores, at the same time combining that with a lot of data that let's say external data that allows you to enrich your customer data, allows them to solve these problems. We'll get into understanding that in detail. Now, and they also have a very intuitive visualization of different unique visitors and daily users by device category. So how many of them are visiting their website through mobile versus websites versus desktop and tablet. So a split between how their visitors on the online portal are accessing their website or mobile application. Now, in the middle, if you see, there is a real-time Twitter analytics. That means there is a real-time customer sentiments that are being captured. So how customers are feeling, whether it's whether they are tweeting good about a specific product, or whether what is the predominant or what is the dominant feeling of the customers that are making purchases online and offline. There is also real-time location analytics data that is coming in from the various IoT sensors that they have implemented across various brick and mortar stores, right? So for example, right now there is there are 4 stores that are open, and number of sensors that are sending the data, let's say, are 4, total number of visitors and average visit time. So these sensors are kind of trying to capture an average visit time, and there is a lot more that can be done. And product recommendation. So when your customers are visiting online and offline, how do you figure out what should be the right product recommendation for that customer, and what is the likelihood that if you place X product next to Y product, what is the likelihood of customer buying both, right, or increasing upsell and cross sell thereby. So these are the kind of use cases that this service allows you to solve. Right now, if you're looking at this dashboard, it looks very nice and savvy. So if you're imagining, it must take months of efforts to create this kind of projects. Not really. With Synapse Analytics, you can create, or you can shrink your timelines of creating analytics for your customer from months to weeks, and from weeks to days, literally. And as I show you the next part of the demo, you would realize that yes, Synapse does make it very easy and seamless to create this kind of visualization. Now that we have understood how that end products probably looks like, let's also understand a little bit more details about the Synapse workspace. So here I am. when you create Azure Synapse Workspace through Azure portal, this is where you will get, and when you log into that Synapse Workspace or open the Synapse Workspace, this is how it looks, right? Now, I'll spend some time in explaining to you about this workspace, right? And how it brings together a number of Azure services, right? To create an end-to-end or one-stop solution for all your analytics requirements. Now, let's start with this, right? So as you come to the home page or home tab here, right, you get some tiles that allow you to ingest data or explore and analyze or visualize, right? So let's click on ingest. Now, for those of you who are familiar with Azure Data Factory, you would know that this is nothing but a copy data pipeline that you use in Azure Data Factory to bring in data from various sources, right? And as you can see, there are built-in 90 plus data source connectors are available out of the box. Now, if I click on next, all I need to do is provide the details of my source data source and then configure, right? Provide connection string and all. So if I click on new connection over here, you would see that I can connect to a number of databases or data sources that are available. So let's say if my data is available in Cosmos DB, Azure Cosmos DB, I can just use this connector to connect to Cosmos DB and bring in that data. And that's not all. Even if I were to connect to a compute data source, let's say Google's BigQuery, I just need to type big and here Google's BigQuery, there is a ready-made connector available for that. Let's say I have SAP data sources from where I want to connect and bring in a lot of data. So I have ready-made connectors available. So be it SAP, Oracle, Netezza Teradata. So you name it and you will have all of your popular data sources for which you have a ready-made connector available in the Azure Data Factory or integrated within Synapse called Synapse Pipeline, right? So let's say all I need to do is create a source, then select the database within that source system, do quick configuration with respect to certain configuration with respect to allocating compute to that data pipeline as to how much compute it should use and what should be the degree of parallelism, etc. And then select the target system as to where I need to bring in that data. What is my target? Whether it is an ADLS Gen 2 data lake storage or whether it's a Synapse table, right? A structured relational table created within Synapse, a distributed table. And with few quick settings, I can create that data pipeline and then bring data from that source. So I have a number of such pipelines created. So I'll not create a new one for now. Okay, now let's go to Data Hub over here. All right. So like I was explaining the architecture, whenever you create a Synapse workspace, you also have a Azure Data Lake Gen 2 storage that is associated and that serves as a common data model layer, right? And I also told you that there is two types of runtime engines that is available, a SQL pool and a Spark pool, right? And even within the SQL pool, you have something called as dedicated SQL pool where you are provisioning certain compute capacity upfront for your workloads. And there is the other SQL pool that is called as serverless SQL pool that you can use for a lot of ad hoc analysis where you do not have to be upfront paying for using. So it's purely pay as you go and used for exploratory purposes, used to scale for unpredictable demands or workloads. So that's dedicated and serverless SQL pool. So if you look at here, right now I have certain queries that are available that I can run on this either on a SQL pool. So this SQL pool 001 is a dedicated SQL pool, and there is a built-in pool that's called serverless SQL pool, right? Similarly, I can show you how to connect to a Spark compute, but wait for that for a moment. Okay, now I wanted to show you that there is a ADLS Gen 2 data lake storage that is always associated with your Synapse workspace, right? So you can come to the Data Hub, and within the linked services, you will see that there is Azure Data Lake Storage Gen 2 that you have associated. And you can, through various data pipelines, you can bring in data into your Azure Data Lake Storage. Now I have, for the purpose of this demo, brought in data from n number of data sources here. So let's say there is some real-time data that is coming in, or batch data that is coming in from Twitter, right? Twitter feeds. And if I click on that, you will see that the Twitter data is coming in Parquet format. Now, if I want to explore this data within Synapse, right, all I need to do is right click on that. I get multiple options. I can either create a SQL script and select top 100 rows, or create an external table, or bulk load this data from this Parquet file into some other destination. Or I can also explore this data using Spark, right? So I can load that data into Spark data frame or create a new Spark table. But let's see what happens when we click on one of these options. So if I click this option, select top 100 rows, it has created an automatic in an automatic way a query for me, right? So I don't have to write any piece of code actually to explore the data that is available in my raw data lake, right? And as you can see, I was able to quickly query the data that is available, and then not just that, I can create quick visualizations on top of that. So if I click on chart over here, I can create different types of visualizations on this data. So line chart, bar chart, whatever makes sense for the kind of data that you are visualizing, and without having to write any piece of code or any data pipeline, right? So that's the beauty of Synapse Studio. Now let's understand further. Now this is Data Hub, right? That allows you to connect to various data sources. Now this is Develop Hub. Okay, so if you go to Develop Hub, here you can do 4 types of things, right? You can create SQL script that you will use the SQL engine to run on. You can create notebooks that you can run using the Spark engine. You can create mapping data flows or wrangling data flows, and you can also create Power BI. So essentially, anything that you need to be able to efficiently process the data, ingest the data and process the data, transform the data, and then visualize that data for end business users in the form of dashboards, all of what you can do within just one service that's called Azure Synapse Analytics, right? But at the same time, it gives you flexibility. Now, flexibility with respect to cost. For example, you have a customer that does not want, they are dealing with mostly structured data, but at a huge scale, right? But they do not want to process any big data or any unstructured data. Now, does that mean that by using Synapse they need to spend extra because Synapse also provide a Spark cluster? Not really. You only pay for what you use. So if you are not using data flows, you do not pay for that. If you are not using notebooks and Spark, you are not paying for that. So you are essentially paying only for what you use, although it gives you an ability to be able to scale very easily in future. So once you bring your data into Azure Data Lake Storage and start using Synapse, you can scale on demand, right? With respect to both structured and unstructured data, SQL and Spark engine, as well as use Power BI. So even Power BI licensing is kept independent. So you will be able to use Power BI to create very intuitive report right from within the Synapse, but it does not charge you for Power BI licenses out of the box. So if you are not keen to use Power BI, you will not be charged for this. So the costing is created very consciously to cater to all sorts of customers. Okay, now let's take a look at these one by one. Now SQL script, right? So let's try to run some SQL script, and let's also understand when we say this is a limitless service, right? And a performance service, let's see how its performance is. So I'm just running a count check on one of the tables, right? And let's see how many records that I have in this table called DBO_sales. Sorry, DBO.sales. So this is the table in which I have. Okay, looks like it ran the other query. Let me run this count check query again. Yeah, so if I look at the count of this table DBO.sales, you will see that it has 31 billion plus records, right? And it has quickly run that query in just about 4 seconds. Now, just imagine I am going to join this table having 31 billion records with a number of other tables. You can notice that DBO.sales is a driving table over here, right, with 31 billion records, and it is being used to join, inner join with products table, then left outer join with Twitter analytics data, and inner join with millennial customers. So number of tables being joined to that, plus I have some aggregate operations such as sum of the total amount, as well as group by clause. And if I run this query where the driving table has 31 billion records, just see how performant Synapse Analytics is. And as you can see, in a blink of a eye, right, within under 4 seconds, you already have the output of the query that has scanned 31 billion plus records and joined it with a number of other tables. The total amount that it took to completely run this query is 17 seconds to scan billions of records, right? 31 plus billion records. That's how efficient Synapse can make your analytics, right? Not just that, it also allows you to process differently structured data. So not just structured data, but also semi-structured JSON data. For example, let me show you this data. This is a JSON format data that I have in a table called Twitter data. If you notice, there are two columns. One is ID and the other column is simply a character blob, which has a JSON object stored within that. And there are a key value pairs that are stored, time and hashtag and others. So if I were to split this data, right, Synapse provides me an out-of-box capability to query the JSON data. So I can not only work with structured data, but also semi-structured and unstructured data in an efficient way, that too with an out-of-box capability that is available. And I don't have to write any Spark SQL here, right? I can use a very familiar SQL syntax and query the JSON data, right? Key value pairs within the JSON data. Now that's how you use SQL pool, right? Similarly, you can create different notebooks and you can run, attach a Spark compute to that. For example, if I open one of these, all I need to do is create a Spark cluster and attach a Spark cluster to that, right? And essentially, I can run my Python scripts or Spark notebooks from within Synapse Analytics. Now, as I mentioned, it allows you to be able to bring together all your resources, right? Business analysts, data engineers, data scientists. And the beauty of it is it allows you to create these data pipelines in two ways, both code first and code free. So if you are a tech savvy data scientist and prefer to write your own code within the notebook, you can do that. Or if you're a business analyst who is not so tech savvy, right, and you prefer to use GUI based capabilities to create a data pipeline, you can do that as well, right? For example, so that's the develop hub, right? Let me go to an integrate hub for a moment. So the next hub, this is where you create your data pipelines. So let's say this is one of the pipelines that I have created. This is SAP to ADLS, SAP HANA to ADLS. Essentially what we are doing in this pipeline is we are connecting to SAP HANA data source and bringing in that data, copying that data. And once the data is copied, we are processing this data by using a data flow. So if I double click on this data flow, this is nothing but a code-free data pipeline. So what I'm doing, I am simply using a GUI-based mechanism to create a code-free data pipeline. How do I create that? All I need to do is, let's say this is the source data. I can just go on clicking on this plus sign and keep adding various operations to this data pipeline, right? And these operations could be operations like filtering of the data or deriving new columns from the existing data. So schema modifier, format changes, or row modification operations, or adding a destination, right? Like I have added in the end. So let me quickly explain to you how this is structured. So essentially in this code-free data pipeline, what this business analyst is doing is bringing in data from SAP HANA data source, then filtering it for last 5 years and adding 2 more derived columns to it, 3 more derived columns. So from 26 total columns, now we are going to 29 total, additional columns. That means there are 3 derived columns that we have added. And at this point in time, he has forked the flow, right? So from this pipeline, from this data source, what I'm doing further is I'm selecting the columns that I'm interested in and loading it into a destination table in Azure Synapse. At the same time, in a parallel flow, what I'm doing is I'm doing some aggregates. So I'm selecting only 5 columns and then doing an aggregate on that to find total sales by year and month, and then load that data into a different table in Synapse. So all of that can happen in parallel, and I can do a lot of different intuitive transformations using code-free data pipelines. So coming back to Develop Hub, right? Let me also show you how easy it is to create intuitive visualization with Synapse. Now, let's say I'll show you this demo of a dashboard, Power BI dashboard that is created. And we also have a cognitive service called as Q&A, and it is natively integrated with embedded in Power BI that allows you to create very intuitive visualization just by typing in your requirement in human understandable language, right? So this is one of the visualization that is created. If I go to this Q&A, right, and if I just type in my requirements like a question, right? So let's say I want to create a visualization for profit. So as soon as I type profit, once my data sets are created, it gives me a visualization, right? So there is already a profit, 43 million. Let's say I want to understand profit by country. So if I do profit by country, I get a new visualization. Let's say I want to see this as a map. As you notice, I am just typing in my requirement and I am getting very beautiful visualizations the way I want to embed in my Power BI reports such as this, right? And that's why I say with Synapse, you can take your development time frame from months to weeks and weeks to years, right? Now you'll be able to realize that, yes, if I'm able to create this kind of visualization in such a quick fashion with Synapse, it will not be very difficult to create very polished dashboards like this in a quick time frame. So and if I further complicate this, right, so if I do by country, by product ID, let's say by product category, and as remap, so there are different visualization, as you can see, that that become possible in very few minutes. Now I know it's about time that I should finish, but I'll quickly take 2 more minutes and finish this, right? For example, now once you create these kind of visualizations, right, you can solve a lot of use cases, right, from descriptive to predictive to prescriptive analytics for your customers, wherein think of a use case where they want to analyze the performance of their campaigns, and this is based on the line of business data, campaign analytics data, as well as data coming in from Twitter. For example, when people were happily buying cocktail glasses, look at the sentiments, look at the popular hashtags. So you would see that this hashtag gets updated over here. So it says beach, cocktail with friends. And at the same time, if I see the sentiment for exercise, that was in red, right? So when I click on the exercise related category, it says too much of effort. So just imagine if we can, create this kind of visualization and data insights for our customer, they can really change how they do business. And one other example of this is, let's imagine that you have IoT sensors that are tracking movement of people within the brick and mortar store, right? And they are tracking this movement in every aisle of that brick and mortar store. And just imagine there are IoT sensors that are tracking the eyeball movement as well. So that tells you that when scrolling from left to right, people have spent more time towards the right section of this rack. That means you can then take advantage of this kind of data insights to make your product placement more efficient, right? And that is the art of possible in context of just the retail industry that I have explained in the limited time that I have, with Azure Synapse Analytics being the one-stop solution for all your analytics requirement, from ingestion all the way to analytics, visualization, and AI. So with that, I'll stop here, and happy to take if there are any questions.
That was absolutely great, Jayendra. I was just watching your session from behind the scenes. There's so much that you covered in just about 45 minutes. Talking about analytics, you did share one thing from your side, that is one source of truth. Right.
Yeah.
As a layman, I couldn't catch it. Can you please explain it to me?
Sure. So what happens, Simon, right? Simon. So you have, for example, a customer's data, right? Coming in from various data sources. So you have a customer that has some entity, or a customer ID X, right, and first name and last name that is coming from your point of sales service, right? Similarly, you may have the same customer's information in some other line of business, right? For example, think of a e-commerce service, right, who also provide, for example, Amazon or Flipkart of the world, right? They have various services. So they have a customer who is their retail customer, but the same customer may also be a customer of a video streaming service. The same customer could also be a customer of, let's say, a music streaming service or books related services. So there are various services or various businesses that an organization operates within. Now, it is important to be able to get a single source of truth, because sometimes when you bring in data from various data sources, it's very difficult to understand that which is the right record for the customer, or how do I make sure that for example, if one of the systems says this customer's age is 35 and the data coming in from other source is saying the customer's age is 45, so how do I choose which is the right source of truth, right? So this is where single source of truth helps you, because you are then analyzing different data sources. You are identifying that if it is age related attribute of my customer, then this is the right data source that I should look at as a golden source of this attribute. Or if it was some other attribute, then source X is not the most appropriate, source Y is the most appropriate source, so that I should take that attribute's information from source Y rather than source X. And that is how you end up creating a single source of truth for every customer record or every data element, for that matter, that you have in your system. And that helps you to create analytics and predictive and prescriptive analytics that is more accurate, because now you have created a single source of truth. That's the concept.
Wow. I feel the tools have become so advanced these days, and there's so much of data that we are processing, we are generating, and it needs to be processed. You did share a demo, Jayendra, where you were saying that, hey, these many count were done in just about in 3 seconds, right? And billions of it. But I never saw you doing anything around the computation. Did you create a compute store computation resource, or it came already with Azure Synapse? How does that work?
No, so actually, it would have been very difficult to show how do you create a Synapse workspace and do everything here within the 45 minutes. But yes, so when I created that Synapse workspace, I did create a compute engine, right?
Okay.
And I did associate that compute engine for my workload, so that I was able to, so that I didn't have to spend time and wait while that compute is created for me, because it takes, if not too much time, but it still takes 3-4 minutes, which can be very crucial given the paucity of the time for this kind of live sessions, right? And people might get bored as we just wait for compute to be created. So yes, there is compute associated with it, and that was created in advance in as part of the prep for the demo.
And I really love that the Power BI with Azure Synapse Analytics, I think they both work very nicely together. And I really enjoyed it. And to be honest, I just went to Microsoft 365 Developers Program, and I just signed in him that, hey, let's go ahead and at least explore Power BI maybe in next couple of weeks. So that was absolutely great, Jayendra. Really enjoyed hosting you. Any final thing you want to plug in before we move to the next session?
No, same here, and look forward. So first of all, thank you so much for the opportunity, Simon and team. I also enjoyed the session as much. So it was a great opportunity, and I look forward to doing much more with you guys. Thank you.
Yeah, we would love to host you, Jayendra. As I said, we do a lot of events, right? And a part of this is the 11 days event, and first 6 days event were streamed on Microsoft Developers YouTube channel, Learn TV, Channel 9. That's what we work very closely with Microsoft on that part. Yeah, we would love to host you back and see what you and your other team members are working on exciting projects. Having said that, thank you once again for accepting the invitation. Have a nice week ahead, and hope to see you soon, Jayendra. Bye.
You too. Thank you so much. Bye. Take care.
All right, that was absolutely great. Very crisp session. I would say I have hosted almost like people for 11 days, and I can go far and say this was a very crisp session coming from Jayendra, who is from India. I believe we should start hosting a little too many people from India now. We don't have many Indians, but it's time we take a quick break. After the quick break, we'll be back and we will have one session by our title sponsor, that is Stratis. Stratis is a blockchain platform. If you come from C# or .NET ecosystem and you want to build smart contracts, NFTs, then Stratis blockchain is a platform you should definitely explore. I'll take a minute break and then we'll be back to learn about on how you can build NFTs using Stratis SDK. Yeah, if I'm not wrong. Yeah.
Stratis as software developer, and in this presentation I will show you how to use NFTs with Stratis Unity SDK. This video will cover node setup, how to create a wallet, how to set up Unity with Stratis Unity SDK. Also we'll create a new wallet within Stratis Unity SDK and fund it. And after that, I'll show you how to deploy NFT contract, how to mint new NFTs, and how to transfer them between different addresses. So first thing that we need to do is to set up a Stratis node. Stratis node basically acts as an API provider for Stratis Unity SDK. Stratis Unity SDK itself is a non-custodial solution which allows end user, basically your player, in the game you're creating, to self-custody their own Stratis. The only thing that node is being used for is basically data provision, and also it helps user to propagate transactions. Transactions themselves are being created on the user side fully and signed with private key, which never leaves a user's device. So the first thing that you will need to do is to get the latest node. The latest node is at release 1.100. It contains all the Unity related features. So you'll need to sync this GitHub repository and switch to this branch. Once you do that, you basically can run the node and sync it. In order to do that, you need to run the node from Cirrus D directory. I use a simple script for that. Basically, you'll need to go to Cirrus D and then call .NET run with transaction index enabled and also address indexing enabled. And for this tutorial, we'll be using testnet, since it currently contains latest NFT version contract already whitelisted. And also you need to enable Unity API feature. When you enable it, you basically add additional port, which will run on your local host, and it will provide all the API methods that Unity SDK needs. For the sake of simplicity, in this tutorial, we will run everything on localhost, but in production environment, what you'll need to do is to run node on a server and also open 44336 port. This is the default port that is used for Unity API. So let's run our node. As you can see, I've already pre-synced the node and it's up to date. When you run the node for the first time, it will take quite some time in order for it to synchronize fully. So you should wait for the node to fully synchronize, and after that, if you want, you can just leave it like that, or if you want a wallet, you can create a new one. To create a new wallet, you basically need to, not this one, this one. You need to go to localhost 3823, and there is a Swagger which has all the API endpoints. So under the wallet, yeah, Under the wallet, you have create here. And if you want to create a new wallet, you just don't supply mnemonic. And then click execute. It will basically add a new wallet here. As you can see, I already have wallet with some T-strats. So after you create a test wallet, next thing that you will need to do is to get an unused address. Here you will supply wallet name and account. Account is always 0. And after you click execute, basically it will supply you first unused address, which you then can use to fund your T-strats or structs if you're running on mainnet. You can acquire Stratis on basically several exchanges, and for acquiring T-strats, you can write any Stratis developer, or you can use a faucet. So let's say you have fully synced your node. After that, we can open Unity and create a new project. And after that, we will add SDK. So let's create a new project. New Unity project. While the project is being created, we can get the latest Stratis Unity SDK. So you will need to go to github.com/Stratis project and get your SDK from Unity 3D integration repository. It's in resources, so download the repository and get this Unity package. Our new Unity project is created, and now we can proceed to importing Stratis Unity SDK. Let's click import package, custom package, and here we have version 2, so let's import everything in it. Now, once it's imported, you can see that there are some test scenes there which cover all the features in Unity 3D, in Stratis Unity 3D SDK. Basically, what we currently have is some examples where you can create a new wallet, add a mnemonic, generate new mnemonic, or recover wallet from previous mnemonic. You can check balances of your addresses. Actually, let me show it. So you need to run a node while doing that, because it will provide API. And here in the example scene, you are providing your API endpoint. If you click test and you have API test successful, it means everything working perfectly. Here you can generate new mnemonic. And or basically you can paste here your old mnemonic, which you already funded with some money. So when you click initialize, you can see that your Stratis address is generated, and you can see its current balance. Also, sending transactions is supported here, and sending op-return transaction is supported. Op-return transactions are basically transactions which generate UTXO which cannot be spent, in general, op-return transactions are used just to store some data on blockchain. So you can play around with that, and there are some other test scenes which cover smart contracts and some wrappers for smart contracts. Right now, there are 2 wrappers, one for NFT and another for standard token, which is basically our ERC20 version of token. But in this particular demo, I will show you how to work with NFTs. So let's open NFT example and go to scripts, open NFT example. I have prepared some code, but Here we will not just use everything as is. Instead, we will deploy new NFT and try to mint some, and also transfer NFTs between addresses. So, so let's see what's going on here. Basically, we're just creating two mnemonics, and from them we will later derive addresses. Those will be mnemonics for addresses between which we will transfer NFTs. It's important to mention that the address which is generated from this mnemonic is already pre-funded with some T-strats. If you want, you can use the same mnemonic, just don't drain it all, because other people might want to use it. But also what you can do is generate the address and then send some T-strat either from the faucet or from your wallet. So in case you have a wallet here, what you will have to do is transfer some of this money to your generated address in Stratis Unity SDK. And in order to do that, you will need to open Swagger and go under Wallet and click Create Transaction, Build Transaction. So you have all the information here. Basically, you don't need to provide operator data and data amount. Fee type would be 105. This is fine, this is fine. Change address, you don't need to supply that. You don't need to supply out points. Account name would be always account 0. Wallet name would be your wallet name. Password will be the password. You don't need to supply fee amount as long as you supply fee type. And also here in destination address, you will need to provide your address generated in Stratis Unity SDK. Destination script doesn't need to be supplied, and amount will be, let's say, 10 test Stratis. After that, you click execute, and after that, you click execute, and you will get hash for your transaction. After that, you click execute and you will get transaction hex. Then you will need to go to send transaction and provide this hex here and click execute. After that, transaction will be supplied to the mempool, and after it's added to the block, you will have those funds on your address in Stratis Unity SDK. And we're also creating a new network on Cirrus test. After that, we're generating first address for our mnemonic. This will be address which will be used for NFT contract deployment and minting. So here I already have NFT contract deployed, but for the sake of this tutorial, let's deploy a new one. So where is it? Deploy NFT. And before we run that, let's see what's inside. Basically, there is some parameters that you can specify. For example, NFT name and symbol for your NFT. And then we're using NFT wrapper class, which deploys smart contract. If we go inside and see what's there, basically wrapper will encode all the parameters that we supply to smart contract constructor, and then it will generate transaction and send it to our node. And when we do that, node will validate this transaction and then propagate for miners to mine this transaction. And once this transaction is mined, we'll have a deploy contract. So here, after we deploy, we have a transaction ID. And when we work with any smart contract, all the feedback from smart contract we can get from receipt. So to get a receipt, you first need to send a transaction which interacts with smart contract. And once this transaction is mined, you will know what is the result of your smart contract call or deployment. In this particular case, this code will wait until the transaction is mined, and then it will display a new contract address that we just deployed. So yeah, let's save it and run it in Unity. And now go to console. We can see that from our mnemonics, 2 addresses were generated. And then we created a contract deployment transaction. So if we go to the node, we can see that there is one transaction in the mempool. That's the transaction that we sent from Unity. And now let's wait until this transaction is mined. So as we can see, the transaction got mined and there is nothing in the mempool. And now in the logs, we have basically our new address. So let's copy this address and use it for our demo. What we are doing here is creating NFT wrapper with the address that with the smart contracts address that we just created. So here we're getting balances for 2 addresses that we have, and if everything is correct, we will see that both of those values will be 0. So let's display it. And now let's run it. So yeah, since we just generated our smart contract, none of those addresses have any NFTs. So what we would like to do right now is to mint some new NFTs. And let's say we don't want to mint just one, we want to mint 10 of them. So I'll add a for loop. And now let's run our code and wait until 10 transactions are sent and propagated. For the sake of saving your time, I'll just skip this process because it will take probably around 5 minutes, and just keep it in the video. Okay, now after we generated 10 NFTs, let's remove this logic and just display that we actually have our 10 NFTs. As we can see, we have 10 new minted NFTs. And also it's important to mention that every time when you mint NFT or transfer NFT from one address to another, an transfer event is being created. So to transfer NFTs between different addresses, you need to know NFT ID. It's pretty straightforward when you just created a new NFT contract because all the IDs start from 1. So your first NFT will have ID of 1 and fifth ID of 5. But when you receive your NFT and not minted yourself, or you have minted already several and you don't know what is the current ID is, what you will need to do is to get IDs for your NFTs from receipts, and for that we can use this method. Basically, you will need to receipt search and provide transfer log as an event name. Also, it's important to mention that Receipt search is a quite slow function, so when you just run it without from block, and let's say it's 0 by default, it will require Node to check all the logs from the first block and iterate all the logs, and it might take around a couple of minutes. So preferred way is to use block ID at which your contract was deployed and set it as a from block, or at least set from block slightly earlier than the contract deployment block, because otherwise it will take quite long. Also, if you are making a long-term solution, what you should probably do is to cache all the transfer receipts, and every time when you need to update data, you will move from block to the last block at which you requested this information. But for the sake of simplicity here, we'll just avoid using any caching mechanism, and what we're doing here is basically iterating all the receipts and then deserializing them into transfer event log. What it has is basically event name, from is the address from which NFT was moved, to is the address to which NFT was moved, and token ID is the ID that we will need to use in order to do anything with this NFT. You need your token ID in order to transfer it anywhere, and also in order for it to be burned. So let's call this function just to see that it actually displays all the transfers. So if we open this log, we can see that all our minted tokens were deposited to our first address, which is the owner of the contract. And we have IDs from 1 to 10. All right, now let's transfer some NFTs between two different addresses. So to do that, we basically need to call transfer from and specify address which holds some NFTs, specify address to which we would like to deposit our NFT, and token ID. As we've seen before, we currently have IDs from 1 to 10. So let's transfer our first token to second address and then basically display how many NFTs each address has. So let's start it. No, I didn't save it. Sorry about that. So let's start it. And let's wait while transfer is being completed. Oh, it's completed already, and we see that second address got 1 NFT. So now let's try to send second token, and it will be pretty much the same after that. Second address should have 2 NFTs, and first address should have 8. Yeah, now we can see that everything is correct. And of course, we can transfer NFT back from second address to first address. And we also can burn our NFT. So let's say that we would like to burn one of the NFTs that we transferred. So we call burn a thing, and let's say the token ID is 2. Let's await. We don't know. We don't need that. Yeah, but we need to display those. So let's burn it. Let's wait until burn is completed. So for that, we'll wait for burn ID. And now let's see if we can actually burn an NFT. So we can see that in total we have 10 NFTs, and after the burn, we should have 7 NFTs for the first address and still 2 NFTs for the second. So let's see if this happens. And yeah, as we can see, we just burned 1 NFT. So this is it. Thank you very much for watching. I hope it was helpful for you, and I hope that you will try it out yourself. Also, in case while trying it out you encounter some problems with it, you can always write to support channel on Stratis Discord or write me directly.
All right, so you saw a session by Stratis. So we couldn't play the other day, so luckily we could play today. It was how you can build NFTs using Unity SDK by Stratis. You now watch once again a session by Stratis, that is our title sponsor, on how you can build NFTs using the Stratis SDK. So enjoy your rest another 20 minutes.
My name is Rowan DeHaas, and today I'm going to be talking about deploying Stratis Smart Contract infrastructure to Azure Container Instances. I'm going to walk you through a bit of a demonstration about creating an NFT smart contract and deploying that to a Stratis blockchain. And then we'll create a microservice that combines the two different elements, an API backend that exposes information about our NFT that we've just created, and a Stratis node that provides this information directly to our API backend from the Stratis blockchain. So let's get started on this in just a second, but before we do, let me tell you a bit more about myself. I am a C# developer, and I really love the language, the tools, and the community and the ecosystem that surround C# and .NET. So I've been working with C# for a long time in an enterprise context until around the year 2018, when I became interested in blockchain and smart contract development. Now, at the time, there were no C#-based blockchains, and there was no way to write a smart contract in C#. There were definitely no .NET blockchain tools. So I pretty quickly discovered Stratis and their goals of building a blockchain node in C#. And I eventually ended up joining the team who built the Stratis Smart Contract Platform module for the .NET Full node. Eventually, I was able to realize my goal of being able to write a smart contract in C#. So the Stratis platform itself is an open source blockchain that's written entirely in C#. And by design, it is modular and extensible, and it allows different blockchain components to be connected together in whatever ways a developer desires. It could also be thought of as a blockchain SDK, where you can kind of pick and choose different consensus algorithms, different databases and storage mechanisms. And then on top of that, you can add features like smart contracts to come up with entirely new blockchain configurations. So the software behind the Stratis platform is used to power several public permissionless blockchain networks. The first of these is the Strax network, which is the original network that's secured by proof-of-stake consensus. And the second of these is the Cirrus network, which is a sidechain to the Stratis network and capable of running smart contracts and is secured by proof-of-authority consensus. There are also testnet variants for these networks, which are places where you can play around with the Stratis blockchain without using real funds. So whenever I refer to the blockchain in this presentation, I'll be talking about the Cirrus test network, which is where we will be deploying our NFT smart contract. So let's get started creating our NFT, and it might help to have some context on what an NFT is. So I'll run through a brief overview of that now with a couple of examples. So right now, a digital art craze is sweeping through the world, and we have artists, developers, and even auction houses creating and trading unique digital art, and it's all being done through NFTs. The technology that makes NFTs possible is smart contracts. So almost everyone who has used the internet would have seen this image at some point. This is the Nyan cat, and the Nyan cat was recently turned into an NFT by its original creator, artist Chris Torres. But what exactly is an NFT? Well, the letters NFT stand for non-fungible token. And by now, everyone's probably familiar with the concept of a cryptocurrency token. Ordinarily, when you own a token, it has no particular identity attached to it, and it could be swapped with any other token of the same kind. You own the token, but you don't really care which particular one it is. And this property is called fungibility. So when something is not fungible, it has its own unique identity. For example, consider a rare painting, something like a rare Picasso. Because only one copy of this rare painting exists, it can't be interchanged with another painting. So due to its uniqueness and rareness, it is non-fungible. And we can extend this concept into the crypto space too, by creating tokens that have their own unique identity. And these tokens can represent many things. Things in the real world such as real estate, or even things in the digital world such as art. So it might help to think of NFTs in this sense as digital collectibles. All right, so hopefully with that background of what an NFT is, we're ready to kick off our walkthrough. So we'll start by creating our own NFT smart contract, and then we'll create our microservice and we'll deploy it onto Azure. Okay, so inspired by the Nyan cat, I present to you this piece of digital art, the Ninja Cat. And shout out to the artists who created Ninja Cat for the Paint 3D software, because I have borrowed this sticker from Paint 3D. It is not an original. I am unfortunately not that artistically inclined, but I do want to turn this Ninja Cat image into an NFT and publish it on a blockchain. I've created a small piece of metadata to describe the NFT. It contains the name and the description of the image, as well as a reference to the URL where the image file is stored online. And it's a reference to this metadata file that will be permanently deployed on the blockchain. So the reference will be immutably deployed somewhere where anyone who wants to verify that the Ninja Cat image belongs to the NFT contract can look up this metadata and see exactly where it is stored. I've uploaded the image of Ninja Cat and the NFT metadata to Azure Blob Storage. This data now exists somewhere where I know it will be redundantly stored and geographically distributed so that it can exist indefinitely. And I set the blob access permissions to anonymous read-only access so that anyone else is also able to view the image and the metadata. So now that we've published our image and our NFT metadata, we can start to deploy our NFT smart contract to the blockchain. I flicked over to Visual Studio Code now, where we can see a JSON file that contains all the information we need for deploying our NFT to the Stratis smart contracts network. Down the bottom of the file, we have the code of our NFT smart contract, which is raw C# IL bytecode that has been encoded into hexadecimal. And next, we have the parameters for our deployment, which includes the name of our NFT symbol, and the reference to the metadata, which we just uploaded to Azure Blob Storage. So I'm going to copy all this and then paste it into the smart contract deployment endpoint of the Stratis full node. And the endpoint we want is this one here for building and publishing smart contract creation transactions directly to the blockchain. So I'll paste that in there and broadcast that transaction. And what we expect to get back is a result that contains the address of the NFT contract that's just been deployed to the blockchain. If I copy this address and scroll up a bit, we can use another endpoint to check that the code exists at this address. And what we should expect to see here is some, maybe the transaction hasn't been mined yet. So let's just wait a second for that to happen. Could take 1 or 2 attempts. And there we go. So what we see here is the name of the token that we've just deployed, the name of the type. And then we see the raw C# bytecode in hexadecimal format. But we can also see the decompiled C# of our NFT token smart contract. So that's our deployed NFT token. So now that we've deployed our NFT and we know that this information exists on a decentralized public blockchain, we want to be able to share this information with others, for example, in a UI front end. But how do we do that? Well, one way would be to have our users run their own instance of a blockchain node, which they can then connect to our UI. But that isn't always practical. Not everyone has the time or the resources to set up and synchronize a full blockchain node. And this stops being a viable approach entirely when taking mobile devices such as smartphones and tablets into account. But there is a solution. We can do the heavy lifting for our users, and we can make our NFT information accessible via a REST API. To do this, we will need to host both the blockchain node and the REST API. But luckily, this is really easy using Azure Container Instances. We can deploy our NFT microservice to production with just one very simple configuration file. And another great thing is that we can commit this configuration file directly into our repo so that we can share it with our team. In that way, our microservice configuration becomes code. Now let's take a look at how this can be done. So I flicked over to Visual Studio now. We can have a very quick look at our NFT REST API implementation. I started by implementing a basic controller which will return details about an NFT at a specific contract address. The way it does this is by directly querying an instance of a Stratis blockchain node to get details we want to show in our API. And that happens in this method here, get NFT details async. Let's click into that method and have a closer look. This method will send off several requests to the blockchain node to query the name, the symbol, and the owner of the NFT. And it will then compile those into a single view model, which will be returned as a JSON object through our controller. So let's have a look at this in action by running the solution on my local machine. And I'm already running a copy of the Stratis blockchain node locally, so all requests will just go there. So here we have our API endpoint. It's working okay. What I can do is append our address of our NFT token contract to the end. We expect to get some details back. And we can see that we've got our NFT name, Ninja Cat, and then we've got our symbol and the owner, which is my wallet address. So the next step will be to deploy this little microservice to Azure Container Instances. So there's two components to the backend microservice, and we just saw the first one, which is the NFT API. And the second part is Stratis blockchain full node. So ideally, we want to have Docker containers for each of these services so that we can bundle them together into a multi-container group that runs on Azure. So next, we need to create a Docker image for our NFT API. So when I created this project, Visual Studio kindly and automatically created a Docker file for me. So all we have to do is check this out, make sure it looks okay, and then build and publish it to an Azure Container Registry. But before we can publish it to the registry, we need to create the registry. So we can do that using the Azure command line interface. So let's have a look at how that is done. So we're going to use the command line to interact with Azure via the Azure command line interface. Now let's create a container registry where we can push our Docker image. And we'll use this command as ACR create, and we'll specify a name, a resource group, and an SKU, and let that run. And when it finishes running, we will have created a private place where we can publish our Docker image. So it looks like our registry is being created successfully. We can check that in the Azure portal. Click on refresh in our container registries page, and we can see the Stratis API registry has been created. So now that we've got our registry, we can begin pushing our Docker image there. Let's flick back to our console window, and then we need to push our NFT API image to the registry. But before we can do that, we have to log in to the registry. And I always forget this step, but it's crucial. So make sure you log in. And once we've done that, we can start to build our Docker file. So the login has completed, and I'll just copy paste this command to build our image. Paste that in there, and this shouldn't take very long because everything is already cached on my local machine. There we go. One thing you will notice is that we have to give the image a tag, and we have to include our image registry name in the tag so that it knows where to go when we run our push. Container group in Azure Container Instances. And it's really quite nice and powerful to be able to define these things in code and share this code with other developers in our team, or with our clients and other users of our software. Okay, so next let's take a look at how to get this all set up and running on Azure Container Instances. So we have our multi-container group configuration file, and we can deploy it from the command line again. So I'll just flick to the command line again. And let's quickly check that we're in the same folder. There we can see our deploy ACI configuration file. And to deploy it, we just need to run a single command as container create. We'll specify our resource group. We'll specify the file name. And kick that off. And while this is running, it will be creating our container group and deploying 2 containers within that group. The first container will be our Stratis blockchain node, and the second will be our NFT API. It looks like they've just deployed successfully. So let's open up the Azure portal and have a look. First, we'll browse to our resource group, look for our container instances. And our first container is visible in the settings. We can view both our containers actually. So our first one is the blockchain node that we created. So let's click into that and have a look at the logs. It looks like blocks are being downloaded, so everything seems to be running as expected. And our second is our API. Let's have a look at the logs for that. And that also seems to be running fine. So what we can do is we can go over back to our overview page, and we can grab the IP address of our container instances and copy that into the clipboard. And then let's fire up a new window, and we can navigate to our endpoint where we expect to see an OK response from our NFT web app. Okay, so looks like that's working fine. So what happens when we navigate here is that we make a request to port 80, which is then forwarded to our NFT API container, which has exposed ports 80 and 8080 to the public internet. And now it's able to serve up data from our NFT smart contract directly from the blockchain. All we need to do is plug in the address of the contract we created earlier. So let's paste that in there, and we can see the information about our NFT. We've got its name, Ninja Cat, its symbol, and we've got our owner, which is my address. And then what we could do from here is we could take this API microservice that we've created and integrate it into a front-end decentralized application, or DApp, or let other people use it to build their own products on top of. So just to recap everything we've done today, which is quite a lot, we have created this magnificent piece of digital art, Ninja Cat, and then we've turned Ninja Cat into a digital collectible and published the image and the metadata about it to Azure Blob Storage, where we know it will exist as long as we want it to. Then we've created an NFT smart contract which contains a reference to this metadata, and we've published this NFT to the Stratis blockchain. And so that we're easily able to view information and share information about our NFT and consume it with other applications or UIs, we've written a small microservice to obtain that NFT data directly from a blockchain instance that we host. And we've done this by creating a multi-container group using a very simple configuration file, which we then deployed to Azure Container Instances. So I hope this has been entertaining and really shown you the power of Azure and Azure Container Instances. It's super easy to set up, deploy, and share new kinds of infrastructure that's easily reproducible for both your team and your customers. All you need to do is share with people a couple of configuration files and they can replicate it themselves. Thank you for listening, and feel free to jump on the Stratis platform website where you can drop us an email with any questions. Or you can find all the links to our social media platforms where you can stay in touch and follow what we're up to.
I played the transition for 2 times. Okay, right. So I hope you learned something new. This was a session by our title sponsor, Stratis. If you're someone who works in the field of C# and .NET and want to build some blockchain application, that is some Stratis, some smart contracts or NFTs, definitely go ahead and check out the Stratis platform. You just need to know C# and .NET. So having said that, we move to our next session. Our next session is by Pragati Jain. She's a Microsoft MVP for data platform and a data analyst, and she's going to talk about very interesting topic, that is data science made easier with Azure Machine Learning Studio and Power BI. So without any further ado, let's I'm messing up today. Let's bring her in. Hi Pragati, welcome to Cloud Summit 2021.
Hi, Simon. Yeah, I'm glad to be here. Can you hear me properly?
Yeah, I can hear you loud and clear, Pragati. Quick question, where are you joining us today from?
Oh, so I'm joining you from London today.
Wow, London. We have had quite a few people from Europe. The last 3 days has only been Germany, and the moment the people from Germany join in, the entire comment is full of beers and waffles. Let's see what happens.
Oh, yeah. I think the Oktoberfest is coming in Germany. I'm not sure they're doing it or not, but definitely October is like a celebrating month for the people in Germany.
Yeah. So Pragati, I won't take much of time. Azure Machine Learning Studio and Power BI sounds very, very great together. I see you already sharing your screen. Once you move to the other slides, I'll add it to the stream. Yeah, I have added your screen to the stream. Maybe you want to click on that hide, StreamYard's hide, it will take it away.
Oh, yeah. Yeah,
perfect.
Thanks.
So everybody can see your screen, Pragati, and next 45 minutes is all yours.
Thank you. Thanks, Simon. So yeah, welcome everyone today for my session organized by Cloud Summit, which is more Azure focused. But yeah, thank you so much for everyone taking out time. So today I'm delivering a session on data science, how you can make data science easier with Azure Machine Learning Studio. So this is basically a beginner level session. So I'll be, just talking like how you can, quickly create a simple machine learning model quickly in Azure Machine Learning Studio environment. So before I start the session, I'll just like to give a little introduction about myself. So hello, everyone. My name is Pragati Jain, and I'm a Microsoft Data Platform MVP. I'm also one of the super user at Microsoft Power BI community. So if any of you guys are on Microsoft Power BI community, you'll see me, actively helping others with the Power BI related queries on the forum. Then I've got nearly 10 plus years of industry experience, and I'm working into analytics industry from last few years, and currently I'm working as a senior data analyst at Trustpilot here in London. One fun fact about me is like I'm a painter, and I just like to proudly call myself a techie artist. And any of you guys, if you want to connect with me on social platform, then I've got my own blogging website, datavibe.co.uk. I'm on LinkedIn, I'm on Twitter, and I've even included my Microsoft Power BI community handle here. So before we start the session, this I do in all of my session. I just like to, tell my audience in the starting, what we are going to cover in this 45 minutes of session. So let's see what all things we'll be covering. So for today's agenda, I'll start with giving a little introduction on what Azure Machine Learning Studio is. And then, further down the line, we'll start with, creating a no code predictive algorithm. Yes, no code. So you'll not need to code a little bit of, you don't need any coding basically to create your first machine learning model using Azure ML Studio. Then further, what we'll do in the process is we'll start with importing a sample data set. We'll try to explore the data set, and then, we'll follow all the steps that are required in creating that or building that machine learning algorithm. Then in the end, I'll also share a few resources which I really found useful as a beginner to get started with Azure Machine Learning Studio environment. And then in the end, if there are any questions, I'll be happy to take any Q&A. So yeah, without waiting any further, let's just crack on and start with the session. Okay, so first thing, whoever here, I think most of you must be knowing what Azure ML Studio is, but suppose if any of you guys you are hearing this term for the first time, what is Azure Machine Learning Studio? Now, in a simple layman terms, Azure Machine Learning Studio is basically a cloud platform, which basically gives you a capability to create a low code and no code options for creating a machine learning algorithm. So yes, when I say no code, it means no code. You don't need to write a single line of code using any language like Python or R. You can basically, simply drag and drop your nodes in the designer mode and, come up with a basic machine learning algorithm quickly in Azure. So why Azure Machine Learning Studio? So for me, the first thing was, as a beginner, it's quite easy to use. As I said, it's a no code way. It gives you a capability to create a no code way of writing your machine learning algorithm. Then second thing, what I just mentioned, it's a drag and drop interface. So when I'll be showing you things practically in Azure Machine Learning Studio, you'll understand why it is a drag and drop interface. So basically you can just bring in different nodes and, drag them on a canvas and then, just connect them with the data and get your machine learning model building. Then obviously, if you guys are coming from data science background, then obviously this will be very easy for you, because if you already know the data science concepts behind, how the machine learning algorithms work or how you create them from starting and all the steps involved in creating or building this machine learning algorithm, then it will be easy for you to work on Azure ML Studio. But for people who are, just want to start with Azure Machine Learning Studio, I would say knowing some basic principles around data science concepts will really help, because it's very important to at least understand the steps required in building a machine learning algorithm. So that is basically something that is covered into data science basic concepts. So I'll also share some resources. So, if anyone really wants to go and read about data science, then at a beginner level, then, those resources can really help you. And the other thing is, I would say Azure Machine Learning Studio, as per my experience, it's just not designed for data scientists. People like me who just want to explore their data and, just try to understand the different data points involved in the data, then Azure Machine Learning Studio is for you. Even the data analysts like us can use Azure Machine Learning Studio to get some, initial understanding of the data. And obviously, as I mentioned, Azure Machine Learning Studio is a web portal or it's a cloud service, right? So you can basically access it from everywhere, and obviously it's in cloud, so it is easily accessible as scalable as well. So yeah, let's go to the next thing. Okay, so first thing, when you say Azure Machine Learning Studio or Azure environment, the first thing you need to do is you need to get an Azure subscription, because if you don't have an active subscription, you won't be able to do anything. So the first thing what you do is you need to create an Azure account. I've included the link here. So once you go to this link, it will just take you to this page. And from here, you need to, create a free Azure account. Okay. And once that account is created, then there are multiple options given. When you log in with an Azure account, you can basically go for a free account, which gives you like 12 months of free services, and it gives you Azure credit worth of USD $200. But suppose if you want to go for paid service with Azure, then it's good, because the best part of Azure subscription is you pay for only what you use. So it provides you a pay as you go service. So you don't need to pay for the entire stuff. If you just want to use machine learning area, you can actually pay for just that. And if you just want to explore some other coding kind of stuff like Databricks and notebook stuff, then you can pay for them. So basically, in that way, Azure is very flexible. It gives you pay as you go service. So you pay only for what you use, not for everything. Then the other thing is, once you get your Azure account set up and your subscription set up, the first thing you do is you create a machine learning workspace. Now, in this session, we are trying to explore the machine learning bit of Azure. So obviously, you need to create an area, where you can start bringing in your data, play around with it, explore it, or create your machine learning algorithm on top of it. So you need to create or define a workspace where you can do all kind of machine learning activities on top of it. Then the other part, what you need to do is you need to create some kind of compute instances or compute clusters. Now, what compute instances and compute clusters give you is basically just consider them as a virtual machine. Now, especially when you're starting as a beginner, you really don't know, right, what all things you need set up in advance to start building your machine learning algorithm, right? Because we haven't worked in that domain for long. So we don't know every technical information which is used in the backend to create that model, right? So what Azure gives is, it gives you that capability to just create a VM, which is like a compute machine or compute VM. And it has got all the, capabilities or pre-installed things for you to just get started with it. So basically, it has got all the pre-installed libraries or applications, on top of it, you can just start with your machine learning work. So that's why you really need to create a compute instance or compute cluster. Now, there is kind of a difference between compute instance and compute cluster, but I would define that, once we start seeing this practically in Azure environment. Okay, so now as we know a little bit about what Azure Machine Learning Studio is, how to get started with, then just let's start with creating a simple machine learning model. Now, to start with, as I said, you'll need to have an Azure subscription and an Azure account, which we saw earlier. So once we have that in place, then we need to create an environment or workspace on top of which we are going to build a machine learning model, right? So let's start with doing that. Okay, so once you guys have a proper Azure account set up, and you've got a proper running active subscription, and when you log into Azure, that is portal.azure.com, then you will see something like this, which this is kind of a home screen when you just log in the starting, and it kind of tells you what kind of subscription you're having. So if you go to the subscription, you can actually see details around it. Like, for example, I don't have a free subscription, but I've got a paid one. So I actually bought a monthly Azure plan where, I can just do the exploratory kind of work, explore different services in Azure. So I just got the basic one for the month. And, it kind of tells you like, how much you're using and how much you'll be using in future. So it basically kind of creates a forecasting as well based on the usage you are doing, right, in your Azure environment. So that's the subscription that will come up in your home screen. Now, the first thing, as I mentioned, we need to create a workspace or environment on top of which we'll be building a machine learning algorithm. So for that, the process what you follow is, on the top, there's something like create a resource. Once you click on create resource, you can create different kinds of resources, okay? But for this session, we are focusing on the machine learning. So we want to create a machine learning resource. So just search for machine learning, hit enter. It will end up showing you something like this, okay? So it shows you all the different types of resources you can create related to machine learning. But for us to explore whatever we want to do in this session, we need this one. So just click on that and click create. So just hit on that and click create. Now, once you click create, a new window basically opens. Now, it kind of gives you basic information like what subscription you're working with. So mine is Azure subscription 1. If you have a different name of the subscription, then that will appear on your Azure account. It has got some other information like what region I have got my Azure account and other stuff. Now, the first thing what you do is you give a resource group name. So you can create a new one. So like, for example, I'll just create a resource test. Okay. And I'll just click OK. Now, once I create a resource, I need to give a workspace name as well. As I mentioned, we need an area, right, to play around with the machine learning things here. So my workspace name could be, so you can give any name. I mean, I'm just giving like as a test workspace here. So that's my workspace test. And yeah, leave all the other details there. You don't need to change them because they are by default, taken based on the kind of subscription you have got for Azure. So just don't bother about them. Just leave them like that. And once you hit review and create, what Azure is doing, it's basically, trying to validate the information you have given. Okay. So as you see, it says validation pass. So whatever details you give, that match. Okay. That work fine. They're validated. And once you hit create, it will create the machine learning resource and workspace for you. Now, I'm not hitting create. The reason is once you hit create, it takes near about 3-4 minutes to get it created. That's why what I did was I created a resource and workspace in advance for the session. So when I go back to my home, you can see I've got a resource and workspace already created for this session. So once you get your workspace created, you come back to your home section and you can see that it's created here. Now, if you go into that, it gives you something like Launch Studio. So now once you create that machine learning workspace, you need to enter into that area, right? So to enter into that area or launch that area or activate that area, you can just, click on Launch Studio. So once you click on Launch Studio, it opens a new window. Okay. Now this is what Azure Machine Learning Studio is. This is the home window for it. Now if you see at the top, you can clearly see, like, if you're looking a good way to create a machine learning model, then you can use any of these ways. Now in Machine Learning Studio, if you see, there are 3 different ways you can use to create your machine learning model. Now, if you see the left one, which is notebooks. Okay, I'm just talking about the default views here. I'm not creating anything new because I just want you to give an overview, like what is already available for you to, create machine learning algorithms in Azure. So that's why we'll be exploring only the defaulted ones. Okay. Okay. Now, if you see the first way is notebooks. Now, this option, if you remember in the starting, I said like Azure ML Studio gives you a low code and the no code way to create your machine learning models, right? So this notebook section, which you see here, it is a low code environment using which you can create your machine learning algorithm. Now, the second one is automated ML. Now, automated ML is more around, so in this environment, there are already some pre-created machine learning. And if you use this automated ML, you can basically just put in your raw data, connect to that already pre-created trained model and get some outputs based on that. So that is what automated ML is, and how Microsoft has designed it. Like when you get a data set as input, then Azure tries to run all the available models on that certain data set and then tries to give you prediction against all the models it has executed for you on the data set. And in the end, it will try to come up with the best prediction made by the best model which has worked on this data set. So that's what automated ML is. And third one is the designer one. Now, this is the area which we'll be seeing today in this session. Now, designer area, as I said, it's more like drag and drop interface. So you just need to get your data, do some preparation or transformations on it, connect it with the actual model, what you're trying to run, and, just build and evaluate your model in the end. So this is the area we'll be exploring today. Now, before we go into that, dragging and dropping stuff, we need to create or prepare ourselves so that, we can run some machine learning algorithm. Now, as I mentioned, once you have a proper workspace, we already have a machine learning workspace on top of which we can build our models. But before that, we need to create some kind of computations. Now, why we need computations? computations are required to handle any kind of, calculations going on within your model. Now, by calculations, it could be like when you create a machine learning model, you train your data and test your data. So training and testing require some computations or calculations in the background, right? So that's why you need to create a compute instance, a compute cluster to handle those kind of calculations, right? So for that, we'll first create some compute instances. So for that, what you can do, on the left ribbon, there's something called compute. Click on that. Okay, now I have already created compute instance in advance, but I'll definitely show you how to do that. Okay, so once you need to create, once you are on this window, you need to hit new. Click on the new button and a new window appears. Now this asks you some information regarding what kind of compute instance you want to create. Now the first thing it asks is compute name. Let's give like test compute instance. Okay. And location is by default where your Azure subscription resides. Then we'll use the normal machine type as CPU. The reason, the first thing is we are just going to do some lightweight processing today. We are not bringing in like a very big data or training a huge machine learning algorithm. So what we want is we just want the basic VM for us so that, it can handle just some basic kind of calculations. So I'll be using a CPU rather than GPU. Then my virtual machine size, I'll be using this memory optimized one. The reason why I'm using this is because we are going to do some lightweight calculations or, model building or model predictions. We are not doing any heavy calculations. So this is the best one. And obviously it is the memory optimized one as well. So, it can handle calculations in a more optimized way. And also you can see a cost against it. So what this cost is saying is if you do anything on top of this instance, you'll be charged for it. So it kind of shows you a cost here, like how much you'll get charged for every hour. So I'm going to choose this standard VM. Then once I hit create, it will start creating that instance for me. Okay. Now let it create the instance. That's fine. What I'll do is I'll just restart my existing compute instance. So we have it quickly. Okay, so it's starting my the previously created compute instance as well. So you have got a compute instance in place. Now the next thing what we need to create is we need to create a compute cluster as well. So for that, take the same process. Okay, now, as I said, a difference between compute instance and compute cluster, which I didn't set previously. Now, compute instance, as I said, it's a basic VM, gives you like predefined environment to create some machine learning algorithm and handle all the computations involved in that model building. Now, why you may need a compute cluster? Now, as the name says, cluster. Now, clusters are, capable of handling complex kind of computations, and, they can handle those computations in parallel. So basically, they're good for parallel processing, or if you're, dealing with like very huge amount of data, or you're trying to run like multiple machine learning algorithm on a single data set, then, it's good to create a cluster. So, it can handle those multiple calculations in parallel and, can give you just, predictions within no time rather than taking a lot of time to do all the calculations and then giving you results. So that's why you need a cluster. So what I'm doing is I'll be just creating a dedicated capacity cluster because, as I said, I mean, I'm not going to be changing much of the options. We are going with the default ones. And I'll be using a CPU because, as I mentioned, we are not doing heavy processing. And then again, I'll be choosing the memory optimized one VM here. And I'll just hit next. Once I hit next, the compute cluster window asks you a name. So you can again give a proper name. Now I have already created it, so I won't be creating it again. Okay, and yeah, minimum number of nodes could be 0, maximum you can put to 2. But yeah, this depends completely on, what kind of or what level of complex calculations you're going to handle in this machine learning studio. So, nodes can be, if you want to go up to 5, it can go up to 5, 6, however you want it to be. But I'm just going with the basic one because I'm not running heavy processing here. And once you hit create, a compute cluster is created within few minutes. So I'll not be hitting that create. because I've already got my compute cluster created here. Let's just see if my instance just started. Okay, it's starting. Let's just wait for a few more seconds. And let's just go back to the deck if we have, missed anything. Okay, so in a way, we have got an environment set up on top of which now we can, just start building our model. So we have got our resource in place. We have got our workspace in place. We have got the compute targets in place. Now, compute targets are what we just created, compute instance and compute cluster. So we have already got a pre-built VM on top of which we can now, build our model. This is just showing you the options, as the basic options you need to use for creating compute instance and compute cluster, which I just showed you in Azure. And yeah, let's go to the next step and let's see if our compute instance has started. Okay, it's taking a little bit of time. I'll just do one thing. I'll, just delete this, the one which we just created, because I already have a compute instance, so I just don't want it there. So let's wait for it to start. We have got this. Okay. Sometimes it takes time. So yeah, sometimes you'll have to wait for some time to get this running up. But yeah, it can happen. Now, once your compute instances are in place, okay, then the first thing what we do is we create a pipeline to, okay, compute my instance is running now. Perfect. Okay, we have got it running. That's good. Now, the next step, what you do once you have got all your environment set up, your VM set up for creating your machine learning model, the first thing you do is you create a pipeline. Now, pipeline is basically just a kind of experiment you create against your individual machine learning model. So for that, what you do is, again, on the left, there's something called pipelines. Click on the pipelines, and you end up with this window. Now, I already have something that I ran in the morning. But yeah, if you want to create a new pipeline, you can go to new pipeline, click on it. And once you create or hit the new pipeline, Azure asks you to link it to your compute target. Okay, now your compute target could be instance or cluster, anything. So you need to select that on the right. Okay, so what I'll do is I'll be selecting a compute cluster. And I'll select the cluster which is already running up for me. So I'll do that. Once that is done, you can give a name to your pipeline as well. Okay. So first thing, before giving a name to the pipeline, just to give you like what kind of data we'll be using today, right? So today what we'll be doing, we'll be just seeing a sample data set already provided within Azure environment. And that data set is based on automobile pricing. Now I'll show you what that data is about. So what we'll do is we'll just name this pipeline something relevant to what you're trying to do, right? So this is basically automobile predictions, or you can give it any name. Okay, I've just given it automobile prediction. Now, once that is in place, let's see what data we'll be using, right? So I'll just go to sample. Okay, before doing that, I'll just give you what these things are here in Azure. Now, there is something called sample data sets already in this area. Now, these are the pre-ready data sets for you, which you can directly use to create your machine learning model. And today we'll be using one of these sample data sets. Okay, so this is what sample data set section comes. And then other sections, what you can see here, for example, machine learning algorithm. Now, if you see, if you know about data science stuff, you can just see like what different machine learning algorithms are available. So you can use any of these to train and test your models on top of your data. So you can see neural network, regression, decision tree, then Poisson regression. You have got some clustering algorithms here. Then you have got classification algorithms as well, like decision forest multi-class, then logistic regression, one of the most popular algorithm. Neural network is again there. So you can see like different kinds of algorithm going on there. So this section just gives you, I call these as nodes. So this is basically different nodes you can drag and drop on the designer to implement them or use them on your model, on your data. So let's now first choose the data. So as I said, we'll be using some automobile pricing data for cars, for automobiles. So what we'll do is we just click on it and just drag it. So this is what drag and drop is basically. You just take the node and drag it onto the canvas. So that's how you can do it. Now, before we start anything further, let's see what this data is about. So for that, what you can do is right click on your node, and click on preview data. Once you click on preview data, you see, the first thing you see is some metrics on the data, like this data has got total 205 rows. It has got total 26 columns, okay? And then at the bottom, you can see all the columns this data has got. Now, this is about automobile pricing. So you can see like there are so many columns that define the characteristics of a vehicle or an automobile vehicle, right? So you can see like fuel type, then number of doors, body style, then make, you can see Audi, BMW, Alfa Romeo, and so on. Then body style, whether they're convertible, sedan, hatchback. And further down the line, you can see so many metrics or characteristics of a vehicle, like length of vehicle, width of vehicle, engine type, number of cylinders, engine size, and so on. And further, you can see like there are other things like now this column called pricing. Now, this is something we'll be using as a label. Now, in data science terminology, when you want to predict something, right? So that is known as label. So in this data set, we'll be trying to create some predictions for price column. Now, other thing, when you click on a column here in the data set, on the right, you tend to get some kind of, high-level statistics or metrics around that data. So for example, against price column, I can see a few metrics like mean, median, max, min, standard deviation. Now this column has got 186 unique values. Then there are 4 missing values in the column. And then at the bottom, you can see some kind of histogram, which tells you the price distribution by frequency. So, this is kind of a really good stuff, especially in the starting when you're getting your data in Azure, because you really need to make sure that your data is in right shape, because sometimes if you don't clean your data or have your data in the right shape or in the right way, then it may just lead you to wrong conclusions, especially when you're building a machine learning algorithm on top of it, right? So it's very it's as part of a practice, it's really good to explore your data and see whether it is right for you or it's in the right shape, or if you want, or if it requires any transformation before you create any machine learning model on top of it, right? So yeah, if you can see the other columns as well, like for example, city MPG, it tells you mean, median, min, max statistics. It tells like this column has got no missing value. So that's a very good thing, right? Then similarly, you can see horsepower, you can see the similar statistics, you can see it has got 2 missing values. So you can click on any of the column and it just kind of shows you different kind of high-level statistics. Now, for example, fuel system is a text kind of column. So obviously there's nothing called mean, median, min, max against it. But yeah, it kind of shows you it has got 8 unique values and there are no missing values. Now, one thing in this data set, what I want to highlight is if you click on this normalized loss column, when you click on it, you see some statistics for that column here on the right. Now, okay, mean is fine, median is fine. I further go down, I see that this column has got 51 unique values, and I see there are 41 missing values in this column. And if you see, total rows in this data is 205. Now, if you just try to work out the proportion, yeah, 41 missing values seems to be quite high in a column, right? So most of it must be, nearly, I would say 1/4 of it will have missing values, right? So is it right to take that column for training a model? That's a question, right? So when a column has so many missing values, like for example, when we saw other columns, most of them didn't have any missing values. And the ones which had missing values, they had something like 2 missing values or 3 missing values. Like I think in horsepower, we had 2 missing values, stroke, we had 4 missing values, but nothing like 41 as we have it normalized losses. So when you have certain columns or features in your data, I think it's always good to remove them, because these kind of columns can just make your machine learning give weird results or non-promising results in the end. So what we understand from this little bit of overview on the data is like we need to ignore this column, otherwise it can just harm our predictions. So let's do how we basically do that in Azure. So for that, what we'll do is, once we have our data here on the canvas, the first thing we want to do is we want to select columns, right? Because as we said, that normalized loss column won't be helpful. So for that, we need to select columns. So the first thing you do is you connect your raw data to this, okay? Then click on select columns in dataset. Once you click on it, it asks you what all columns you want to select for further next steps, right? So what you do is click on the edit column. Once you click on the edit column, there are two options, with rules or by name. We are just selecting columns based on names, okay? We just want to ignore one column, right? So what we do is we take this option by name. And what we'll do is, now on the left, you can see all the available columns in the data set. And on the right, you just need to make sure you have only the columns you want to take forward in the next steps for your machine learning building, right? So now we want to ignore normalized losses. So what I'll do is, you can either click on plus sign one by one and get columns added. But what I prefer doing is I just add all columns, but remove the ones I don't want. So for example, I don't want normalized losses. That's gone. Rest, I want everything, right? So that's all there. And then just click save. So once you do that, then that step takes into account what all columns you want to take to the next step. So that was like a select columns in dataset. That was the first thing we did. Now the next step, as we just saw, like for example, the normalized column had a lot of missing values, so we just ignored it. But there were few other columns like horsepower, book or stroke. They also had like few missing values, like 1, 2, or 3. So we need to, somehow handle those missing values. Now there could be multiple ways of doing it. Like, for example, when you have a numeric column, okay, like for example, we had, okay, let me go to the data again. So in this data, for example, when we talked about horsepower, it had 2 missing values, right? Now there could be ways of cleaning these missing values or, sorting them out. Now one way could be, replacing this missing value with some mean value or median value, because that will just, normalize that column in a way. The other way could be, you can ignore those rows with missing values if your missing values are not that high. So in our case, if we say the number of missing values in the columns that we just saw, they are not that many, right? They are between 2 to 4. So what we can do is we can just lose these rows, because 2 to 4 rows won't make much difference if we lose them, right? So for that, what we do is we just clean our data basically. So there's a clean missing data node. Just drag it onto the canvas. And before doing anything, connect your select column data set to clean missing data. Now you need to make sure you connect this, because this is the final data set you'll be using, right? Now click on clean missing data, and it basically first thing asks you what columns you want to clean. So for that, go to edit column as we did previously. We can go by name. Now I want to clean all my columns, right? If any of my columns have got missing values, right? So I'll just add all. Now here, make sure you are removing the normalized losses, because that's the column we don't want going forward. And then just click save. Now, once you select all the columns that you want to clean, there are certain metrics you want to use. Now, I won't be playing around with anything apart from cleaning mode. Now, once you hit the drop down, there are different cleaning modes. Like I talked about, you can substitute your missing values with a value, like for example, replace with mean or median or mode, or you can remove the entire row. Or if you want to remove the column, you can remove the column. But in our case, let's remove the entire row, because they were like very small in number, right? So we'll just remove the entire row and just close it. So this step has taken that into account now. Okay, we have selected our data set, we have cleaned it. Now, after cleaning, what do you do? Now, if any of you guys are coming from data science background, you'll know what are the basic principles around creating a machine learning algorithm. Now, whenever you create a machine learning algorithm, you do it in 2 parts. The first part is you train your model, and the second part is you basically test it. Okay, so for training and testing, you need to split your data into 2 parts. Then only you'll be able to train it and then test it on the trained output. So the first thing now we'll do after we've got the clean data, we'll split the data into 2 parts. So for that, what you do is you bring in a split node. Now see, it's very easy. You just write the words and it will just gives you the suggestions. Now we want to just split data. So just drag that node here, right? Now for splitting the data, before going there, we need to connect it, right? So we'll connect our missing data node to split data node. Click on the node. Now, once that split data node is open, it asks you a few things. Like, what fraction of rows you want in your first output data set. Now, first output data set here is basically trained data set. So it's asking you what proportion of data you want in that. Now, generally, people tend to train their model on 70 to 75% of data, but the choice is yours, how you want to create your model. Because what happens is you can start with a train data set size at 70%, but suppose if you don't get good results, you can actually try experimenting with this value, right? You can modify the size and try rerunning your model. So let's start with just, 70% of trained data set. And I want it to be randomized split, because I just don't want Azure to, just give me like top 70% rows as my trained data and bottom as my test data. I want them to randomly pick my rows. And to randomly split our data, you need to add a seed. So this can be any number. Okay. So that's what we'll change in this node, and we'll just close it. So we have given relevant parameters. Now, split node has basically, split your data into train and test. Okay. Now, the next thing will be, now we need to run a predictive model on top of our trained data. Okay. So for that, we need a model, right? Now, as we are trying to predict a numeric column, which is price, we'll use a regression model. So for that, again, go on the left, search for regression, and I'll be using a basic linear regression, which is not very complicated, and drag and drop that node here. Now, once I bring in that linear regression, now this linear regression I want to do on my trained data set, right? So I need to bring in a train model node here, which will take my trained data set as an input and run a linear regression on top of it. So I'll bring my train model and bring it here. Okay. Now, before doing anything, I'll pass my split data to my train model, because I want to give input to my this data set, right? Because my split data bigger part, which was 70%, should be used for training purposes. So I've given that as an input, and I want to run a linear regression on my trained data. So I'll connect my linear regression node to train model. Now, in linear regression, I'm not changing anything. I'll just give a random seed. Let's just stick with the default parameters. Okay. And in the train model, now once you click on train model, it asks you to choose a label column. Now, label column, as I said, is something which you want to predict. Okay. And in our data set, we want to predict price column. So we click on edit column, and yeah, you can just enter the name of the column here. So once you click on that, once you click on enter column, it shows you all the columns in the data, and we know it's price. So just click price and hit save. So that's what it has taken as a label. And in the end, we want some kind of model explanation. So I'll just do it to true. Okay, so that's the parameter setting for a model. Now, once your data is trained, or once you have run your linear regression on your trained data set, you need to test that as well. Okay, so for that, what you do is you create a scoring, typo mistake. You create a scoring node. Now, scoring node, what it does is, it takes the remaining part of your data, which was like 30% as input, and takes the output of your trained model as an input and try to score the model on it. Now, once the model is scored, you need to evaluate it, right? In the end, somehow we need to, evaluate the performance of the model, right? So for that, we'll create a node called evaluate and just drag and drop here. Now, in the evaluate model, we'll just, input the output of the scoring model. Now, just look at it. We'll just look at all the steps quickly, what we did. We just brought in a raw data. Then we selected the columns, which were more relevant to us for building our machine learning algorithm. And then we cleaned our data. In this case, we just removed a few missing rows. The rows which had missing values. Then we split the data because we want a trained data set and test data set. So we split that into two parts. Then we used the train part of the data set to train a linear regression model on the data. Once that outcome is generated, we feed it to the score model, and we also feed the remaining part of the data, which is test data, to score model to run the predictions. And once that is done, in the end, we evaluate the model just to see how a model has performed. Now, once you hit submit here, these nodes will start running. So for example, if I hit submit, it will ask you experiment name. I'll just name it as test pricing, and I'll hit submit. Now, once I hit submit, okay, it is submitting. It just starts to run the nodes one by one. Okay. And yeah, it has completed quite quickly. That's a good thing. So once that is completed, you see a green against every row. Now, the only thing what I want to show you as part of this execution is, let's see what it has done basically, right? So if you go to select column dataset node and go on the preview dataset, it will show you in select column, it removed the normalized losses column and kept rest of it. So we are just seeing what every step has done. Then in the clean missing data, if you preview the data, the clean dataset has got 193 rows. If you remember, our original dataset had 205 rows. Now we are only left with 193 rows because it had removed those few rows with the missing values. Okay, so that's what that step has done. And split data, when you go to split data, it shows you two datasets because our first dataset was trained dataset, which was 70%, and second dataset is the test dataset. So if you click on result test dataset 1, it shows you it has got 135 rows, and it definitely tells me it is 70% of my data. And if I similarly right click on it and go to preview data and result dataset 2, it shows me it has got my test dataset with the number of rows. So that's how what split node has done. Then linear regression model it won't tell us much here because it ran with these parameters on our trained data. And now let's see what scoring we have got. Okay, so for that, what we'll do is we'll click on score model, go to score dataset. Okay, now if we scroll to the right, we see a new column added to our original test data, which is scored labels. So these are basically, the predictions made against the price column. So you can see, like in this row, our price was 9279, but it came up with and predicted it as this value. So these are the scored labels, or the predictions that we get against every individual row for the price column. Now, the last thing is evaluate model. Now, evaluate model, what it does is it basically compares your predictions with the actual values in the data set and comes up with some metrics which you can use to, identify or assess your model performance. So if you right click on evaluate mode, okay, this node is still running, I think. Let me get the one which I've already, okay, so I already ran one model a few minutes back and it's ready. So let's right click on the evaluation node and click on evaluation results. Now, once you open evaluation result, it comes up with few parameters or, few metrics, I would say. Based on it, what it has given you some values like, these are the values against your model, what you have just trained on your data. Now, these metrics gives you an indication on, how well your model has performed. Let's go back to the deck for now. Okay, so we were on this deck where, we had to create a pipeline, which I already showed you. To create a machine learning model or flow, you need to create a pipeline first. We created that. Then we also explored the data, showing you like what all you can see against all the columns in the data, what all statistics you can see. Then further down the line, we created this model and got to this step. Now, after that, we were looking at the model scoring, like how the model has scored our predictions against the actual value. So that's where we see the scored labels, right? Or the predicted labels. Then further down the line, we went to the evaluation node and checked all the metrics that it came up with. Now, for example, as we ran a regression model, that's why you see these numeric metrics there. Now, every metric has a different significance, but it just indicates like whether your model has performed good or not. So for example, mean absolute error. So it's basically, just a mathematical formula that just takes a difference between the scored, or I would say predicted, and your actual values and give it a value in the end. And lower this value is better the model performance is. Similarly, if you see the root mean squared error, it is very much similar to mean absolute error, just that you take a square root of this value and then take a difference between actual and predicted. So these are basically more like mathematical formulas. And the thing is, again, the lower the value is, the better your model has performed. Then there are three metrics which are, or I would say two metrics which are more around relative squared error and relative absolute error, these both are relative metrics, and closer their value is to 0, better the model has performed. Okay. And the last but not the least is coefficient of determination. Now, coefficient of determination, against, it is kind of, it is calculated in the form of a variance between your between your actual and predicted values, and closer the value is to 1, better the model has performed. Now, in this case, our value is closer to 1, right? It is 0.86. So I think our model has performed fairly well on this data. And so the predictions, what it has given us, we can rely on it. So these are just, model evaluation metrics. And though there could be other ways of evaluating your model as well. Okay. But this is what, Azure gave us as an output for our linear regression model when we trained it and tested it on our automobile pricing data. Now, excuse me. So the most important thing, as I said in the starting, whatever you do in Azure, you are charged for it. So if you are not using any of these, compute instances or compute clusters or the resource or workspace that you created for your machine learning environment, it's better to stop them or, just delete them. So first thing is, you can stop them if you're just going to use them like in few hours, or you'll be using them on daily basis for next few days. Then it's fine. You can just go and stop your compute instances. So for example, if you remember in the starting, I just restarted my compute instance, right? So if you don't want to use them, so what you can do is just go to your compute area. And if your compute instances are running, you can just click them and just stop them. Okay. And you can restart them next time when you log into Azure and, just do your bits. And then again, you can stop and restart them. But suppose if you don't want to use these compute instances for a few days, I would better suggest just delete them. Because if you have these in the environment, Azure just, charges them, charges for taking them some space or, assigning them some resources. So you get charged for what you have in the environment, right? So if you're not using them, just delete them. So that's what I mean by clean up resources. So always make sure if you're going to use them, then keep them. Otherwise, delete them. Otherwise, you'll, unnecessarily get charged from Azure. So that's the main important step you need to, remember. Then I think in the end, I have added few resources to help your learning. So suppose if you're a beginner like me, you can, just start with some Microsoft official documentation, because I myself started with this, and, these are really helpful, and, they have really explained everything very clearly, and, how you can create everything step by step. And then this is one of the Azure machine learning Git repository, which is available for everyone. So you can actually go there and see some use cases, what people have created using Azure Machine Learning Studio, like training and testing different kinds of model on different kinds of data sets. So you can, I think it's worth visiting the link, because it has really got great examples there. And then any of you guys, if you really want to, go and learn some data science basic concepts, then I've included 4 resources, what I generally follow on, whenever I'm in need of learning those data science concepts. So you can also follow them. Then in the end, I would just suggest if you guys have got like enough comfort with Azure Machine Learning Studio, and if you just want to test your skills, like how much like designing these experiments and how you can build them, then I would just suggest you can just go forward and take Azure AI 900 fundamental certification, because if you take that exam and you pass it, it will just give you a confidence in like whatever you were learning from last few days or few weeks or few months. Your results are coming up. It means you're really getting what you were learning, right? So it kind of just boosts your confidence. So it's like a good certification, and it's a basic level certification. It doesn't require anything related to coding in Python or R. It's more around the drag and drop designer stuff, what I just showed you, and some basic concepts about Azure environment. And yeah, I actually gave this exam a few months back, and I created some learning parts for it. So if any of you guys are interested, you can go and refer them, because I just use them as notes as well. So they were really helpful. And then, yeah, in the end, guys, thank you so much for attending my session and taking out time for joining me. And yeah, I'm happy to answer any questions now.
That was absolutely great, Pragati. I think you covered the entire ecosystem of Azure Machine Learning Studio. You created an entire experiment, right? And I really love drag and drop. And having said that, you did also talk about the certification, right? And I also took the certification. I really loved it. I took those learning paths. Those are very good. Microsoft Learn is an amazing platform to go ahead and look at the latest contents that we have. The cloud advocates at Microsoft have been doing great job to keep it updated. My quick question to you is, Pragati, now you did use low code, right? I mean, there was no code involved, right? And then still you ended up building an entire machine learning model. So if I want to go ahead and feel like, okay, no, maybe this machine learning model is good, but I want to maybe add this line of Python code in that designer, or maybe canvas that you is that possible? Can I add some custom Python scripts there?
Yeah, I think there's a way of doing it, Simon, though I haven't tried it. But I would suggest, as we saw previously, there's a low code area where you can create your Python notebooks as well. So I would suggest exploring that bit, which I am still in process of exploring these days, because I really love working with Databricks. So I am doing that these days. So you can basically code your entire machine learning algorithm, because I know Python and R, they've got amazing inbuilt packages for different machine learning algorithms. Just bring them in, add your data to it, and split them and just get your machine learning model started. So yeah, I mean, Azure gives you both flexibility. If you just want to do drag and drop stuff, it does that for you. But yeah, if you really want to go into the basics of coding and understand that model, how it is actually working, I think I would suggest go for the low code environment, because it really helps you building in your understanding on how the model is actually working. Because currently when you do drag and drop, you don't understand all the parameters behind it, right? You really don't know how the model worked. But once you start coding in Python or R, I mean, guys, it is a suggestion for everyone else out there. Just start with a basic linear regression creation in R or Python. That's the simplest model you can start with. And rather than bringing in a data, just create X and Y column and try to do some predictions and correlations between them. And you'll just start loving it, because it kind of comes up with different predictions on the random values in X and Y columns. I literally did it 2 days back. So just as a suggestion, start doing that in Python.
I've done that a lot, and I still, this is the advice that you exactly copy paste. Even I said that start from very basic. Linear regression is the first thing you should try, even to understand y is equal to mx plus b. It will take you time, right? It will take you time. When things are happening, I would go back, then look at my elementary math, that, okay, this is what the intercept
exactly
means.
I mean, that y is equal to mx plus c, that's a line equation, right? We guys must have done that in a education time. But yeah, it makes sense when you start doing that. So yeah, I think as a suggestion, just go and do that. But my focus on the session was, just to show the capability of Azure Machine Learning Studio. Like, it has really got something which you can, just get started on the day one. You don't need basic information. You just need basic data science concepts. Because if you don't know how a machine learning model is created or what kind of steps are included in building a model, you'll have obviously not be able to create the flow that we just created and ended up doing today here. So that's what I meant by, because I think someone asked, I think Sandeep, you asked me, can you explain where the data science concept comes? So that's the data science concept I was talking about, especially like when you need to use regression, when you need to use classification. Like in our case, we were predicting a numeric value, so we use regression. Like suppose if you want to do some predictions on a categorical value which are non-numeric, then maybe you need to go for a classical classification model. So that's the kind of data science concepts I was talking about. So it's always good to have that background. Otherwise, you just end up creating these models but not understanding anything out of it. So yeah, better focus on few data science concepts, and as I have included few in my deck as well. So you guys can, just and obviously there are amazing blogs and YouTube channels on data science basics. You can just go and refer them. So it's good to know, basically.
Yeah, that's great, Pragati. You have so much to share that I think I can give a couple of more hours.
Yeah, actually, when I start talking, I'm like, talk a lot. Because I just have so many things in my mind to tell people, and it's like that.
Never mind, Pragati. That was absolutely good. I really enjoyed hosting. Any final thing you want to plug in before we move to the next session?
I think guys definitely go and explore Azure Machine Learning Studio. I'm loving it these days, because whenever I get free time, I just do it. And obviously, it's never late to start on something new. I know people are coming from different background in this audience, but everyone can do data science. Okay, it's nothing a big thing, okay? Like the people talk about it. You can start your machine learning AI journey from right now. So don't just bother about what people think about it. Just get started.
All right, Pragati, that was absolutely great. I really enjoyed hosting you. We'd love to have you back. We do many events
Definitely.
around the year.
Yeah, I think this is first time. Definitely, I'll come with advanced session, Simon, next time.
Yeah. All right. Enjoy your rest of the day, Pragati. And yeah, hope to see you soon. Bye-bye. Take care.
Yeah, thanks, Simon. Thanks, everyone. Bye.
All right, now it's time to switch to our next session. Our next speaker is Luis, and Luis is a true community rock star. I follow him on LinkedIn, Twitter. He's very, very active. And today's session, he's going to talk about image recognition in WhatsApp chatbot with Azure AI. Now, this is pretty interesting, right? He's talking about Azure AI, but with an application that you can do it with within WhatsApp. So I'm really excited. So without any further ado, let's bring Luis to Cloud Summit 2021. Oops. Hi, Luis. Welcome to Cloud Summit 2021.
Hey, Simon. Thank you very much for the warm welcome. And welcome, everyone. Thank you, everyone, for being here.
So Luis, I'm really excited to host you. I still remember the last time I hosted you was back in .NET Virtual Conference last year. The first time I hosted you, and I'm really excited, looking forward for your session. And I see some of our sponsors joining in, so shout out to Script Runner. That's also very important. Heiko, Luis, I see you shared your screen. I'm going to add it to the stream. Everybody else can see it. And next 45 minutes is all yours.
Okay, thank you very much, Simon, for the warm welcome again. So I am very happy to participate at Cloud Summit 2021. So the topic that I'm going to be talking about is image recognition in WhatsApp chatbot with Azure AI. So please feel free to ask any questions through the presentation. I will do my best to answer them. So again, I appreciate the time that you spent learning and being here in this presentation. As the introduction said, I am a researcher at Masbate University in Zlín, Czech Republic. Although I am from Mexico, I am also a Microsoft MVP in categories of AI and developer technologies. Here you have my contact details, and also feel free to reach out in case you have any questions or you would like to talk about mobile applications with Xamarin, cloud computing with Azure, or artificial intelligence. I'm very passionate about these topics. Okay, so in this presentation, we're going to talk about these topics, and we will demonstrate the application of image recognition in WhatsApp chatbot. So first, let's talk about chatbots. Well, most of us have interacted with a conversational agent. We ask or request something, we ask a question, and on the other side, there is a digital assistant. There is a software with maybe some personality added that answers our questions, that process our request, and send us a response. A response according to our initial request. This is one of the most advanced human-machine interactions because it involves several artificial intelligence or machine learning tasks, as the previous presentation said. Because first of all, it has to process the natural language, because when we interact with a bot, it's the same as if we were talking to a friend or to another person. We use some language, English, Spanish, etc. And the bot or the software understands. Well, first takes the input, process it, and then understands what is our intention, what we want. And also, there might be some context. I will talk about that in the next slide. But it can also involve speech to text because, you know, there is Alexa, Cortana, Siri. We interact with these assistants by talking. So when we ask Alexa, what's the current weather, it will give us a proper response. So it will translate the speech to text, and then the natural language processing starts, right? In order to recognize or to identify some information. So yeah, basically, when we send a request such as, I would like to put 10 euro on SIM card of telephone number 390, blah, blah, blah. This message is analyzed by the bot, by the software, and two special elements are identified. The intent, which means what we want, and the entities, which is the context. It can be place, some object, some date, some specific information that will be important in order to compose a personalized or custom reply. Like, for example, now that it gets or knows this information after processing, it will identify, for example, if it is a valid number. It can search on a database, right? It can build a query, internal query, to look for this number in a database. Then if it is active, and maybe it can even process the payment, 10 euro. Do you have enough funds? And so other things, right? And this reply could be either positive or negative, depending on the result. But of course, it will also use the same way of communication. Usually, if we speak to a bot, we will get also a speech as a response, right? It will talk to us. Or if we type, we will also get a message or even maybe some images, right? So what is the importance of bots in case of users? Well, some or maybe companies. Usually, we can use bots for repetitive or simple tasks where usually there is a person. You can imagine customer service that receives a lot of phone calls. So let's say that the users talk to employees and ask, okay, I have an issue with my computer. All right. The employee asks, okay, is it turned on? What is happening? Do you see the logo of Windows? What is your operating system? There are several questions. You collect information, right? And then maybe the employee has a manual or has some steps that he can recommend to the user in order to solve the issue. But of course, maybe most of these issues are quite common. You can say maybe 80% are known issues, known problems. There is already a solution for that problem. So we can use a bot to send responses or to even process these inputs. Instead of talking to an employee, the users, the people, the customers can talk to the bot or can write a message, right? And the bot will send a proper response because it's in its knowledge, right, how to solve these issues, or it can search on a database. And for the remaining 20% of issues where are more specialized, particular, maybe unknown, we can talk to the, or we can call, sorry, the employee, the expert, and then he can, we can hand off to this human, right? So this employee will solve this particular issue. But this doesn't mean that the bot is replacing the employee's job. Actually, the employee can be working on some other more important task rather than having him just replying, answering to known questions or issues. He can be, let's say, more valuable to the company, for the company, by working in other project maybe, and just use 20% of his time in solving difficult issues at this customer service issue or problem, right? So the bots, since they are software, they can combine millions of data. They are available all the time, everywhere. And yeah, they can easily be integrated in different platforms, because we can see bots on Facebook Messenger, WhatsApp, Twitter, or maybe other channels such as Teams, right? You can name it. Even on websites, right? We can take a bot and integrate it on a web platform. And well, depending, right, on the implementation, they can improve the user experience and keep the human effort to a minimum. So this is one of the applications of artificial intelligence. But maybe, yeah, there is a question, or you have a question. How is it possible that when the bot gets a message, either written or spoken, it can be understood or it can be analyzed? Well, I mentioned one of the tasks that solves this, or that process this test, is known as natural language processing. Natural language is what we are talking right now, because there are some words, vocabulary that you and I understand. So the issue is that a software can also understand this. We can create a neural network, for instance, that processes every word, right, and tries to understand what we are talking about. So yes, you can do that. You can study artificial intelligence in order to build a neural network that processes text. But also, there are some cloud services which help us to do this with few lines of code, or even without any code. And one of these services is provided by Azure. It's known actually as LUIS, as you can see, Language Understanding Intelligence Service. So this is a cloud service that understands text. And basically, you don't need any previous AI background to use it, because, and also it is easy to integrate it into our software solutions. What are the steps? Basically, we are going to first create some intents and add some entities. You will see in a second. Then we will add utterances. I will explain also what is that. Then we will train, test, refine the machine learning process that you saw previously. And then if it is successful, or if it is it has a high precision, we can publish and deploy it. So what are these three concepts that I mentioned? Okay, the utterance is an example. Actually, you need several examples, right? So we are going to train a model by providing examples. This is known as supervised learning. So let's say that you are building an intent. The intent is turn the light on. What can you use in order to so you or even a bot understand that some lights should be turned on? Okay, so maybe one example, one sentence could be, can you please turn on the lights for the kitchen? Another one, oh, it is too dark here. Maybe we need more light. Or could you, I don't know, power or up the room, or I don't know, another example, right? So basically, you will provide several sentences, and they mean the same. The intent could be turn the light on. But of course, maybe you don't want to turn the lights on for the kitchen. You want for the living room or for the bathroom. So this is an entity, the place, the room. Where do you want to turn the lights on? Right? This is like a variable. Okay. So basically, right, and now I can explain this. I can go to this website. The website is luis.ai. And in my case, I am already logged in. And here I create an application. In my case, I have already created one. The name is WeatherBot. I will zoom in a bit. Okay, yes. So this is WeatherBot. And here you can see that I have already created an intent. The name of the intent is get city weather. Okay. And also I have an entity. This one is a pre-built entity. It is already, let's say, created, or sorry, it is already provided by Microsoft in this service. There are several pre-built entities. This one specifically allows us to detect geographical data, such as city names, river names, countries, continents, right? And what else? We can also add some other pre-built entity for identifying numbers, not only digits, but also position, like first, second, third, right? And others. Okay, and after I have created an intent and an entity, I can go back to the intent and then provide utterances or examples, right? And here you can see that I have provided some of them, such as, is it snowing in Seattle right now? What is the current climate in Cortázar? Is it raining in London? And so on. The objective is to know the weather of a city. That's the intent, purpose, okay? And you can see that I have also identified, in some cases I identified, in others, it already worked, it already knows that, okay, Seattle is geography, or Cortázar, which is the name, the city, the name of the city where I used to live in Mexico, Prague, and others, okay? So these are the entities, and we can provide many examples. It is recommended, I don't know, at least 10 to improve the quality of this machine learning model. And after we have provided different examples, we can train and test, right? In my case, I have already trained this one, so I will test it. I can provide a new example. I want to know, and of course, I will use an example that is not inside these examples or utterances. I want to know the climate in, for example, Tokyo. Tokyo. And it will say, yeah, you mean, or your intent is get city weather, right? And we can inspect and we will get information such as, okay, in this case, it didn't identify the entity, but let me check with the published one. Yeah, it didn't identify. So maybe I need to, of course, improve it. This would be one example, right? So let me try another one. Let's say I want to know the weather in, I will try again, Tokyo. Okay, this one didn't work either. So maybe Tokyo is not recognized. I want to know the weather in Prague. Okay, yeah, well, okay. It seems that there is an issue because it doesn't identify the machine learning entity. Okay, so yeah, this happens. So I will try another one. What is the weather in Tokyo? I will try it. Tokyo, right? Yeah. For some reason, it is not identifying the intent. So let me try. Okay, what is the weather in Prague? Okay, yeah, this one, it did identify the entity, even though it is not here in the publish. Yes, you can see that actually in this JSON, because that's the outcome of this, it is a JSON. You can see that the intent is recognized, and also the entity, right? When we publish this Luis model, we are going to get an endpoint where we are going to send our requests, and we will get this JSON. And of course, if we get this JSON in our program, we can extract the entity and connect it to another part of our application. I will tell you how I do this in a minute. But as I said, when I publish this, I can go to the settings, but just give me a second, because yeah, here in manage, under manage, Azure resources, you will see the endpoint. Yes, this one. So I can take this example query, which is, as I said, an HTTP resource, and at the end I can provide my query, such as I would say, what is the weather in Prague, right? And yeah, this is the response, right? Okay, so I have an URL, I have an endpoint. Then I can go. Okay, sorry for that. It seems I am going to access another computer where I have my code. So just give me a second. I will try here. Okay, yes, it is here. So as you can see, this is a C# code. This is a program. I will tell you what type of project is later. So here I have the URL, right, that I just showed you. And I have a method where I provide my query or the text. And actually, you can see that I create a string and I send a get. I send a get request. All right. And after that, I deserialize this JSON string into an object. And if the intent is get city weather, I will extract the entity, right? And this method actually returns the city name, the entity. Later, I will connect, I will show you a bit later, I will connect this get city output with this weather service as an input. There is also a get weather method. And in this case, I am using Open Weather Map, which is a website. It provides an API for free, but also there are paid services where I can get the weather or climate conditions of a specific place. Even though I am talking about image recognition, this bot also process some text, right? I will talk about image recognition in a second. So I need the API key, and I will get the weather information. Actually, I also have this. So let's say, right, that my bot already got the information. I have already sent the request for Prague. You can see here, this is the Open Weather Map. The query or the city name is Prague, and I have my API key here, and I get a JSON as a response. And then I can compose a reply for the user, right? Well, of course, this is just some, let's say, functions, right? later, let's see how to connect it to WhatsApp, right? So yeah, let's go back to the presentation. And I show you the internal parts of Luis, right? And we also saw the resources and the C# code, and also the Open Weather API. All right, so we are a bit done for text. What happens with computer vision? Okay, in case of computer vision, this is also an important area in artificial intelligence, which aims to create software applications that can see or understand what is happening around, as if it had a camera or some eyes, okay? And in computer vision, there are many tasks, such as the object detection. As you can see, object detection means that in one picture, we will be able to identify where specifically there is a specific object, right? Sorry, where specifically there is a particular object, like the coordinates. These coordinates are known as bounding box, right? So for instance, in this case, it identifies, okay, here there are buildings. Or maybe another related task would be brand identification. We can train a model, a neural network, to recognize specific brands or logos. It can also perform OCR, which means optical character recognition. Maybe we have this message, and it will understand what are the characters or the text inside. And also face detection, which is a quite common solution that we see everywhere or every day, right? One of the most advanced tasks is to actually explain what is happening, not with a specific, with isolated entities, but actually giving a description, such as, for instance, if I show you this picture, you can say different things, right? Maybe some of you focus on the buildings, some others might focus on the taxis. You can say, okay, yeah, this is maybe some specific city. You can say, okay, this is Prague or this is New York, right? But other people could say, okay, this is a person walking with a dog on the street, right? You can create a lot of descriptions from this image. Well, image analysis focuses on the identification of tags and then create some description from it, right? Some summary of the image. Again, you would need to be a machine learning student or artificial intelligence in order to create a neural network that is trained to recognize objects and then evaluate the performance. But if you don't have this knowledge, if you are more developer, you can also use cloud services such as Computer Vision API, which is from Cognitive Services. And in this case, it has a service where we can send an image, and you will get a JSON explaining what is happening there and also giving other useful information. So in this case, I have created on Azure already a cognitive services resource, which is this one. And then I go to keys and endpoint, and I will get precisely, right, some API key and also an endpoint where I can set the request. With these two elements in hand, I can create some code, and the code is here. To accelerate the development, I am using a NuGet package, Microsoft Azure Cognitive Services Vision, Computer Vision. You can see the endpoint from the Azure and also the subscription key. I create a client, which is here, right, with this method. It is an instance. And after that, I build and analyze a request. You can see I am using the analyze image async, which internally it creates a get request and send it to my endpoint. In my case, I am sending also the URL of the image. I mean, it's an internet, let's say, resource. But I could also send the stream, the file, right? The array of bytes of the picture, which is fine. But in this case, I am using this one. And I will get different information, right? I am asking, actually, you can see that I am adding some visual feature. Okay, my service, what kind of information can deliver or can give me? Well, categories, faces, tags, some brands, if it is adult content or not, and some description, right? This service is quite powerful. It gives a lot of information. And after that, I just create a string with all the details, the description, some categories, some tags. You will see in a second, okay? So this is quite easy, few lines of code, and I will get some summary of this picture that I am sending, right? So as you can see, this code is also, let's say, small. It's another class, right? So you can see now, okay, my bot would have two functionalities, right? Image processing provided by this service class, and also text processing provided by this other class, Luis service. Then we will see how we are building a conversation, all right? So next up, we have WhatsApp. WhatsApp, of course, is one of the applications that is widely used by millions of people. Actually, you can see that so many users every day, every month, every year, right? And you can imagine how many messages are being generated per minute, and then per hour, per day, billions, right? So for companies, right, for businesses, this is an important communication media or way to interact or to reach customers. There is a private API for WhatsApp, which is the business API, which we can use to reach people or customers, to create conversations more engaging, or to provide like a list of products, right? Immediately, like, okay, a new user comes to this conversation and it is presented some menu or some options, right? All right. But so are we able to actually use this business API? Well, not directly, because as I said, it is a private one, but you can talk to a partner, to a Facebook partner, and then you can actually use this API, of course, paying some fee, or maybe there is a trial service or option. Well, Twilio has this, or offers this service. Twilio is a cloud communication platform as a service that you can use if you want, for instance, in your applications to send SMS messages, or maybe a call, create virtual numbers, or even perform video calls. There is also one feature, which is the verify. If you want to create an application and the user provides the phone number, you can send a code for verification, right, of this. Or you can create something like two-factor authentication. It is quite powerful platform. One of its capabilities is the WhatsApp messages. So actually, yes, it offers access to the WhatsApp Business API. Very simple to use, to implement. You will see a few lines of code are needed. Well, okay, yeah, this part is not accurate. It is not in preview version. It is already available in different platforms and programming languages. So for this, we need to access the dashboard. So I will explain this right now in this part. So here I am already inside the Twilio console, and I have already accessed the WhatsApp, let's say, the dashboard. I have to refresh this one. And as you can see, in a second, it asks me, okay, if you want to interact with, let's say, if you want to run some tests, you need to send a number. So just give me a second. Yeah, you can see, okay, I need to send a message to this number, and I will show you here. I am already. So I already added this number. It's the same one that you see there, right? So I will just join the sandbox by sending a message here. Actually, you can do that as well if you want. You can pause this video and you can send a message to this one. So I will do it, and I will get, okay, you are all set, message received, and now I can communicate with this bot, right? Or call with this number. I can send messages. I will skip this part, and I will, because actually I can send a message from here, but I will not do that. So after that, I will reach some step, which is hopefully this one. Just give me a second. Yeah, here. I will pause here. But so far, you know that I can send a message, or I can communicate, right? I can communicate with this phone number, right? Okay, so I will leave it here for a moment. Here in the slides, you see how to actually access the dashboard, right? You can activate it, of course, and then you send the number, which is the same process that I showed you. Okay, now, if I go to my code, and if I add a library, which is the specific name is Microsoft Azure Web Jobs Extensions Twilio, or Twilio SDK, depending on the platform that you are working with. Just in a second. Yeah, this. The code that I need to send a message to the user as a response is just creating an instance of a messaging response, and then add some string, right? And after that, just create a twiml object and send it back. This twiml, could be sent as part of an HTTP message, right? So let's say that this part is the last one, is to compose a reply to the user, right? But actually, how can we get the user query or the user initial text? Well, also, this message comes in a special or a standard format. It's actually an XML. And for this XML, we can process it a bit. We can split some parameters and get some values, right? And after that, this information, right? It's actually a dictionary, right? We can search if the non-media key has some value, such as 1. If so, it means that this message, whatever the user typed, contains a picture. And if there is a picture, then I can call my computer vision service. So you can see how I am building the conversation, right? If there is a picture, okay, call the computer vision service and analyze the picture. Actually, the picture that we send to in a conversation, WhatsApp conversation, let's say there is a public URL that we can get in this key and send it to our service. But if it is not an image, if there is no image, it means that it's just some plain text. So let's extract the body, and after that, call our Luis service searching for some city. And if there is a city, let's call the weather service and create a message as a response, right? In both cases, there is a response that we are sending back to the user, right? So you see the flow, right? I will explain this part later, right? So I already told you about this. And finally, in order to connect everything, we are creating an Azure function. This whole project is an Azure function project or solution, right? So you saw the services, you saw the models. Well, the model you didn't see, but basically it's C# class, right? And yeah. And Azure Functions is basically your code in the cloud, right? Which responds to events. It's event-driven, which means that maybe we set up an HTTP trigger function. So it means that when we send an HTTP request, either GET or POST, some code will run and we will get a response. Or maybe we created a timer trigger. Maybe every hour, or we set the time frame, right? Maybe every hour or every Monday at 9 a.m. some code will run. So maybe one application would be we connect to a database and we create a backup, right? There are endless possibilities what you can do with serverless computing or Azure Functions. Actually, it is called serverless because you don't worry about setting up a server. You only focus on the code, right? And on the events that will trigger your code. Another example, there is a storage on the cloud. In Azure, it's the blob storage. So maybe you have a mobile application and you are using the SDK to upload your picture into blob storage. Then there is a function that immediately when a new element comes to this container will produce escalated images automatically. The user didn't do this. They just only uploaded the information to blob storage, and then these escalated versions were created automatically because there was a trigger, there was an event happening, right? And the code needed to actually perform, let's say, those escalated versions is quite easy because there is a specific configuration, such as some bindings, input binding, output binding, right? The input would be the image, which image was inserted in the blob. So this one will be processed and resized. And the output would be, maybe I will create this escalated version in another container, in another blob storage, right? So that's the idea. As you see, in this code, there is no blob storage SDK or class, right? It is pure C#. Yeah, so, and actually everything that we set in the bindings, it's in the function, the string file name or the output block, the string, right? Okay, so I already explained you this code, which is the flow, right? Okay, we get a message, we are processing in search of either text or picture, right? And well, this code that I showed you, I already published it to Azure. To publish it to Azure with Visual Studio is quite easy because you just select the target, Azure Function Application, and after you publish it, you will get a URL. So here is my resource, ImageBot, and I am close to finish. Sorry that I'm taking a bit more minutes, but we are quite close to end. So in my case, I go to the functions, and I have received message function, and I will get a URL, which is, okay, I go to code plus test. Just a second. And this URL is, as the name suggests, public, right? So I will take this one, this endpoint. Okay, it is taking so much, but it doesn't matter. I will take this, and on my Twilio sandbox, there is a webhook. When a message comes in, when the user sends a message to this number, I can send the text to some endpoint, which is actually my Azure function endpoint, to process it and execute the code that you just saw, right? So yeah, here is the URL. This is the same URL that I sent here. And then the process will start. And this is what I'm going to show you right now with the demo. Okay, let me see. For some reason, PowerPoint just stopped. But okay, in the meantime, let's go back to here. And let's send a message. So what is the weather in Slim, which is the city where I live? Oops. Sorry. It is, yeah. And you see, the weather of Slim is clouds. Now, let's send a picture. And here, I have something. Okay, let's send this one. And we will see, it will, yeah, you see the result. A close-up of a cat with confidence, blah, blah, blah. And yeah, some information, some tags, right? There are some whiskers, some objects, and well, it says some brands, but okay, maybe that was a bit weird, but okay. Let's try with another one, right? Let's send this one. And it will tell us, yeah. Well, it didn't recognize actually the celebrity, okay? Which is fine. So a man in sports with uniform. People, person, sports, but it could have recognized some celebrities. Okay, and finally, maybe me. Okay, so yeah, this can be a bit interesting, right? So yeah, it actually created this conversation. A man with a bird and glasses with some confidence. Yeah. So you it's up to you. What do you do with this data, with this information, right? Store it in a database, send customized message. Yeah, it's up to you, right? So just to conclude, yeah, let me sum up with this diagram. And basically, in the diagram, you see the flow of everything. The user posts a message, then this one comes to the Twilio WhatsApp API, and this one launches or calls, right, the Azure functions because it is connected. And Azure functions, in the code, we will make a decision. If it is text, it will call the Luis service. Otherwise, if there is a picture, it will call the custom vision service. In both cases, there will be a reply, right, after processing this information, and then our Azure function will send a reply back to Twilio, and of course, this one to the user. So this is what we did. If you want to learn how to create this, I have two posts. One is in Dev2. This one is in English. Second one is in Spanish, and also the documentation from Twilio, and also from yeah, this one is also from Twilio. Okay. So yeah, basically that would be all. Please WhatsApp is one of the most used media or ways to communicate to people. So be responsible for what you build. Don't use it to spam other people. Be transparent. This is also important. If we are interacting with, if our bot is interacting with people, let your users know that they are not talking to a person, but actually a bot, and actually offer some way. Would you rather talk to a person? Okay, yeah, this is important. If you are storing some data, respect the privacy of the users. Tell them what you are doing. So yeah, be responsible of what you are building. So please, if there are any questions, I would be happy to reply them, and I will send this slide, and I will start answering some questions. This is my data, and please, I am also adding, let's say, some feedback way. So if you take some minutes to also tell me how was my presentation, I will be very grateful. So in the meantime, please, are there any questions?
Wow, Luis, it was great. WhatsApp with as cognitive services, right, Luis, and all that. That was pretty good. I've not seen a complete end-to-end demo in just about 45 minutes. Absolutely loved it. And I also see you use the service called Twilio, right? And and I saw that you had this emulator. Was that an emulator of WhatsApp? What was that?
No, actually, that was my iPhone, my device. It is here.
Oh, so was that a real WhatsApp?
Yes. You can even connect to this number and interact with this bot. You can use you join to this sandbox.
I should have done it.
Yeah.
That's great.
Yes,
I thought there's an emulator that Twilio has provided. Wow.
These are the pictures that I sent.
Great. Now I definitely need to go back and try to do it. I need an Azure subscription, and what else do we need?
Okay, yeah, you need the Azure subscription. You also need to create a Twilio subscription, but actually it offers some credit. I forgot if it is $5, $2, or $10, but yeah, you can get some credit to test the service without spending a single penny.
Wow, that's okay. I'm very happy. I promise I'll do it. This is so interesting, and a lot many sessions that we have is around best practices. Every session is very different, and I found this very creative, I would say, right, where you not only teach what are cognitive services, but also have it. Great. If I knew it was, I would have somehow taken your contact, found your contact number, I have texted you. But never mind. Let's see if you have any questions. Jayasankar is asking how to capture live camera pictures and identifier. Maybe even WhatsApp camera would work, right? In that case?
Yes, actually, yes. If I didn't perform that one, but if I take right now, for instance, if you want, I can maybe.
Okay. Okay, this one.
Yeah, this, and I just took a photo of this other phone.
Let it be the Let's see what it says.
Yeah, it says a white cell phone, a wooden surface with confidence, blah, blah, blah. Yes.
Wow, I love it. You can see I'm acting as a kid.
Yes.
This is great, Luis. I absolutely enjoyed it.
Awesome. Thank you.
This was amazing.
Thank you.
I think it all answers, right? It can do anything, right? It can do anything. Analyze any locations.
Yes, definitely. It can identify famous people. You can even the Face API, which is part of computer vision, has let's say some kind of enrollment. You can even train some model with faces of people faces, and later build an authentication system. Like, okay, maybe is this person or not? But be careful, because there is something known as face I forgot. But the thing is face spoofing,
Okay.
which means that, okay, yeah, I can be in front of the camera and it can recognize me, but also maybe another person prints a picture of me and you present it to the camera and it will say, okay, yeah, it's Luis. So what actually Microsoft recommends, if you are using the Face API to create this authentication platform or system, is not to rely only on it, but also add a 2FA, a two-factor authentication, maybe also send a message, a code to this phone number of user, and okay, type the code, and that's it, right?
I
Then you
wonder
will-
how this Windows Hello works and face recognition work. I mean, right? These are pretty cool technologies. I absolutely loved your session, Luis. Again, I would say very unique and practical. Any final
Thank
thing you
you.
want to plug in before we move to the next session?
Well, I am quite happy to be here. It was quite a big effort, more than 10 days of
11.
learning. So yeah, 11. Yeah. So keep up the good work, and we are very grateful for having some opportunity to talk with you, with students, and yeah, feel free to reach out. We will do our best.
Yeah, thanks, Luis. I really appreciate you accepting invitation. I know it's work day, people have work to do, but still you're taking out time, and there's no way we can pay back, right? So I really appreciate for all that you do for the community. I'll host you and see you in some other events. Until then, Luis,
course.
take good care of yourself and see you soon. Bye bye. Take care.
Thank you. Goodbye.
All right, that was a absolutely amazing session. I loved it, and I'm gonna do it. I'm gonna do it on my mom's phone. She'll be surprised when she sees it, how things are happening. Having said that, we are now reached a break. So this break is different. We are not going to take a break, but we're going to play a recorded session for one of our sponsors, that is Runduck by PagerDuty, and yeah. Let's play the commercial, and after that we'll watch their 30-minute session.
Life in operations. It's a mix of planned and unplanned work. Operators frequently find themselves getting interrupted with an endless stream of tickets, often for doing the same things over and over again, and those tickets are often escalations to yet another team. Resolving these tickets leads ops teams to searching documentation and runbooks, looking for steps to complete routine procedures. Hopefully, the docs are up to date and the operator has access, and they don't make a mistake. And of course, that the business can afford to wait. Wouldn't it be great if there was a better way? What the operators really need is their runbooks to be automated. Here's where Rundeck can help. Rundeck by PagerDuty is a leading solution for runbook automation. Customers use Rundeck to delegate automation to the right people in the organization. Now users get self-service access to operations that previously only subject matter experts could perform. Rundeck automates IT workflows and processes, replacing the previously manual procedures found in documentation. Rundeck doesn't replace existing automation. It makes existing automation, scripts, and commands more secure, auditable, and safe to run. Rundeck is a central hub for automation, connecting key tools and infrastructure in operations workflows. Rundeck helps teams resolve incidents quicker, avoid interruptions, and get more done, all while ensuring things are locked down and remain compliant. First responders are empowered to resolve incidents themselves instead of escalating, minimizing disruptions and reducing outage time. Operators become more productive. Developers stay focused. IT users can solve problems for themselves with the click of a button. Rundeck customers regularly see 60% shorter incidents, escalations cut in half, and 15 to 20% increase in productivity. Sign up for a demo today.
Today we're going to be talking about how to automate yourself out of job and how to safely delegate the management of your Azure deployment. My name is Jesse Holdsworth. I'm a senior solutions consultant here at PagerDuty, focusing on Rundeck. You can find me on Twitter at jholds. And I'll also be joined today by my teammate, Jake Cohen, who's also a senior solutions consultant here at PagerDuty. So a quick agenda for today. First, we'll talk about the status quo that we see for operations and we'll make the case for making operations self-service. We'll then look at some ways to create runbooks that leverage existing scripts and tools that you've already made investments in, as well as some strategies for getting started. And then finally, my colleague Jake is going to round things out here with a demo of Rundeck in action. So I have a feeling that just about everybody tuning in today is familiar with some of the benefits of moving workloads to the cloud. We now have the ability to scale resources like never before, which has unleashed innovation that has disrupted many industries, from taxis to entertainment to financial services. And the cloud is incredibly accessible with very few barriers to entry. So rather than having to go through long procurement cycles to purchase and set up your hardware on-prem, just about anybody with a credit card and an internet connection can get started building on the cloud in minutes rather than months. And so this combination of accessibility and scalability also enables much greater agility to businesses, which allows them to quickly adapt their products to customer demands. And so this newfound agility makes the cloud a strategic topic for most executive teams, even companies that wouldn't normally consider themselves technology or software companies. And as we look ahead, the future of the cloud is only expected to continue to grow. Things are not slowing down here. Gartner predicts that in 2021, there will be 18.4% growth in cloud services to total $305 billion. And this is driven in part by the COVID-19 pandemic. And this has really validated the cloud's ability to help businesses adapt to new challenges and in resource constraints here. While the promise of the cloud is inspiring, we also need a healthy dose of reality to keep things balanced. So while there is a ton of potential value to be unlocked by removing the constraints of traditional IT, there are also new operational challenges that often arise as companies migrate to the cloud. So for example, rather than having everything you need to run on your for your application installed on your local machine using the WAMP stack, we can take advantage of cloud resources such as Azure SQL and blob storage. And while the scalability of these services is certainly a benefit, there are also some more disparate services that need to be connected together. Or we could take an example of breaking a monolithic application into microservices. At first glance, it makes sense, right? Developers are better able to work on different areas of the application without interfering with one another. And we can more efficiently scale the parts of the application that are seeing the most demand. But at the same time, we now have a much more complex system to maintain and operate. And so this image up above here shows a typical microservices-based application for a mid-size SaaS service. Each one of these connecting lines in the middle is now a point of failure that we need to account and plan for here. We touched on the topic of accessibility earlier, and it has proven to be a double-edged sword. So while cloud platforms like Azure have made it very quick and easy to provision and manage compute resources, this can also be seen as a security risk, as we obviously don't want people taking down our production environments on a whim. So many business users are often prevented from accessing the Azure console. So this brings us right back to some of the typical challenges that we see with on-prem systems. For example, there are many times when a business user needs some new resources created, such as they're bringing a new customer online. But since that business user doesn't have access to the Azure console, that means they need to file a ticket or request somebody else to handle this. And this, this sounds familiar, right? The way we usually see this sort of scenario play out is we have a business user over here on the left that needs something done in the Azure console. Maybe they need a port opened on a firewall to enable a new integration. Maybe they need a new VM created, et cetera, et cetera. But they either don't have the knowledge or the permissions required. So they have to file a ticket that gets routed to some sort of a cloud or an ops team. And somebody from that team is going to go ahead and make the requested change. This sort of setup usually creates a bottleneck that slows down the business, since these tickets for repetitive tasks are being manually executed by subject matter experts. And this also means that as more tickets come in, we'll need to hire and train more and more people to take action, which makes it challenging to scale this area of the business. And last but not least is the effect that this constant interruption has on the focus of our subject matter experts taking action on these tickets. So while one such request might not seem like a big deal on its own, the volume of these requests like this often becomes a major barrier that keeps organizations from maximizing their investment in the cloud. As requests like this pile up, attention of the ops team becomes focused on these repetitive low-value tasks rather than working on our products and services better for our customers. So we recognize that the current pattern that we see all too often is inefficient and challenging to scale. So what's the answer? How can we reduce the burden on operations and cloud teams and empower both developers and business users with quick access to the tools that they need? The answer, let's make cloud operations available at the click of a button. Instead of waiting for somebody else to execute a script or a manual workflow to fulfill your request, why not automate these processes and wrap an easy button around them so that users can just push it when needed? By enabling a self-service model, we can give people the ability to execute predefined workflows that may involve both cloud and on-prem systems. And this eliminates the need for users to be trained on these specific underlying systems. And it also alleviates access challenges since we no longer need to log into these systems to get things done. There are a number of reasons why companies are enabling self-service for their users. One is to reduce toil across teams. So rather than spending time on low-value repetitive tasks, our users can execute the workflows that they need right away. And this helps them improve productivity and business agility since they're not waiting around for somebody else. Reducing organizational silos is another benefit we often see. Many organizations have complex workflows that involve different systems managed by different teams. Let's think about a typical workflow for deploying an application. Processes like this often involve different teams. A sysadmin might need to make some changes on an application server. A DBA might need to update the database schema. And maybe a network engineer has to make changes to the load balancer or to a firewall. If we can automate these tasks from different teams and connect them together in a single workflow, we'll be able to deploy both faster and more reliably. And this all helps us save time and money, especially when we think about resolving outages or incidents that are impacting our customers. Having the ability to get things done quickly is key to keeping customers happy and minimizing downtime. And finally, self-service operations also allows us to leverage the current tooling we already have in place. Self-service makes these existing tools and processes available to everyone who needs them without requiring them to be an expert. When people start thinking about self-service, the question often arises, so does this mean I need to automate everything I'm doing today? And the short answer to this is no. We want to focus on the low-hanging fruit that's going to make the most impact. I usually recommend focusing on workflows that are both time-consuming, repetitive, and have an impact on the business. So for example, if I'm a developer and I need a new test environment, let's say my company requires me to file a ticket to get one created, but that ticket won't get worked on until tomorrow because the team it's assigned to, they're on the other side of the world and they're at home asleep right now. I'm going to lose productivity for that day while I wait. And if this is a common occurrence that happens hundreds of times a year, this becomes a really good candidate for automation. Another category of use cases we see very frequently involves incident response. So let's say we have an outage in an application that is impacting one of our customers. If engineers need to manually collect diagnostics and perform remediation, this is time spent that's often has a direct correlation on lost revenue. So providing our on-call engineers with automated workflows to collect diagnostics and better perform remediation can have a major impact on our ability to get things back up and running quickly. These are also really good candidates for automation. From a security perspective, we also need to understand how automation solutions manage access to the platform. since giving everybody the ability to do anything on all of our systems is not usually a recommended approach. So leveraging tool sets with role-based access controls is a good way to make sure you're giving people the right level of access to the automated workflows based on their job. In fact, leveraging automation can actually improve your security posture if implemented correctly, since it helps avoid the need to give out credentials to your systems. So for example, instead of giving a developer SSH access to production servers so that they can collect logs to troubleshoot an incident they're working on, you can create an automated workflow that they can execute that collects the logs and copies them to a shared location. So this way, the developer is still able to get the information they need to do their job. They don't have access to the underlying production system. And finally, many organizations have lots of existing or legacy tooling that has already been implemented. A major factor in getting started in self-service automation is making sure that your existing tools and technologies are compatible with the solution that you're evaluating. There are many automation tools out there, and most are somewhat narrowly focused on specific use cases or technologies. So it's important to understand what you're trying to automate and what tools are going to be involved in your workflows so that you can make the right decision. When we talk about automation, there's a maturity curve. Here's an operational maturity model we have developed based on the levels of operational maturity we see from customers. Delegating self-service automation requires cultural and platform changes for an organization. It can be helpful to think of these changes as an evolution. This image here outlines a journey through a digital operations maturity model for an IT automation developed by PagerDuty. The model describes characteristics of each maturity stage so businesses can assess where they are today and understand what the next phase looks like. The 5 phases include manual. In these organizations, automation can only be run by experts. There's a heavy reliance on ticketing systems, and subject matter experts usually push fixes to requests. And next would be reactive. At this stage, there is some general automation, but automation is still only initiated by experts. And these organizations also rely on ticketed escalations. Next up is responsive. As maturity develops, delegation of self-service operations improves. Here, there is some kind of runbook automation platform in use, and automation is delegated for common tasks rather than having to rely on a subject matter expert every time. And then finally, there's proactive. So we talk a lot about non-emergency use cases in this presentation, but the last phase of this maturity model is around event-driven automation. And in this phase, organizations are really reaping the benefits of better maturity as context-specific diagnostics and mitigation are automatically triggered when an incident hits. So deeper automation means frontline responders can not only diagnose, but can also resolve recurring issues without escalating to an expert via self-service. So getting a little bit more specific, here are a number of example automation tasks I often see organizations implement. So with the x-axis on the bottom here being the level of sophistication, meaning how complex is this task? Simple tasks have one step without any options, whereas sophisticated ones have multiple steps, tools, and endpoints involved. And the y-axis here is the level of impact. High impact activities could break systems. No impact activities are non-change activities. So on the bottom left, we have things like incident enrichment, essentially automatically collecting diagnostics and attaching them to a ticket that's tracking a production outage, for example. Relatively simple task that doesn't take too long to do manually and doesn't carry much risk since all it's doing is copying logs from one place to another. Although these sorts of tasks may not be very difficult or complex, they're often great candidates for automation if they occur really frequently. On the flip side here, we have rollback and redeploy. This is often a very complex operation that involves orchestrating load balancers, web servers, and database, and has a very high impact to the business if things don't go as planned. So we often categorize these various tasks like this into a crawl, walk, run in terms of maturity. Starting out by crawling, we can often gain a lot of efficiency by automating relatively simple activities like health checks and incident enrichment while we get comfortable with the new platform. Walking involves taking things to the next level by automating more advanced tasks like performing service restarts, and running may involve even more complex maneuvers like doing config changes and rollbacks and redeploys. Once you have some use cases identified, the first step is to work with your subject matter experts to understand the workflows and codify them, right? What is it they're doing to fulfill these requests? What tools are they using? In what order? What scripts or commands are being used and what are their inputs, et cetera, et cetera. We usually want to extract all of the knowledge and experience from your subject matter experts so that are used to execute these workflows. The next step is to take this knowledge from your subject matter experts and codify it into self-service jobs. Now here at Rundeck, we help customers do this all the time. And our platform gives users essentially easy buttons that they can push as needed to run these jobs. Our platform makes your workflows more secure, auditable, and easier to run. And now next comes the fun part, giving your users access to these self-service operations. Let's take a look at just a quick before and after with a couple use cases. Over here on the left, we have our poor subject matter expert that's being inundated with all sorts of requests. And it's preventing her from working on stuff that matters. Once users can get things done for themselves, they get faster turnaround and she gets fewer interruptions. And that's a win-win. Another use case we can take a quick look at is incident response. So here we see Alice again responding to a PagerDuty alert, letting her know about a production outage. First, she has to manually collect and examine the logs. And she eventually realizes a service restart is needed. But since she doesn't have access to log into the system to do this herself, she needs to escalate and interrupt somebody else for help. With Rundeck connected to her incident response solution, logs can be automatically collected and attached to her incident as soon as it's created. And she can execute an automated Rundeck workflow that allows her to perform a service restart through PagerDuty, another major win for Alice. So now I'm going to hand the reins over to my teammate, Jake, who's going to take you through a quick demo here.
Thank you, Jesse. In this demo, we will show how a self-service mechanism for developers or other departments can take the burden off of site reliability and IT operations teams. Without this self-service mechanism, other teams have to open tickets or message channels to make requests of operations. This slows down productivity and interrupts operations teams from their high priority tasks. Rundeck changes this model by providing a simple and secure interface for other teams to conduct pre-approved tasks authored by engineering and operations. Let's look at a common example. Developers and, in fact, other teams regularly ask the operations team to provide a snapshot of production data that can be used for testing new code or analyzed for business operations, such as marketing analytics. Here in Rundeck, the user is presented with a simplified form to determine the behavior and desired outputs from the automation. In this case, I will choose to snapshot 1,000 rows from my database, deployed into this resource group in Azure. I'll also install Apache and create a name for my new VM. And then we will execute. When the job is initiated, it actually initiates the snapshot of the database as well as the provisioning of the infrastructure in parallel. This significantly reduces the time to accomplish the full workflow and does not leave room for human error. To snapshot the database, Rundeck executes commands on the remote host and then uses the built-in Azure integration to push the .SQL backup to our storage container in Azure. We can see that new backup.sql here as a blob storage item. As mentioned, Rundeck is simultaneously provisioning the new VM. This is also accomplished using the built-in Azure integration. And it's worth noting that you can have Rundeck integrate with multiple Azure subscriptions. Now, in order to upload the database snapshot to our newly provisioned VM, Rundeck needs to have an updated inventory of our VMs in Azure. To do this, Rundeck dynamically pulls VMs from our Azure, on-premise, and other cloud providers and lists them as nodes in our resource inventory. In our steps in our job, we can refresh that syncing with Azure so that we can connect to our newly provisioned VM. And we can see our new VM now listed as a node to be used in our Rundeck job. Then Rundeck will install the necessary services, in this case, MySQL and Apache, and configure them as intended by the operations engineer who authored this workflow. Then Rundeck pulls the SQL backup from Azure Storage and deploys it as a new database on our VM. Lastly, our job cleans up by removing the backup from blob storage and then previews the data from a table in our database. Our developers or other users can now connect to our new VM using Azure's Cloud Shell or SSH. In summary, this is one example of how Rundeck can reduce the workload on operations by providing a self-service mechanism for other people in the organization. Reach out to learn more about how Rundeck can help drive efficiency for teams managing on-premise or cloud environments.
So wanted to thank everybody for tuning in today, for taking some time to learn about how to make your Azure cloud operations more self-service. If you'd like to see more, you can get a more custom demo of Rundeck at the URL on the screen here. Thanks again, and hope to talk to you soon.
All right, that was one of the sessions from our sponsors. That was a recorded session, so unfortunately we won't be able to take it. To learn more about our sponsors, please look at the description. Having said that, we still have about 10 to 12 minutes before we start the next session. So there's a session by Holy Layman, which I'm going to play now, and hope you enjoy it, and see you in about 10 minutes.
Hi, everyone. My name is Holly Lehman. I am a product marketing manager on Microsoft Teams, and I am so happy to be a part of the Cloud Summit 2021 Azure Focus. So Azure Focus, you're probably wondering why I'm here. Well, as we're going to talk about today, you are in charge of managing your own career. And when I had the beautiful opportunity to join you today, I was sitting in engineering as a program manager on Azure. But like everything else, things change. And I'm so excited to tell you how my career changed, what I input, how I drove my passion, and hopefully I can help you with your next steps in your career. So let's go. Manage your career with passion reimagined. What in the world does that mean? Well, let's talk about it. So quite often we apply for a role and it sounds really fun. It sounds right what we want to do, right up our alley. And we start the role and we find out maybe it's not exactly what we thought, but that doesn't change who you are. You applied for this role because of your passion, because of your talents, because of your skills. So how do you influence your role for the positive, and how do you drive your next steps in your career? So when we think about my own personal example, my background, believe it or not, I worked in an administrative side of the world for law enforcement. Sorry, you guys, I have a dog in the back. I apologize. I started, 8 years in law enforcement, working at a jail, working at 2 police departments, and I loved it, to be honest. What did it teach me, though? What did I walk away with? So I learned attention to detail. I learned how to follow policy, procedure. I also learned what I missed. And I missed people, and I missed having fun and engaging with people in a way that made me feel good. So I moved my career and went to hospitality. I worked at almost every front of house department you could think of, and I loved it. But I also was able to bring with me the skills that I learned from my previous role to my advantage. So the attention to detail was great. Ability to define myself in ambiguous situations was great. But now I'm in hospitality where everything's ambiguous. how do I show up differently? So I learned that being really busy and taking on a variety of projects was what I enjoyed. I found almost a calmness in chaos. So part of my career led me to being one of the first people to open one of the resorts in Vegas. And that's where, without even realizing it, I got my PM hat on. I took on a number of departments, a number of different projects, working with a number of different people in all different facets. And now moving forward, here I am, Seattle, Washington, working in Microsoft. I felt so blessed, but I also felt like I didn't belong. What in the world was I doing here? But as I grew in my career and I found that there was a need and a want for community engagement, we have this beautiful group of humans, customers, partners, MVPs, who need a bright personality that wants to drive chaos, be in events, pull people together, get people in a room chatting. So what I would say to you is what defines you? How do you show up differently in your job when you realize what your passion is? And how did I define my role? So within Azure, my role changed just like every other role does. And I realized I missed community so much. So with a friend, we thought about starting up the North Star Partner Program, and I woke up excited again. I got to talk to all these amazing humans in technology from all over the world and share their story. That was what I was passionate about. I also fell into COVID just like everybody else. Our world's changed, every single one of us from around the world. And that change was positive. It made us think outside of the box. It made us look at our job differently. How do we show up every day in our home, doing our job to the best of our ability in this completely different world that happened overnight? Well, what's that moment going to be for you? What's that moment going to be for you where you decide to look at your job differently, where you decide to show up differently? You code, you create, you program, you develop, you test, but what else do you do? How do you want to show up differently and innovate your role and bring others along your journey to have passion for what you do every day? And how does that passion help you move your career along the road? I had to realize what I missed, what I learned, what I liked and what I didn't like. But what I knew I loved was community. So fast forward, because of this crazy situation called COVID, I feel like a lot of us started to look for the socialization opportunities on social platforms. It might be GitHub, it might be Reddit, it might be LinkedIn, it might be Facebook, whatever it is for you. But for me, I found a dear friend through the MVP community and became quite close to Isadora Ketanique. Together, we talked about our love and our passion for the community that's out there, not just MVP, but the world changed. And I didn't have the community impact that I loved. I realized I wasn't as excited. I wasn't as motivated. I wasn't as eager. And those feelings made me really wake up and think, what can I do today to integrate a piece of work into my job that will not only bring a business strategic benefit, but also bring personal benefits to myself and do what I love, impact the community. When we thought about head in the cloud, heart in the community, the last thing I thought about was how it would integrate with work. But when I thought about how we can pull our partner stories and share it with our engineering team, drive feedback from these incredible humans who are eager to share technical feedback, I loved it. I connected with people all over the world. I was able to really share what people want to do, is to talk about the tech and do it in a way where we get to showcase the work that these amazing humans are doing. When I thought about head in the cloud, heart in the community, it had nothing to really do with Azure or my day job in specific. But you know what it did do? It's diversity and inclusion at its finest. You didn't have to be a Microsoftie. You didn't have to work in a certain technology. You didn't have to live in a certain area. And it was a way of driving customer, partner, MVP stories and advocate for diversity and inclusion, which that's what we all care about right now. We need to lead with empathy, drive what everybody is striving for, which is respect for one another, a kindness, and bringing people with you on your journey. When I approached my manager about both ideas, he loved it. Sure, I had to prove it. Sure, I had to do the work. But if you're willing to do the work and do the research, you're going to love the outcome. You're going to feel impactful, and you're going to know that you are driving your career today, tomorrow, and for the future. Now, for those of you that were wondering, what in the world does this have to do with Azure? My goal in this session was to make each one of you feel a little better, a little stronger. Look at your passion, not just a job description. Look at what you want to go after and how you can think outside of the box and bring something different into your day job. And what does that look like down the road? What can you create? What is your love and your passion? And how can you partner with others? How can you create with others? And how can you show up more differently every single day? I want to see everybody that is listening show up with a newfound passion, your health better, your heart better, a sense of confidence, and a love for what you do. So now, whether you're Azure, whether you're MVP, partner, customer, whatever company you're working for, my ask is that you go and get after your goal. I'm Holly Lehman. Thank you so much for having me. Enjoy the rest of the summit. Take care.
All right, so welcome back, everyone. That was a quick recorded session by Holly Lehman, who hosted the very first day of Cloud Summit 2021. And yeah, I hope you go back all and chase to your goal. Having said that, it's time to move to our next session. Our next session is by Marco. Marco is going to talk about on how you can save money, bucks, and maximize performance of your SQL Server virtual machine and Azure on Azure IaaS. Marco is a Azure MVP and an engineer. So without any further ado, let's bring Marco to the live show. Ooh. Hi, Marco. Welcome to Cloud Summit 2021.
Hi, Simon. Thank you for this introduction. Very complete. Thank you so much. I'm very happy to be here with you.
Yeah, I'm really happy to host you, Marco. I really love that you have joined us with the branded. You're all branded for this Cloud Summit. I really love your background. So thank you so much. So Marco, you're going to talk about SQL Server virtual machines, right? So I won't take much of your time. And I see you've already shared your screen. I'm going to add your screen to this stream. Everybody else can see it, Marco. And next 45 minutes is all yours.
Okay. Thank you, Simon. And hi, everybody, and welcome to this session here at the Cloud Summit 2021. I'm Marco Obinu, and I'm very pleased to be here today with you to talk about how you can save money and maximize the performance of your Azure SQL virtual machine. Before jumping into the technical content, if my clicker works, oops, okay, no, let's do it again. Okay, sorry for the trouble. Well, let's introduce a bit myself. I'm an advisory engineer for an Italian company. I work for SoftGem, and I have a strong passion for everything that is related to Azure and SQL Server and more in general to the data platform. If you want to stay in touch with me, just follow the link aboutme.omegamedlab.com, where you can find all my social media references and so on. Let's have a brief overview of the agenda for today. If you are here, you'll probably want to deploy a performant Azure SQL virtual machine on your Azure subscription, or you are probably looking for a way to optimize its performance or reduce its cost. The idea behind this session started from a couple of facts. First of all, SQL Server uses a core-based licensing model, at least in the vast majority of use cases. And this means that if you assign more core to your SQL Server instance, then you will pay more licensing costs. And these costs are usually one of the biggest component in your SQL Server solution. The second fact is that if you apply a less than optimal configuration to your virtual machines in terms of sizing of the virtual machine or configuration settings at the operating system level or SQL Server level, then you won't be able to achieve the desired performance. Or if you are able to achieve the desired performance, then you are probably achieving them in a non-optimized way, and you are probably wasting money for licensing. You're probably using more core than needed. Having said that, during this session, we will go through all the key performance aspects you should take care of while deploying an Azure SQL virtual machines. These settings must be applied during the deployment phase as well as after the deployment of the virtual machines. Then, since we are talking about a whole lot of settings and configuration, I'll try to give you a couple of hints about how you can automate this kind of configuration. And as well as I'll try to give you some hints about how you can leverage some licensing features that permits you to save some money. Well, this is a session, plenty of informations, and we won't be able to go deeper on each single settings. I'll try to list every setting you should take care of, and inside the slide you will find all the links you need to go deeper on the topic and to understand the rationales that are behind this kind of advice. Let's start with the performance aspects that you should take care while sizing the virtual machine. If you want to obtain a performant Azure SQL VM, you should look for an efficient CPU. You need as few cores as possible, but efficient cores to contain licensing cost, as well as you need a ton of RAM and fast storage and fast network, especially if you are working with high availability configurations. How you can address these needs when you start diving between the plethora of different families and series of virtual machine available in Azure. And this can be a challenging task for you. And also on the storage side, you again have to deal with different storage tiers, starting from standard storage to premium storage and to arrive to ultra disks. How you can choose the right configuration for your needs without wasting money? Well, you need to understand how things work under the hood, and I'll try to show you this with this schema. Here you can see a virtual machine that is hosted on a virtualization host. And this virtual machine needs some durable disks to host its data, the operating system, the SQL Server related files, and so on. These durable disks are placed on Azure storage, so they're working as remote storage for your virtual machine because they're placed far from the virtual machine. At least the virtual machine needs to deal with some latency when it tries to reach the data on these remote disks. Apart from these disks, the virtual machine has also access to the local storage hosted on the virtualization host. On this local storage, the virtual machine can access the temporary disk, which is a volatile disk that is hosted on the local storage. So when the virtual machine migrates from a virtualization host to another, this disk, the content of this disk may be lost. So this is why it's called temporary disk. On the local storage, the virtual machine has also its portion of blob cache that is used to improve the performance of the remote storage. When you have a durable disk configured with cache settings, you can try to speed up the data access using cache heat when the blob cache is warmed up. Now, to connect to the Azure storage, the virtual machine uses a dedicated channel with its own characteristics in terms of bandwidth and IOPS, and this channel is referred as uncached throughput into the documentation. Conversely, to reach the local storage, the virtual machine has another dedicated channel, again with its own IOPS and throughput specifications, and this inside the documentation is called as cached throughput. During your sizing phase, your main goals are to select the right virtual machine that must support your workloads requirements, so the right virtual machine that offers you the right number of virtual CPUs, the right quantity of gigabytes of RAMs, and so on. And then you should match its storage capabilities with the disk subsystems. You don't want to deploy a huge virtual machines with a poor disk or vice versa, because you are probably wasting your money in that case. Let's move on and let's see what are the key specifications for a single virtual machine series. Here you can see a screenshot taken from the official documentation for the EDSv4 series virtual machines. And as you can see here, you have different sizes for this virtual machine series. At each size correspond a number of virtual core as well as a quantity of gigabytes of RAM available for that specific size. The ratio between the number of core and the quantity of gigabytes of RAM is fixed with a core to RAM ratio. In this case, is 1:8 for this specific virtual machine series. Now, how can you choose between different virtual machine series that offers you the same quantity of cores and gigabytes of RAM? You should look for the ACU value, the Azure Compute Unit value. This number expresses the result of a synthetic benchmark that compares Azure virtual machines. This is the result of a benchmark when compared to the slowest Azure virtual machine available. And this means that a higher number in terms of ACU usually means a fast CPU for that virtual machine. Moving forward, let's see what are the best practices suggested by Microsoft in terms of virtual machines selection. First of all, you should choose a virtual machine with 4 or more virtual cores. This is for licensing requirements, because you can license a virtual machine with 4 or more core. You cannot license less than 4 cores on a virtual machine. And this means that if you deploy a 2-cores virtual machine, you still have to pay for 4 cores in terms of SQL licenses, and this is not so smart. And if you are dealing with a production OLTP workload and intensive OLTP workload, you should choose a virtual machine that offers you a 1:8 CPU to RAM ratio at minimum, and this drives you to memory optimized families as virtual machines. Let's jump to the storage part. it's recommended to use a virtual machine that supports premium storage, caching, and temporary disks. In the last period, Microsoft released some series of virtual machines that, to reduce costs, remove the caching and the temporary disks, but these are important for SQL Server performance. So choose a virtual machine that support them. Then inside the highlight portion of the table, you can see the storage specification for that kind of virtual machine series. You can find the temporary disk size as well as the number of disks you can attach to that series of virtual machines. And then you can find the IOPS and throughput expressed in megabyte per second data related to the cached and cache throughput. Those are the data related to the channel I was saying before while looking at the schema. Last but not least, some virtual machine series offers you also the ability to support bursting for the virtual machine. This means that this kind of virtual machine series can, for a limited amount of time, can overcome their limits for uncached throughput. And this is useful to handle spikes in your workload. Instead of sizing a big virtual machine to handle the peak of your workload, you can try to reduce the virtual machine size and use VM bursting for support that spikes in terms of storage performance. Conversely, if you need to achieve consistent high performance on the storage side, you will probably end by using a big virtual machines that offers you huge performance on the storage side. But this usually has a drawback because a big virtual machines normally means also a high number of CPU cores that must be licensed with SQL Server. In that case, you should look for a constrained CPU virtual machines. A constrained CPU's virtual machine is a big virtual machine that offers you the same quantity of RAM and storage performance as the original size of the original big size, but expose to the operating system only a part of its core. And so, in terms of licensing, you would need to license only the available cores at the operating system levels, and this can contribute to keep the licensing cost at a lower level. Then, when talking about storage, you should also start considering the virtual machine generation you are using, because part of the storage specification you see in the table are available only if you use a Generation 2 virtual machine. Last topic really is related to accelerated networking. Accelerated networking is an interesting feature for keeping lower latency and higher bandwidth on the network interface, and it's usually useful in high availability configuration, because with the accelerated networking, you can skip to traverse the virtual switch inside the virtualization host, and you can communicate directly with the underlying hardware, and this maintains the latency lower than usual. Now, let's move to the disk side. We have seen how we can recognize the limits in terms of storage for the virtual machines. Now we need to understand what kind of disk we can attach to that virtual machine. From the list I've shown before, leave apart the standard HDD disks, the mechanical disks, because they're not suitable for anything related to SQL, apart probably backups. And let's start talking about standard SSDs. Standard SSDs is the entry level I suggest you to use for a SQL Server workload, for a dev and test SQL Server workloads. They offer quite good performance levels that increase with the accordingly to their size. But unfortunately, for this kind of storage, for this storage tier, you can't obtain a reservation for the performance. So the declared specification can be reached only if the storage subsystem is not busy. If other customers are pushing on the storage, you won't be able to reach the specifications. In a recently released feature for standard SSD disks is bursting. As we've seen for the virtual machines, again, here also the disk can overcome its performance limit for a short period of time thanks to a credit-based mechanism. If you need to deal with a production workload with a mission-critical workload, you need to choose a premium SSD disks. Again, here you can see that with the increase in terms of size of the disks, also the IOPS and the throughput of the disks increase. And with premium SSD disk, we can obtain significantly higher performance than with standard SSDs. And we have provisioned performance in this case. This means that if you pay for a specific disk and its performance, you will be able to achieve them in any condition. And premium SSD disks also support bursting, both on a credit-based way and on a on-demand way. That is a different model where you pay a fee to overcome the limit of the disks, as well as Microsoft recently released in general availability the opportunity for you to change the tier of the disks without disruption in your workload, without deallocating the virtual machine once every 12 hours. This means that you can potentially deploy a smaller disk to support your off-peak periods, and then dynamically change its tier to an higher one to achieve the higher performance tier you choose, and this can be done dynamically without deallocating the virtual machine once every 12 hours. Let's close this section talking about ultra disks. Ultra disks are the fastest disks available in Azure as of today. They offers you provisioned performance as the premium SSD ones, but they offers you sub-millisecond latencies. They are very, very, very fast. And a big difference for these disks is that they can change their size and their performance tiers in an independent way. So if you want to achieve a big a small disk with huge performance, with ultra disks you can do it, while with premium SSDs and standard SSDs that can be a problem, at least. Well, they're quite expensive, and they are subject to a couple of drawbacks, at least in my opinion. First of all, they don't support cache, and this can be critical when dealing with SQL Server, as we will see in a while. And also, they actually don't support backups. This means that you cannot take a snapshot of your virtual machine if it's using ultra disk, and this can be a huge issue in several scenarios. Now, how can you choose the right disk for your virtual machine? Best practices suggested by Microsoft for production virtual machines says that you should size your disk system accordingly with the VM storage capacity. As I was saying before, you should avoid huge difference between the virtual machine and the storage. Then you should use different disks for data and log files, because those two kinds of different files can leverage different settings for caching. Usually, when you put data files on a premium disks, on a premium disk, you should set read-only caching on that volume, and this improve read performance on that volume. For using read-only caching, you can use only disks up to the P30 1 terabyte or P40 2 terabyte, because higher premium SSD disk sizes doesn't support caching as well as the ultra disks. On the other side, for log files, you are free to use whatever you want between premium SSD or ultra disk, because they don't need caching due to the different access pattern. Usually log files are sequentially written, and so you don't need to set any kind of cache on those volumes. Then, if with a single disk you are not able to achieve the desired performance level, you can use a smaller disk and combine them together into a RAID configuration by striping them. This permits you to combine all their sizes and all their performance together. And for example, with a P30 disk, 1 terabyte disk that can reach 200 megabytes per second as throughput, if you put two of them in striping, you can obtain 400 megabytes of throughput per second. When configuring striping with storage pools on Windows, use that settings you can see here in the slide for number of columns and interleave depending on the type of workloads you are dealing with. Then, if you have to deal with a workload that is subject to short spikes, you can also consider using disk bursting to support that workload. And you should consider also to enable write accelerator on the VMs that are part of the M series family. This is typically a configuration for specific cases like SAP servers. And you should place the temp database on the temporary disk. This configuration permits you to save one durable disk for this database, and you can place the temporary disk that is recreated at each startup of the virtual machine. You should place it on the temporary disk. And this permits you to use a low latency and high throughput disk for your temp database if the size of the temp database is compatible with the available storage for the temporary disk. And this is, you can find this data in the table we were seeing before with the specification of each virtual machine size. Last point in this section, you should format your disk with a 64 kilobytes allocation unit size. That is the recommended one for SQL Server workload. This is to optimize queue depth and IOPS on the premium SSDs. Now, we've seen that you have to fight a bit to find the right storage configuration for your virtual machine, and this part of the configuration is still relevant while applying post-deployment settings at the operating system level and at the SQL Server level. All these settings can be easily resumed as this hint: do all your best to contain the stress on the storage layer. And so, consider to enable database page compression as well as backup compression to reduce the I/O through the disks. And then again, enable instant file initialization to avoid the zero filling of the data files while you are enlarging the data files, and limit the auto growth and disable auto shrink again to contain the IOPS activities on the disks. You should move all the databases, including system databases, as well as error log and trace files, away from the operating system. You should use data disks for those kind of files, because the operating system disk doesn't offer a cache setting that is compatible with this kind of file, and it cannot perform well with this kind of file. Then you should configure default backup and database file location to respect the recollocation of your database file. And you should enable locked pages in memory to avoid the pagination of the SQL Server memory to the disk. You should apply all the SQL Server performance fixes available for your SQL Server build. And you should set the SQL Server memory maximum memory limit in order to avoid contention between the operating system and SQL Server instance, and again to avoid pagination. You should enable optimize for ad hoc workloads in order to save plain cache memory for a OLTP-heavy environment, and you should apply the latest cumulative updates. You should enable query store and automatic tuning to enabling the automatic detection of execution plan regression and the remediation to this regression. And you should be sure to apply all the temp database best practices in terms of number of temp database files and so on. Then you should implement maintenance jobs on your SQL Server instance to maintain databases in a healthy state, and conversely to reduce the need for physical read on disks. You have to monitor and manage the health of transaction logs. Transaction logs should be enlarged, should be resized only during maintenance window. You should avoid using autogrow to manage this kind of extension. If you use the SQL IaaS agent extension, that is also known as the SQL Virtual Machine Resource Provider in part of the documentation, you can achieve part of this kind of a configuration automatically, and you can govern them from the Azure portal instead of inside the virtual machine. Last point in this area, you should leverage the best backup and restore strategy for your workload. For example, if you can avoid to use local disks to backup your database, and you can instead leverage the backup to URL statement that save your backups into a storage account, then you are using networking bandwidth to save storage bandwidth. So you have to carefully choose your backup strategy and backup functionality to support your workload. Let's have a brief overview of high availability and networking topics. First of all, if you work with a single virtual machine, you are covered against hardware failure at the Azure data center level, but you are not covered against fault at the operating system level or at SQL Server level, for example, a virus and so on. To gain this kind of protection, you have to implement a clustered system using always-on availability group, failover cluster instance, or whatever you want, but you need to make Azure aware of the fact you are using a multi-node configuration by putting all the nodes inside an availability set, or by distributing them into different availability zones. This gives you the warranty that at least part of the nodes will be always available even during an Azure fault or a planned maintenance. Now, here you can see different kind of native high availability technology supported on Azure, depending on your availability in terms of SQL Server version and edition and operating system version. In the upper part of the slides, you can see two mechanisms, availability groups and a failover cluster instance with storage spaces direct, that leverage on data replication at the database level or storage level. And these technologies are fast and reliable, but requires double the storage you normally need to maintain your databases. In the lower part of the slide, instead, you can see a configuration that uses shared storage with premium file shares or with shared disk. These are very interesting for limiting the cost of your solution, but they have some drawbacks in terms of performance, so you should read the documentation well to choose between the different available technologies. One thing that you can leverage with the latest version of Windows and SQL Server is a simplification in terms of networking layer. As you can see here, in front of the cluster nodes, there's a load balancer that is used to support the clustering IPs. If you use a Windows Server 2019 and a SQL Server 2019, you can switch from using a virtual network name and their related IP to distributed network name. And this permits you to completely remove the load balancer in front of nodes. And this is a great improvement in terms of easiness in deployment. Now, since we are dealing with networking with high availability configuration, you should be sure that your virtual machines are placed together in the same infrastructure to reduce the latency between them. Azure data centers are huge, and normally you don't have any form of warranty about the fact that your virtual machines are turned on one near the other. To gain this kind of warranty, you should place your virtual machines inside the proximity placement groups. This keeps the virtual machines together and decrease the latency between them. And this can be an improvement for replication, for example. What are the best practices available when talking about high availability technologies for SQL Server VM on Azure? First of all, since we don't have, we are not sure about the latency, at least if we are not using a proximity placement group, we are not sure about latency between nodes, it's recommended to relax the cluster monitoring parameters. This may avoid unwanted failover of the cluster due to spikes in latency between nodes. You should place all your nodes in a single availability set or different availability zone. And you should use one network interface per cluster with a single subnet, because the networking layer in Azure is already redundant. And so you don't need to add any additional network interface to your cluster system to support Herbit and so on. When you are dealing with clustering configuration and you are talking about clustering quorum, you should assign a odd number of votes to your cluster. And if you are working with disaster recovery configurations, you should remove the vote from the DR nodes. So for example, if you are creating a hybrid configuration between on-premises and Azure, usually the Azure nodes shouldn't have any vote, because they cannot compete with the on-premises node for failover management. And again, you should carefully monitor your virtual machine performance, because if the virtual machine is under stress, it may cause unwanted failure, especially if you do not relax the cluster monitoring parameters. If you are using always-on availability groups, is again suggested to consider relaxing the monitoring mechanism of the availability groups, other than relaxing the settings at the cluster level. Then you need a way for you to speed up your client reconnection after a failover. And you can use different ways to achieve this result by using, for example, the multi-subnet failover through inside the connection string, or you can, for example, avoid using a distributed network name or load balancer for basic availability groups if you use a database mirroring connection strings. These are options for you to simplify your life and speed up the client reconnections. Okay, that's all. Both in terms of settings you should apply at the during the deployment phase and during the post-deployment phase. It's a huge amount of settings and configuration. How you can automate them? Well, you can leverage an infrastructure as code approach. You can create, for example, a bicep file or a non-template file, or you can use third-party tools like Terraform, Ansible, and so on to create a script that manage the hardware configuration of your virtual machine. Then you can, with this tool, you can script also the setup of your SQL IaaS extension to simplify the management of disks and storage settings for your instance. This is very useful to keep your infrastructure as code files simple. And again, for everything that cannot be managed at Azure level with Bicep and ARM templates, you can inject inside this kind of files custom script extension or PowerShell DSC extension that permits you to run PowerShell scripts. And with some different modules like the awesome DBA-Tools module, you can then apply all kind of SQL Server configuration at the operating system level inside the virtual machines. If you want to have a look to a real use case for this stuff, you can look inside my GitHub repos. I published here the link for an ARM template I normally use to deploy production-ready SQL Server VMs, and this uses all the techniques I was talking about. ARM template and custom script extension and the PowerShell DSC to configure the virtual machine once it's deployed. I also linked a new version of this template made with Bicep, but it's still a work in progress. The repository is still empty right now, but I'll try to populate it during the next days. Last section, let's briefly talk about licensing tips. Well, you can leverage a couple of functionalities of features of the new licensing model of SQL 2019 to reduce the need for licenses when you are implementing a SQL Server solution. In this case, the case depicted here in this slide, if you are designing a hybrid disaster recovery solution and you have SQL 2019 licensing model covered with software assurance, you can gain some different passive nodes for your system without having to license them. In this example, you can see you have an active server that is fully licensed with software assurance, and with software assurance, you gain the right to deploy an additional high availability node, a synchronous node with automatic failover on premises for high availability purposes, as well as a passive node without automatic failover for disaster recovery purposes on premises, and an additional disaster recovery node deployed in Azure, again, free for the licensing point of view. This means that this 4-node system requires only licensing for one node, while with the old SQL 2017 licensing model, cross-premises designs required licensing also for the remote node. This is a huge improvement. And another benefit you can leverage while migrating to Azure, if you have a software assurance on your SQL Server licenses, is Azure Hybrid Benefit. With Azure Hybrid Benefit, you can reuse your existing SQL Server licensing in Azure. And you can also leverage an interesting conversion factor while moving licenses from on-prem to Azure. For example, if you have one standard core licensed on-premises, you can obtain one general purpose or hyperscale core if you want to target an Azure SQL database solution, or you can obtain a SQL standard Azure SQL VM core if you are targeting a traditional virtual machine deployment. So this is a one-on-one conversion ratio. But for enterprise cores, with one enterprise core on-prem, you can obtain one business-critical core for PaaS on Azure, or one SQL enterprise core for virtual machine, again on Azure. Or say if your workload can tolerate a downgrade to the standard version, you can convert your existing enterprise core into 4 cores, general purpose or SQL standard on virtual machine. And this is a really interesting conversion factor, especially if you have a system license for maximum virtualization on premises, and this permits you to migrate to a huge amount of cores on Azure. Well, I think that it's enough for today. We were plenty of concepts. It was a strong session. So I can leave you with some homework, and I can leave you some links to a demo repository where you can find scripts to create a different kind of high availability solution with Azure virtual machines for SQL Server, failover cluster with storage spaces direct, shared disks, always on availability groups. You can test whatever you want. Then I've linked my ARM templates and the Bicep version, as well as the official documentation that contains all this information I shared with you today, and a link to the incredible DBA Tools module. If you don't know it, please have a look at that site, because you can find an incredible way to automate your deployment. That's all for now. Grazie. Thank you for your patience. If you have any question, feel free to ask. I'm here for you.
That was great, Marco. I mean, I'm not a very seasoned developer, so it went all over my head, to be honest. But I definitely believe everyone watching would get to learn a lot from it, because he covered a lot around Azure SQL in just about 45 minutes, and that was absolutely great. There were some questions coming up from the comments and from the internal channel. People were just asking even the other days that is it possible to migrate maybe from Oracle to Azure SQL? Is that possible to do it? Who provides the service? Is it like Azure SQL provide the service, or is it like Oracle provide the service?
Well, there's a tools from Microsoft, the SQL Server Migration Assistant, that can assist you in translating your Oracle database to a SQL Server database, and then you can define what kind of Azure SQL service you will need to host that kind of database. You probably, by using in conjunction the Database Migration Assistant, you can then understand if you need any feature that requires a virtual machines, or if you can jump directly to an Azure SQL PaaS service.
One final question, Marco. I mean, now since we say that Azure SQL is like what we call it, they call it versionless. I don't know, right? If it's versionless, how do I go ahead and how do I know which version is it? Is it like latest, or how does that gets managed?
The build version of the Azure SQL you are meaning?
Yeah.
Okay.
Yeah.
Well, this is the big difference between virtual machine and PaaS services. With virtual machine, you are free to install whatever you want. So you are controlling the build version of your SQL on Azure. On the other side, with PaaS services, you have no way to control that. You are always on the latest build. And this is automatically managed by the system. So you should start developing your database against the compatibility level instead of testing them against the build of SQL Server. Because as of now, the compatibility level should ensure you that if you migrate your database on a more recent version of the SQL Server build, and if you keep the same level in terms of compatibility level, you won't suffer for any regression in terms of performance. So this is a change in the paradigm you should use for developing your databases.
That's perfect, Marco. That was absolutely great. I believe everyone watching now and maybe later on once we archive the session, we'll definitely get to learn a lot from your session. Any final thing, Marco, you want to plug in before we move to the next session?
No, well, I would like to say a huge thank you for having me here today. It was very interesting to prepare this session.
Yeah, thank you, Marco. I really appreciate it. We would love to host you back whenever we are available. And we do many events around the year. We have .NET Virtual Conference coming up, Blockchain Virtual Conference coming up. So we'd love to host you there. Thank you so much, Marco, once again. And yeah, hope to see you soon. Have a nice week ahead. Bye.
Thank you, Simon. Bye-bye.
All right, now we move to our next session. I think we still have about a couple of minutes. So let's take a break of 1 minute and then we will be back.
Script Runner, the #1 for PowerShell management. We get it. You were hoping that PowerShell would save your day, but you figured out that it is not user-friendly for non-experienced colleagues. Managing the increased demand on IT is a growing challenge, and running scripts manually is still very time-consuming and complex. Welcome to Script Runner, the #1 for PowerShell management. Script Runner runs on PowerShell scripts. It combines everything you need to efficiently manage and automate your complex IT infrastructure. With Script Runner, you'll be able to make it easy for your team to perform administrative tasks without any knowledge of PowerShell, have a transparent overview on all PowerShell activities, and most importantly, free up your IT resources for more relevant tasks such as innovation and development. Download your free trial now and unlock the power of PowerShell.
All right, that was a quick commercial from our sponsors. If you want to know more about our sponsors, please go ahead and check the description or the Azure Summit.live website. Oh my goodness, I sound like a radio jockey. And yeah, let's move to our next session. It's by Sam Kogan. Sam is a solution architect and Azure MVP. He was recently a guest at Rocking the Code will be .NET Dev live show where I got to meet him behind the scenes. And today he's going to talk about state of Azure infrastructure as a code. So let's go ahead and invite him to the Cloud Summit 2021. Hi, Sam. Welcome to Cloud Summit 2021.
Hi, Simon.
How are you doing today?
I'm great, thank you. Very well. Hope it's all going okay over there.
Yeah, everything is going okay. And Sam, quick question. Are you also speaking at the Azure Serverless conference?
I'm not. No.
Oh, no. Oh, sorry. I messed up. 11 days is very too long for me.
Absolutely.
Yeah. So, Sam, I'm really looking forward for your session, right? So, please feel free to go ahead and share screen and then we can get started.
Okay, let me...
.NET says, hi, Sam.
Hi there.
All right, so Sam, I see your screen. I have added it to the stream. Everybody else can see it. And next 45 minutes is all yours.
Great. Okay, thanks, Simon. Yeah, so today we are going to have a look at my session. We're going to talk about the state of infrastructure as code in Azure today. So I spend a lot of time working with people, both in my day job and community things, talking about infrastructure as code. I think it's a really great way of building your infrastructure and moving away from using the portal and clicking on things. But a question that comes up a lot, particularly today, is where do I start? What do I use? There are so many options for infrastructure as code. I don't know what's good. I don't know what I should be looking at. Where do I go? So what we're going to talk about today is what's available, what the different tools you can use for infrastructure as code, and perhaps why you would choose one over another. As I said, my name's Sam Kogan. I'm a solution architect with a company called Willis Towers Watson and a Microsoft Azure MVP. I blog a lot about Azure and particularly infrastructure as code pieces on Azure. So if you're interested in any more information, you can just check out my blog at samkogan.com. And all of the slides and the samples from this session are going to be on my GitHub account. So if you want to check those out, you can do so at github.com/sam-kogan. Okay, let's get started. So just a quick refresh for anyone who's come into infrastructure as code the first time. What is it? Obviously, from the name you can make out it's the fact that we're declaring our infrastructure in code rather than going into the Azure portal and clicking on new VM or something similar. But there are some characteristics that make up what infrastructure as code is really compared to some other approaches. And you see on the screen here, we're talking about those. So things like the fact that infrastructure as code is generally declarative. You are declaring what you want to deploy rather than how you want to deploy it. It's generally idempotent, so that you can run the same piece of code over and over again, and you'll get the same results at the end of it. It's immutable, generally, so you quite often will want to deploy, when you're deploying new versions of your infrastructure as code, you will often want to sort of destroy and recreate your infrastructure rather than trying to upgrade and fix existing ones. And particularly when you get to a point where you've got problems with a resource, you might want to say, okay, well, I'm just going to destroy that and recreate it rather than messing about trying to diagnose a problem. It's the whole cow versus pet approach. Infrastructure as code allows you to make reusable libraries of modules so that you can actually share and reuse code that you've created your infrastructure with. It can be modular so that you can build specific units of work in your infrastructure as code, and quite often you can use it to correct drift. So because of the fact that when you run your code, you get the same result every time, you can do things like run it to correct when somebody's made a manual change or somebody has updated something that they shouldn't have or so. So infrastructure as code generally falls into those sort of categories. And the reason why you might want to look at it is really around some of the benefits you can get. These are sort of the 8 top benefits that I pulled out here. There may be well more than that, but these are the ones that come up the most often. And one of the big things, if you're going into the portal and you're deploying resources by hand, you're clicking on new VM and so on, you will invariably do something different the second time you do it to the first time. And you will get slightly different configured resources. If you move to using infrastructure as code, you're declaring what you want in the code. It's not changing every time you deploy it, so you get the same consistent results every time. And if you use that to deploy 1 VM or 100 VMs, or maybe a dev, a test, and a prod environment, you can be sure you're getting the same results across all of those. Speed is a big factor. So if you're deploying resources by hand, it's obviously going to take you time to go and click all the buttons and so on, but also you're generally doing it one at a time. If you need to deploy 20 virtual machines or 100 storage accounts, you can write the code once, you can parameterize it so that you can feed in some parameters to affect the name of the resource or the type and so on, and then you can run that with a loop to say I want 100 and you'll get them, and often they'll be deployed in parallel, so that it's much quicker, that approach as well. By using infrastructure as code, you can use all of the common tooling you get around code. So you can put them in a Git repo. You can use version control. So you can collaborate on this code in the same way you would as normal application code. So it makes working in teams much easier, particularly if you start going down the route of building modules and reusable code. That sort of the team collaboration becomes really easy. You've got accountability now because the code, again, is probably in a version control system. When somebody makes a change, they're not just going into the Azure portal and changing things and you don't know who did it. Now someone's got to go in and make changes to the code. It's got to go through your version control. You can see who did it. Maybe you've even got a test process, a pre-release gates, and so on. You can apply all of that to your code. It's scalable because, again, you can build your code so that it can support one of something or it can support hundreds of something. And the actual code you write isn't really any different. You can build things to be as big or as large as you want. We talked really about, you can version control things as well, so you can have different versions of your code. If you build modules, you can have versioned modules that allow people to pick and choose which version they want to use. They can control when they upgrade and all those sort of things. Because you can treat it like code, you can do things like testing with it. You could run unit tests, integration tests, all those sort of things. You would do with normal code. You can do with infrastructure as code. And when it comes to documentation, you've got part of it already done for you, because your infrastructure as code is part of your documentation. You can comment it, you can add XML attributes and so on to actually create documentation around your code. And it does some of that work for you. But even when you've got to write manual documentation, it's much easier to refer back to the code. So there's a lot of benefits around using infrastructure as code. But we come back to our original question. How do you get started? What tooling should you use today? What does the estate of infrastructure as code when you're working with the Azure cloud today look like? Okay, so we've really got 5, maybe 4. Actually, there's one missing on there, so we are going to talk about it. I'll add it on when we get to the end. So that's my fault on the slide. But we actually got another option. But we can work through these. So we've got things called ARM templates, which is a Microsoft tooling. And I'm going to go into each of these in detail in a minute. We've got Bicep, which is another Microsoft tool. We've got Terraform, which I think most people probably have heard of. We've got Pulumi, which is a bit of a newcomer, but is growing in usage. We've actually got another one that's not on the slide that I will update, which is one called Farmer, which is more of a community-based open source tool. And then we've got PowerShell or CLI, which we're going to talk about, but it isn't really infrastructure as code, but we'll talk about where it fits into this sort of set of tools. So let's go have a look at each of those tools and see what they are and why we might use them. So first up, we've got ARM templates, or we give it the full name, Azure Resource Manager templates. So these are the Microsoft native infrastructure as code tooling that Microsoft released with their platform probably 6-7 years ago, that allows you to write infrastructure as code to deploy to Azure, which is supported by Microsoft. It's a DSL, it's not a full programming language, and it's based on JSON with a lot of custom functions and attributes added onto it. And we'll see an example of this in a minute. ARM templates are stateless, and we'll talk about this quite a lot in the next few slides. So maybe it's worth explaining what I mean by this now. So when we talk about stateful or stateless infrastructure as code, we're talking about whether or not the tooling itself tracks the state of your resources in Azure. So for Azure Resource Manager, it doesn't have its own state process. Its state effectively is the state of the resources in Azure at the time you look at them. So it doesn't track it by itself. Some of the other tools we'll look at, like Terraform and Pulumi, actually track state for themselves, which has a number of benefits we'll talk about in a minute. But it has some downside in the fact that you've actually got to manage that state. You've got to look after the state file, because if that gets damaged or corrupted, that can cause issues. Whereas with ARM templates, there is no state, so you don't get some of the benefits, but you don't have to manage that state file. Another point about ARM templates is they are closed source. So the code that actually interprets your ARM templates and does the deployment and so on is not something that Microsoft have open sourced. You can't look at the internals of ARM templates. You can obviously look at the JSON code and so on, but the ARM fabric that interprets those and deploys your resources is closed source. So let's have a quick look at what an ARM template looks like. So this is a very simple ARM template we've got on the screen here, and all it's doing is deploying a storage account. You can see that it is based on JSON, so it's fairly, if you've ever worked with JSON, it's fairly obvious that what it's doing. It's got a number of properties, and it has a schema that Microsoft have created for the JSON file. And so there are certain sections. There is a parameter section which allows you to feed data into your template. And we've got a couple of parameters here for our storage account. We're passing in a parameter that allows you to define the name, so what you want to call the storage account, and a storage account SKU option, which allows you to provide information on the type of storage account you want to create. So, do you want to locally redundant, geographically redundant, and so on. We then have a functions section, which allows you to create user-defined functions, which I'll already go into today. We have a variable section, which allows you to create effectively constants within your template. And then we have the resource section. And the resource section is where you'll do most of the work. And this is where you would actually define the resources. So we want a storage account. And so every resource in an ARM template is defined by this type function. And there are, basically a schema of resource types. And in this case, we're looking at Microsoft.storage/storage accounts. Everything has a version. So that's the API version. You can see here it's using this 2019 0601 version. And then you have some properties that you applied related to the actual storage account. So things like the location, where do I want it deployed, the type of storage account, and the SKU of the storage account, which is where we feed in that parameter previously, where we picked whether it's locally redundant, geo-redundant, and so on. And so we feed all that in. And you can define any resource in Azure in an ARM template. One of the big benefits of this being a sort of native tooling is the fact that any new resource that gets created will have functionality in ARM templates. So you can create complex ARM template files that deploy lots of different resources. You can have dependencies. You can have results from one resource feeding into another one. You can even create modular resources using a concept called nested templates. Which would allow you to build reusable code and have that feed into another top-level template. And so the downside with ARM templates primarily is that they can be very verbose. There's a lot of JSON syntax here. It can be quite hard to read, particularly if you're actually writing very complex files. If you start using nested templates, it can be quite difficult to work your way through the different levels of nesting. And that they can be quite difficult for people who are new to using infrastructure code to get started with. And so for that reason, and because of what we're going to talk about in the next slide, generally nowadays, at least at the moment, I would say to people that it's probably a good idea not to use ARM templates. Obviously, if you're using them currently and they're good for you, that's fine. But if you're a newcomer coming into the world of infrastructure as code in Azure, I would say ARM templates are perhaps more legacy now, and I wouldn't suggest you use them. And that's primarily because of what we're going to talk about next, which is tooling called Bicep. So Bicep is, again, produced by Microsoft and is an abstraction built on top of ARM templates. And so this is Microsoft's attempt to make ARM templates easier to use, easier to get started with, and just generally simplify the concept so that people who are coming to this for the first time have a much better time. And so if you're looking to use these sort of Microsoft native toolkits, I would suggest Bicep is where you should start. So Bicep itself is still a custom DSL. It's, again, not a full-fledged programming language. It's a DSL. But it is designed to be, a lot simpler. And actually what it does is it's not a replacement for ARM templates. It's actually an abstraction that sits on top of ARM templates. So you write your infrastructure code using the Bicep language, but when you come to actually want to deploy it, it actually compiles that into an ARM template. And it's the ARM template that gets deployed. And this is quite clever because it means Microsoft can still use all the existing tooling that exists for deploying ARM templates they don't have to change any of that, but the language is something that can be changed. So when you write your code using Bicep, you then run a command that spits out some ARM templates and you then deploy them. But those ARM templates are generated automatically for you. You never actually have to do anything with them. You don't even have to read them. You can just deploy them. And there's even a lot of tooling nowadays, including some Azure DevOps extensions and some of the CLI coding, which means it will do that for you. So you never actually have to touch the ARM templates at all. You tell it to deploy the Bicep file, and it will just go ahead and compile it for you under the hood and deploy for you, and you won't ever see the actual underlying ARM template. Bicep are similar to ARM templates in that they are still stateless. Again, because they're using ARM under the hood, they kind of take a lot of the factors from there. But the Bicep code is open source. So you can go and see the actual code that creates the Bicep that does the compilation into ARM templates. You can submit pull requests and issues and so on through GitHub, and the team there are very, very responsive and very happy to have people help them. So yeah, it's much more open than the ARM template world was. So let's have a quick look at a Bicep file. So this is the same process as with the ARM template. So we're deploying a storage account, but you can see already from this that it is significantly simpler. It's only 14 lines of code compared to 45 for the ARM template. So it's much, much simpler. We've still got the same functionality. We've got parameters, we've got variables, but instead of needing multiple lines of JSON to declare a parameter, you can do it much simpler in a single line. You can do more complex things with it. So you note here in the storage accounts, I don't have those, what do you call them in ARM templates? We have these allowed values. I don't have them here. So you could actually pass anything you want into this value as a string. You can add those. So Bicep has the functionality to add those, and then it will get a little bit more complicated. You'll have a few more lines, but even that has been streamlined to make it much easier to read. And when we get to the actual resource, you can see we've got pretty similar information. We've got the actual resource type and the API version declared, but now it's declared in the header of the resource. And then inside the resource, we've got the actual properties and so on, as with before. So it's not that different in terms of what you're actually doing in the resource, but it's a lot simpler to read, and it's a lot easier for people who've never seen this before to get started. As you start doing more advanced things as well, it becomes even clearer that it is easier to use. And modules are a really key example of that. So I mentioned with ARM templates, you can create reusable code using nested templates, but it made things pretty complicated. They were quite deep nesting. You had to move through different files and track your way through to find what you were looking for. In Bicep, you can create what are called modules, which are reusable code, and you can then pull them into your templates to run them. They're very easy to create because you just create a file, you create your module in it, and then you say in this document, I want to pull in this module from that file, and that just works. Behind the scenes, that gets compiled into is nested templates. It's using the same technology, but again, you don't have to deal with that. And so it makes it much easier to use. You're not having to deal with multiple levels of nesting. You're not having to try and find your way through all those different levels and so on. So it is much, much easier to use than ARM templates. Now, Bicep still has a lot of the features of ARM behind it. So depending on your view, the same downsides with ARM templates might apply here. The lack of state, if you're particularly keen on that sort of approach, which we'll talk about more in a minute when we talk about Terraform. But it is easier to use. So those are the two options that you provide if you want to work with native Microsoft tools. We'll have a look at some third-party options now. So the first one up, and the one that most people have heard of, is probably the biggest tooling set in the infrastructure as code world, is Terraform by HashiCorp. So Terraform is a third-party toolkit that is a multi-platform infrastructure as code. You might have heard referred to these as multi-cloud, but I'm not going to use that term because they do more than that. So Terraform allows you to write infrastructure as code for multiple different platforms. So not just Azure, you can do AWS, you can do GCP, but you can also do non-cloud services. You can write code for things like Kubernetes. If you have a Kubernetes cluster, you can use that. You can even write code to talk to GitHub or Datadog, or lots and lots of other services. So they have libraries for doing all that. So it's a sort of a common language for writing infrastructure as code across multiple platforms. One misconception to get out of the way that some people think is it's not completely interchangeable. So when you write code to deploy a virtual machine to Azure, it is different code than deploying a virtual machine to AWS. I've talked to people when they first get started who think you can write a sort of a generic virtual machine code and deploy it to any cloud. That's not how it works. You are writing code specific to that platform, but you can write a Terraform file that deploys a VM to Azure, then deploys a VM to AWS, then maybe creates a Kubernetes cluster in GCP and deploys some resources into that Kubernetes cluster. You could do all that in a single Terraform project. As I mentioned, this is a third-party tool, so it's supported by the HashiCorp, the company that make it. They have paid support options, or there is a lot of community support. And I say being one of the biggest tools that people use for infrastructure as code, it does have a lot of community user base and support. It's again a DSL, not a programming language, and it is a custom DSL that's been written by HashiCorp called HashiCorp Configuration Language. And you'll see that it looks very similar to Bicep, and I suspect Bicep took its inspirations in some areas from Terraform. Now, Terraform is a stateful language, unlike ARM and Bicep. So Terraform maintains a state file. So whenever you do something to deploy a resource or delete a resource or whatever, it records this in this state file, which is separate to the state that's in the actual what the cloud looks like today. Now, they should usually be in line, but one of the issues with state is if two diverge, you can have problems. But the benefit of having a state file is the fact that you can do things like previews, which allow you to determine what's going to happen when you deploy a template before you actually deploy it. So you can run Terraform plan. Sorry, I've used a lot of Terraform recently. So Terraform plan, which will allow you to then basically will show you what it's going to do, and you can have a look at that and say, okay, well, I was expecting it to do this, and it's actually doing this. Okay, what's going on? It's going to delete a resource. I didn't think it was going to do that. Why is it doing that? So that's one benefit of state. The other is it can clean up after itself. So when you run an ARM template or a Bicep file, when it's deployed the stuff, it's kind of forgotten about the stuff that's in Azure. So if you want to delete everything you did in the deployment, you need to go in and basically just delete the resource group or delete the individual resources. With Terraform, with a stateful language, you can actually just say Terraform destroy, and it will go and delete everything it created. And this is pretty important when you start doing things beyond just deploying Azure resources. One of the most common ones I see is that quite often you deploy Azure AD service principals to go with an application. You don't generally do that with ARM templates or Bicep. They don't have the functionality for that. So you might do it manually or maybe some PowerShell. And then you come and delete all your Azure resources and you forget about the service principal. And that's now sitting in Azure AD for a long time. So with Terraform, you can deploy all of those things with it. But that also means you can then have it keep track of them and it can destroy them for you. Again, Terraform is open source as well, so you can go and have a look at the code and you can submit pull requests. You may have seen in the news recently that Terraform have actually stopped accepting community pull requests, I think because they are pretty overloaded and don't have the staff to deal with them at the moment, which is a little disappointing and perhaps a little bit worrying. But they in the past, they have generally accepted community pull requests and helped in that way. Terraform, like most third-party things, has an enterprise version that you can use. So the open source version you can use for absolutely free. The enterprise version adds some capabilities. It has a cloud service for storing your state. It has a module library, and it has some policy as code options as well. So if we have a quick look at some Terraform code, and you can see straight away it doesn't look that different from the Bicep code. So we've got a few extra things. So we've got this provider function in here because Terraform works with multiple clouds. We need to tell it which cloud we're going to work with, or even multiple providers. We need to tell it what provider we want, so we're using the Azure one. We're having it create a resource group. We didn't do that in the ARM or the Bicep template. You can do that, but the way ARM and Bicep work with the concept of scope makes it a little bit more complicated, whereas with Terraform, you can do that right in the same file. And then we're creating the storage account. And you can see, it's given all the same properties and so on. But one of the things you don't see here is the API name and version. So you are telling it that it's an Azure storage account, which is kind of the Terraform name for the resource, but we're not giving an API version. Terraform abstracts away from that, which can be a good or a bad thing, in that Terraform needs to update their libraries every time a new version comes out. So you can't just update the API version. You have to wait for Terraform to release a new version that uses the new API version. And usually they're fairly quick on that. But if there is a delay, you're stuck using the old version until you can get them to upgrade. And so that's one of the benefits of the tooling of Bicep and ARM is that because they're produced by Microsoft, they get the latest updates straight away. Whereas something like Terraform, you've got to wait for them to catch up. But because it is an abstraction on top of the Azure REST APIs and so on, they can add more functionality. They can add, they can deal with some of the inconsistencies and so on in the ARM API, and they can add additional functionality if they want. Yeah, we're deploying our resource, and then we've got an output here. We didn't have any outputs in the other modules, in the other languages, but we can do that. This just allows you to pass results out of your template when you run it. In this case, we're passing out the connection string for the storage account. You can see, again, fairly similar to Bicep, fairly straightforward. There's not a lot of superfluous brackets and semicolons and so on, and so it can be relatively easy to pick up. Once you start trying to do some more advanced things in Terraform, you can find it gets a little bit more difficult as a new user. So when you start trying to do things like loops, particularly like for each loops, which it has the capability to do, because it's not a true programming language, it's a DSL. There are some boundaries and some limits you might hit in terms of what you can do with that. That's probably one of the sort of biggest issues I have with Terraform is when you start to do some really advanced and complicated stuff. The nature of a DSL can make that a bit more difficult. Okay, on to the next tool I'm going to talk about is Pulumi. So Pulumi is quite a lot newer than Terraform, but it's a similar approach. It's a third-party multi-platform IaaS solution, and it again can deploy to lots of different clouds, things like Kubernetes, GitHub, all those different sort of things. It can still do the same thing, but the big differentiator between Pulumi and Terraform is the fact that Pulumi is not a DSL. It is a programming language, or it uses real programming languages. So you write your infrastructure as code as one of Python, Go, TypeScript, and .NET. So you can write your infrastructure as code in the same programming language that maybe you're writing your applications in. And so some of the downsides we talked about with Terraform there in terms of when you're trying to do more advanced things like loops and iterations and so on become easier in something like Pulumi, where you can use actual programming concepts. So you can just write a normal for loop in Python or C# or so on. So yeah, there are potentially some real benefits if you are wanting to work with a real code programming language. Obviously, it's going to depend on what your users are. If you've got developers who are looking to do infrastructure as code, this can be a real benefit. But if you've got infrastructure people and IT ops people who don't write code as their day job, that can actually make things more complicated. And there are some downsides to using code in terms of how you have to work with programming concepts, particularly asynchronous concepts, when dealing with resources that take time to deploy. But it's a very interesting concept. Like Terraform, Pulumi is stateful, so it maintains a state file, and you can do all the same things. You can do a preview and you can destroy things and so on. It's all open source. And again, there is an enterprise version, which is very similar to the Terraform one in that it provides cloud state storage, policies code, logging and all that sort of stuff. So the Terraform and Pulumi are fairly similar in terms of what they provide, apart from the fact that they use the different programming languages. The fact that you're using a real programming language with Pulumi does also then bring some additional benefits. So one of the things that they've recently released is an automation API, which allows you to turn your infrastructure with code into full-blown applications. So maybe you wanted to build an API that you could then somebody could call to deploy resources inside your company. You can actually do that natively with the Pulumi automation API, whereas with Terraform you'd have to build a lot of controls on top of that to make that work. So let's have a quick look at Pulumi. So we've got a Pulumi project here. I've written this one in C#. Obviously, as I mentioned, you can use multiple different languages. I chose C# because I know C#. But you see it's not all that different from Terraform. Again, we're doing the same thing. We're deploying a storage account. We're creating a resource group like we did with Terraform. But you can see there it's using programming concepts from C#. So I'm putting the results of that resource group into a variable. I'm using this sort of method approach to do that. When we get onto the storage account piece here, you can see we've got the sort of expressions and similar sort of thing that we would do in C# to deploy those resources. Now, it can take a little bit to wrap your head around the fact that you're doing declarative code within a sequential programming language. It takes a little bit of getting used to. But one of the benefits of doing that is the fact that as well as using the Pulumi code here, I can actually insert any old C# code within this program as well. So yeah, say something that there was something in there that the language didn't support, the Pulumi language, I mean, that I wanted to call out, or one of them recently, I needed to call a webhook once I deployed a resource. Pulumi itself doesn't have a concept of calling webhooks, but I can just write some C# REST calls in here to have it call out to that webhook, and that did work just fine. So you've got the full capabilities of that programming language. But the actual Azure resource deployment pieces here is fairly straightforward. You can see there I'm creating the storage account, then I'm creating an output to get the primary key of the storage account. Now, this is possibly where there is a little bit of a difference and perhaps favor towards the Terraform side if you're looking for simplicity. So the Pulumi libraries are, or at least the latest one, is based around the Azure REST API. They're generated based on that. And that's quite a big benefit compared to Terraform because it can cover 100% of the API. But what that means is they are restricted to what the API offers rather than Terraform, where they are adding layers of abstraction on top of it. So with Terraform, you remember on here when we wanted to get that connection string, we just had this single line. Whereas with the Pulumi option, we actually need to use this method here, which is a little bit more complicated, to go and get the primary account key from that storage account using behind the scenes what is the REST API. So it's a little bit more verbose in this respect. So there is a balance here between the power of using this full programming language with it being a bit more verbose. Okay. And the last tool we're going to talk about, or at least the infrastructure code tool, is one called Farmer. So Farmer is another third-party tool built by a company called Compositional IT, and it has a lot of community support as well. But it is, again, it's a kind of a cross between Pulumi and Terraform in that it is a DSL to some extent, but it's based on the F# language. So what you're writing is actually F# code, but it's sort of extracted away a little bit, and it's a bit simplified by the fact that it is a basic DSL on top of that. It's a little like Bicep in that it compiles to ARM templates under the hood. But again, you don't have to actually deal with those ARM templates. You can have Farmer deploy them for you. It's stateless because, again, it's using ARM templates, so it follows the same process. And again, it's open source. And so let's have a quick look at what that looks like. And so we've got our Farmer program here. And you can see, again, it's fairly straightforward. If you've ever used F#, it's using that sort of functional approach. But again, it doesn't look that dissimilar from Terraform or even the Bicep approach. We're just deploying our storage account. We're giving it the values. We're giving it like the SKU here, which they have a selector for, so you can make it very simple. And then this section here is what actually handles the deployment for you and runs the ARM template, so you don't have to deal with it. So Farmer is another option that uses this functional approach to abstract away from the complexity of ARM templates. And then I've just mentioned PowerShell and CLI. It's not really infrastructure as code. It's not idempotent, and it's not with declarative. So I generally wouldn't recommend you use it as a platform for building infrastructure with code. However, it might have a place. If there is something you really can't do in another language, then maybe as part of your deployment pipeline, you add in a PowerShell step to do that, because moving away from declarative to the more scripted approach of PowerShell, you may be able to do what you need to do there. But I would generally consider it as a last resort, and I'd look at some of the escape hatch options that are in languages. Like with ARM templates and Bicep, you can use script tasks where you can actually run a script in a container. With Terraform, you can have the local execution option to run something directly from inside Terraform, and that may be calling a PowerShell script, but that gives you that option. With Pulumi, you could write just in your language of choice to do that. So look at whether or not there's an escape hatch in the language to use when you can't use the native language before dropping out and looking at PowerShell. So then the question comes, well, which one of those do I choose? There are so many options, and they all look cool. What do I use? And it's going to come down to your preferences and your requirements. But there are a few things that generally are the most common reasons why you pick one language or another. So firstly, this is probably the most common one that comes up. Do you need multi-platform support? Do you need to deploy to more than just Azure? Do you want to deploy to AWS, GCP? Do you want to be able to deploy Kubernetes clusters and then deploy resources onto them? If you need that multi-platform support, then really you don't have an option. You need to use one of the third-party options, Terraform or Pulumi, because they're the only ones that will support multiple clouds. You don't want to be writing, Bicep for Azure and CloudFormation to AWS. You want to use a single language, then one of those tools will be the choice for you. One that also comes up a lot is that you need support for your tool. You want to be able to raise support tickets and so on. You already have a support contract with Microsoft. They are the vendor, your vendor of choice, maybe. And in which case, if you want that approach, then you would use the Microsoft created tools of ARM templates or Bicep. As before, I would use Bicep. Also, I guess this one also factors in, if you want the new resources quickest, then you would use a Microsoft supported tooling as well. So maybe that will drive you down that path. Maybe you want to actually write your infrastructure code in a real programming language. And this comes up a fair amount, particularly when you're talking about teams who are developers. They want their developers to pick up writing their infrastructure as code, and they don't want to learn another language. They don't want to go and learn Terraform, DSL. They don't want to learn Bicep. They already use Go or Python or F#, and so they want to continue using that. In which case, your options really are Pulumi or Farmer. Pulumi obviously has the most choice. You have those multiple different languages. So if you're using Go, TypeScript, Python, .NET, then that would be the obvious choice. Farmer obviously restricts you more to F#, and it's not entirely native F#. There is a bit of a DSL on top of that, but it is closer to a real programming language than some of the other options in there. So those are the two options if you want to go down that route. If you want the benefits of state, so you want to be able to do previews, you want to be able to do destroys, you want to be able to perhaps use the state programmatically outside of deployments and so on, then Terraform and Pulumi are the options. They're the ones that have a state file, and you get the benefits of having that by using those tools. On the other hand, if you don't want to manage that state file, and managing a state file can be a pain, and you've got to make sure it's secure. There can be secrets in there. You've got to make sure it's backed up. You've got to make sure it's not going to be accidentally deleted or overwritten. And so there is a downside to having that state. If you don't want to have to deal with that, then you can use one of the stateless options, which is ARM templates, Bicep, Farmer. And there's a table here. I won't go into this in every detail, but if you want to have a look at the slides afterwards, just giving you some comparison of the different options and why you might make your choice based on one of those factors. So, is it the language? Is it the multi-cloud support? The statefulness? Maybe even open source. Maybe you want to make sure that you use an open source tool set, in which case your ARM templates are probably off the table, but the rest of them are pretty okay. And maybe you like some of the benefits of the enterprise functionality that Terraform and Pulumi offer. There are some nice features there, particularly some of the policy as code. If you want to be able to control what your users can deploy, so not just that they can deploy anything they want, but you want to maintain. Say they can only deploy these sort of VMs, or they can only deploy these regions, and you want to abstract that away from the cloud provider's policy. Again, if you're doing multi-cloud, and you want to make sure your policy is applied regardless of which cloud you're using, and some of those enterprise features might be something you're interested in. This question comes up a lot when I talk about this sort of thing. As someone, well, should we change the language we're using at the moment? And my answer generally is, well, it depends on what you want. If you're happy with the language you're using at the moment and it's doing everything you want, then no is the answer I would say. You don't want to change language just because you want to use the latest cool and trendy options. You want to change a language if you think there's a benefit. Does it add value to your process? Now, if it does, if moving, let's say, from a stateless to a stateful language will really make your process easier because you really value the ability to do previews, then there is some benefit to doing that, and perhaps it's something worth considering. But if someone in your team's come along and said, I think we should use Terraform because it's cool, then no, I wouldn't go down that path at that point. You've got to make sure it's worth it for you. You also need to understand, how you would actually transition. Is it a lot of work? Is there a converter to allow you to move from one language to another? Something like Pulumi offers a converter from Terraform, which you can use to actually convert your code. And obviously it's programmatic. It's not always going to be perfect, but that might help your transition. Can you transition gradually? Can you do a few modules at a time, or a few sets of resources at a time, and just do those as an initial test, and then move the rest gradually? Because if you've got to do it as a big bang approach and you've got a lot of existing infrastructure as code, then that can be a really painful experience. Maybe makes it not worth the effort. So you need to work out, actually how much effort is it for you to move? Does that outweigh the benefits of actually moving that you've identified in that language? So yeah, it's a very consultant answer, but it very much does depend. And if you're happy with your language of choice, then don't move. Would be my advice. So lastly, just before we wrap up, I want to talk about a few real-world scenarios where a particular infrastructure as code language has proved useful. So first up, there we talk about sort of getting started, and we mentioned this already. If you're brand new to infrastructure as code and you want to get started with just the concept, and you're not particularly concerned about which language you want, then there are certainly some languages which are easier to get started with than others. ARM templates, I would say, should be definitely off the table. Bicep is a great language for starters, I think, because it has all the simplicity moved away from ARM templates, but it still maintains the statelessness. And I think the state files are great. They have some real benefits, but if you're new, having to write the new language and get familiar with the concept of infrastructure as code and having to deal with state can be really confusing. And so Bicep is probably the simplest option. It's a simple language. It doesn't have state to deal with. You're not having to learn any programming languages. And it's heavily supported and documented by Microsoft with a lot of community support. So that might be the one of the best options if you're just getting started and you don't care what language you're using. Now, obviously, if you're working in a company and they're already set on Terraform, don't go and start using Bicep as your learner language, because you're still going to have to transition over to Terraform at some point. But if you just want to get started, that's one way to do it. On the other hand, if you're trying to get your developers to pick up using infrastructure as code, and we kind of already mentioned this, but giving them access to a tool that supports a language they're already familiar with, like Pulumi, Wolffarmer, will make that transition a lot easier. So that those sort of languages are probably going to be easier for them to adopt than trying to look at a custom DSL like in Bicep Terraform. We talked quite a lot about multi-platform, but let's talk about a real specific use case. This is one I've dealt with. Is Kubernetes is becoming more and more popular. People want to use it. You can deploy Kubernetes clusters in most clouds. And particularly, I can deploy a Kubernetes cluster, an AKS cluster with Bicep. But once I've done that with Bicep, I can't do any more. And usually, when you want to deploy a Kubernetes cluster, you also want to deploy some resources onto it. You need an ingress controller. Maybe you want Cert Manager running on it, and so on. It's using one of those multi-platform tools like Pulumi or Terraform has some big advantages, because I can deploy all my prerequisites, all the virtual networks and everything else that goes along with it. I can deploy my Kubernetes cluster, and then I can deploy actual Kubernetes resources, maybe using Helm, onto that cluster using the same language, and I can have a library, and I can maybe even turn it into a module that I give to my users and say, run this, and you'll get a pre-configured Kubernetes cluster that's got all the resources you need. It's secure, and all those sort of things. I mentioned earlier about automation. If you want to take your code, infrastructure as code, a bit further, and you want to actually build more automation around it, so maybe you want to build an API or a web UI your users can come in and deploy resources through. Pulumi has this great automation API that can help you do that. And you can basically just integrate that straight into your project. Whereas something like Terraform or Bicep, you would have to write some code that perhaps called out to PowerShell or some command line to run your templates and so on. So it's a bit more difficult. It's not a native part of the programming language. So in that scenario, maybe you'd look at using Pulumi in this automation platform. And then I mentioned this already, but escape hatches. If you find you can't do something in a language and you need a way to do it as part of your deployment, what functionality does the language have to allow you to just do anything? And it's usually run a script of some sort or pull something externally. Some of them are more complicated than others. I would say probably Terraform has the simplest option with its local or remote exec, where you can just point it at a file and say, run this executable with this file, so in PowerShell.exe with this file, and run that. I know you're not going to be aware of the state of it, or you'll know if it's been run or not, and that is a downside, but at least I can get it done as part of my end-to-end process, and that makes it really simple. Pulumi has some nice features in the ability to run just arbitrary code like C# or Python or whatever. It's a bit more difficult to implement because you've got to write that in the native language, which if you're not a developer, maybe you're not that familiar with, and you've just learned the Pulumi bits. But that can be used very flexibly. Whereas things like Bicep and ARM templates, you need to use the script resource and run it through a container, which can be more complicated to use and a bit more difficult to get started. So those are some scenarios that might drive you to one language or another. And that's it. Just on time, which is good. So hopefully that was useful. Hopefully it encourages you to get started looking at infrastructure as code, but also helps you pick out which language you want to get started with, which one appeals to you, and which you think will be useful. As I said, all the slides and the samples are on GitHub, so feel free to go have a look at those. If you've got any questions, I think I've got a little bit of time now, but also I'm always happy to answer them on Twitter. So feel free to send me a tweet and I will do that. And if you're interested in more articles on this sort of topic, feel free to have a look at my website. And that is it. Thank you very much for listening today.
That was great, Sam. I was just looking at your session from behind the scene. You did talk about all the different services. You talked about them. You also showed a demo. Then you also compared them. Also shared the scenarios. What are the factors one would consider when choosing any platform? That was really great. I would say it was a very complete session, to be honest. That's what I felt. We have some questions coming from the comments from the viewers. Let's say Sebas is asking, Pulumi, as what it's being described, it has too many good points, but I see everywhere people using Terraform. Is that the general feeling?
Yeah, it's changing a bit. So Terraform has been around a lot longer than Pulumi, so it has built up a much larger following. If you were looking for a multi-platform option prior to Pulumi, that was all there was. And so it has quite a big following, and the fact that it's a DSL rather than programming language, it's perhaps a lot easier to get into. But there are a lot of people picking up Pulumi. I do a lot of Pulumi myself nowadays, and working looking on their Slack and so on. It is growing, and more people are getting involved. And the fact that you can there has a lot of good points, particularly around being able to use real languages. It is, in my view, it is getting a lot more uptake over the last perhaps year or so.
All right. I hope, Sebas, that answers your question. There's another one from Lalo. Thanks for Lalo for asking. He's saying, in a day-to-day basis at a cloud engineer role, where does IAC show? Really loved your ARM masterclass, Sam.
Yeah, so IAC is really about turning your manual processes of going into the portal and clicking things into a more constructive process. If it's something you're doing once a month and you're going and creating a VM and that's it, then maybe it doesn't have all the same benefits, although I'd still argue it does. But if you're doing a lot of deployments, if you want the consistency, if you want the speed of doing deployments, you want to not have to go in and deploy the same VM 6 times, you just want to run the same template, then that's where really infrastructure as code shines. It gives you the consistency, it gives you the automation, gives you the speed, and it stops you making so many mistakes, or at least you make all the mistakes up front, and you find them all. And particularly if you're working in a sort of more development process, you can then apply more developer type things to it. You can use Git, you can run tests, you can use deployment pipelines in DevOps, Azure DevOps or Jenkins or so on.
Yeah, version control is also very helpful. Loka is asking, do any of these IAC providers allow deployment locally / on-premise?
It depends. So certainly the ones you would look at with Pulumi or Terraform, they're the only ones that would do that. I've never done it, so it's just looking at the documentation is probably the best place. But I know they do have some providers that work with certain things. You can deploy. You can work with things like Ansible and Puppet and so on to trigger configurations. I don't know whether you would be able to deploy. In fact, no, there are certainly VMware providers. So if you want to deploy virtual machines, you could do that. Obviously, bare metal is a lot harder, and I don't think you'd be able to do that. But you can certainly do VMs through there's definitely a VMware one. There may be some other VM provider ones as well.
All right, we'll take final question, then we'll move to our next session. Alan is asking, so Sam, do you know when the ARM equivalent of function is coming to Bicep?
No, I don't. It's been something that's brought up, and if you look in the Bicep issues log, there's a lot of conversation about it. The last I read it's certainly something that is planned. I think they want to do a good job of it, because I think the implementation in ARM was a bit lacking. You could only really use certain things. It was very limited. Not many people used them. So I think they're trying to make it a bit more functional. But no, unfortunately, I don't have any information about when that's going to happen.
All right, so Sandeep says, thank you, Sam. Very helpful information on this topic.
No
Alan also says, many thanks, Sam. Hasnan says, nice, Sam. Thanks for sharing the knowledge. Thanks everyone who's joined and asked questions. It's always good to have some interaction. Sam, that was a great session. Any final thing you want to plug in before we move to the next session?
Yeah, the only thing I would mention is probably not on my slides actually, but if you're interested in getting started, I have a whole series on getting started with ARM templates and Bicep on YouTube. If you look at YouTube /Sam Kogan, and it's a whole video series that will get you started with that process as well.
All right, Sam, thank you so much for your time. Really appreciate it. I know it's a work day, people have work to do. So I really appreciate you taking out your time and contributing to the community. We'd love to have you back. We do a lot of events, we do a lot of live shows and virtual conferences. We'd love to have you back. And thank you so much and hope to see you soon. Bye-bye. Take care.
Bye.
All right, that was an absolutely great session by Sam. Definitely go ahead and check out his YouTube channel. I couldn't find the URL, but yeah, it's time we go ahead and invite our next speaker. Our next speaker is Rudy. He's a product manager at Pyra Services Limited. Pyra are the partners of this Cloud Summit 2021. If you want to know more about Pyra, I have dropped all the links in the description. And Rudy is going to talk about creating a PaaS on top of the Azure platform. So let's go ahead and bring our next speaker. But before that, gentle promotion. Hi, Rudy. Welcome to Cloud Summit 2021. You are muted, Rudy. You're muted.
Sorry, a habit of online presentation. Hi, Simon.
How are you doing today, Rudy?
Yeah, I'm doing fine, thanks.
Yeah, all right, Rudy, I won't take much of your time. First of all, thank you and your company for being a part of this Cloud Summit 2021. I see you have already shared your screen. I'm going to add it to the stream. Maybe, Rudy, you would like to click on that stream and height pop-up. Yeah, click on that height. Yeah, that height.
Oh, not that one. So,
never mind.
And this is the correct one.
Yes, exactly. Everybody can see your screen, and next 45 minutes is all yours.
Okay, thank you. So yeah, welcome all to this session where I talk a bit about creating a platform as a service on top of the Azure platform. And I know that not many of you will create a platform as a service, but you will see why I have chosen this title later on in the presentation. But we hope that we can tell you a few tips and tricks that we have learned and some knowledge sharing if you create something on the Azure platform. So a quick look at the agenda. When you have your application ready, then, okay, where are you going to deploy it? So let's have a quick look at deployment options. I'll show you a quick demo of Payara Cloud. You saw it also in the intro, but let's do some real demo of how you can use it and what it is capable of today. And then I'll discuss a few of the components of Azure that we use to create that Payara Cloud product, and share that knowledge, shared that info that we have learned that might be useful for your situation. And then as closure, I want to discuss a bit more about Kubernetes itself, or the tools that you're using on top of Kubernetes, like, for instance, this Payara Cloud product. So your deployment is ready and you need to deploy it. Well, hopefully you have thought about that at the beginning of the project and not when the application is ready. But what are your options to deploy your application? So some companies, they still rely on buying a physical server and put it in their data center, connected to the network, configure the proxy server, install the runtime, etc. So they want to have control about all the different parts of the setup, the configuration, and of the entire system. That can have sometimes a reason. Sometimes there is a reason for that, of legal reasons, for instance, for data that where your data are stored or whatever, and that's perfectly fine and no problem if anyone is doing that. But some people don't want to buy, of course, that physical server and put it in their local data center, because the resources are fluctuating a lot, and maybe the server shipment is delayed, etc. So many people who use what's called infrastructure as a platform, infrastructure as a server on the cloud platforms, which is more or less the same as you do on premise, of course. You specify, of course, most of the time within a GUI or within a script, what your requirements are for your new server, like memory and CPU, and with a few clicks later on, then you have your server, either a dedicated server, if you have that option, or a shared resource on a larger machine, where you can start up a remote shell, and you can do again the same things that you do on premise. Of course, the other benefit is that you can scale easily. You can create more easily some additional servers, or you can even drop a server if you no longer need it. There is also the option of the platform as a service, where you don't want to maintain that runtime yourself anymore. You are using a classic runtime, the Jakarta runtimes as we use with Payara, where we are specialized in providing Jakarta runtimes for web applications. Then you maybe have a managed environment where you don't need to install that runtime, you don't need to maintain it, and in that platform as a service solution, you only need to care about uploading your application and configuring your application. So that's much easier, especially if you are not that big player in the market. You're just a smaller company. You have maybe only a few applications, and then this kind of managed platforms is, of course, easier, because you don't need to learn all those things. You don't need to do all those things. For me, the container as a service solution is also kind of a platform as a service. There you don't have your specific runtime, as you don't have the Jakarta runtime, which is managed for you, but you have, instead of that, a Docker environment, Kubernetes setup, where you still are responsible for setting up the entire infrastructure and creating the configurations within Docker and within Kubernetes, etc. So you see, you have many options, and there are many factors that define what is the best solution in your case. So I cannot say that one of those 4 options are the best solution. But today I would like to talk a bit more about that platform as a service solution, either the managed solution where you don't need to take care of the system itself. So it's all managed for you, only the application and the configuration you are responsible for. Or in contrast with that, the classic systems where Kubernetes is used. So let us have a first quick look with a demo about that Payara Cloud, how that entire managed situation could look like. And in fact, that Payara Cloud is built on top of the Azure platform and the Kubernetes service. So although it is managed, it is using underlying all those technologies and all those frameworks. So for me, I have here a demo environment because we are not live yet, so it's not yet production. We have only a few things to do, but we are very close. And I can log into that environment. And then you get a overview that you can group your different applications in namespaces. So a bit the same as within Kubernetes, we have kept that distinction there. And if you have that namespace, then you can deploy their applications within it. You can see some logging information and monitoring. But let's upload an application and see how easy it can be to get something running in the cloud. So I have here an application ready. I can do the uploads. Later on, I'll tell a bit more what it is doing in the background here. I can change the configuration, so I can change the context route where it is deployed. I can change some accessible parts within my application, or I can make it the entire application accessible from the outside. I can define the size of my environment, if it's only a small microservice or a larger monolith that probably needs more CPU. And it also discovered that I have a few configuration parameters. For instance, there is a default, but for this environment, I want to have another value for the email address here. I can add additional keys if I like, but I'm just going to save now. Configuration is ready, and I can click on the deploy. Now it is setting up the entire application on that Azure platform. It creates everything behind the scenes for me. I don't need to care about any of those things. And if everything goes well, and sometimes it takes a bit of time, see my application is not available, I tell you in a moment why. But then your application appears. Let me switch for the moment then to the logs, for instance, in the meantime. So in that other application which I deployed earlier today, you can see, for instance, to the log, access to the log files can be very important. Seems to be an issue with the environment because I don't see any logs for the moment. Because it is managed, you don't have really access to your application, to your container. So that means that you need to be able to access the logs so that you can see what is going on. Not only logs, but if you running into some performance issues, because this is a Java-based applications, then you need to be able to create heap dumps and thread dumps to analyze, etc. In the meantime, my application was available, and it shows my my first screen. Of course, it's just a demo. It's not very useful, but if you see, then I go to that screen where he picks up that value that I've configured there. So he actually took my configuration value and not the default one. You can have many configurations. You can change the configuration again. You can upload new binaries. You can do the, for instance, let's say that I'm going to change the configuration here. For instance, I'm going to create it as my application, for instance. Then you see that he has a new configure status, and then you can deploy that, for instance, and then he takes the old version out of order and he deploys a new revision. If something goes wrong, you can easily go back by clicking to revert to this previous version, and you can deploy it again. There are other functionalities not shown here, so you can, instead of the generated domain name here, you can link your own domain names there. And as you can see here, you can have a follow-up already in basic view, but in the extended plans, then you also have access to more detailed information of the entire platform. So that was very quick overview, because probably not everyone knows about what Jakarta is, what the web application is, or even Java. So because the main focus lies on the Azure platform and the Kubernetes component and all the different components of Azure which you can integrate. So that's why I keep this demo limited, just that you have a feeling what you can achieve by creating something custom on top of a platform. And the reason why we did it was because within in the Java enterprise world with Jakarta EE, developers were used to building just the WAR application, the web app application, and had a WAR artifact that could be deployed to a runtime. Traditionally, that runtime is just installed on a server like Payara server or even Payara Micro. You just need to configure that database, for instance, or a few configuration values, but you were not confronted with all the low-level details. If you are now going to a cloud environment, like the Azure platform is one, but also all the other platforms, of course, and you have to deal with the different virtual machines and the pods and Kubernetes and configuring services and deployment scripters, secrets for your configuration values, etc. Then, of course, that developer, and especially if your company uses the DevOps role, the DevOps style of working, the developer is now confronted with all those kind of technologies. He needs to learn it, he needs to be able to work with it, etc. That means, of course, that part of the role is not only providing functionality to the end user through that web application, but you also need to learn and take care of all the other things, like creating those YAML files and all those infrastructure elements. So the idea was, let's go back to the original Jakarta EE philosophy. You just deploy to a runtime, but this time the runtime is an entire system, an entire environment which is running on a cloud. But we still have that same philosophy. Just click deploy, configure your application, and you're done with it. That's, of course, a trade-off. If you don't have access to all those low-level details, it will be probably difficult or even not possible to do whatever you like with the environment as you when you use Kubernetes directly. On the other hand, it frees you from all those frameworks, all those tools, and you can have a quick deployment as you are used to. So actually, the Payara Cloud has two main components. The one that you saw in the demo, the application management. The application management is responsible for uploading, the ability to upload that application, the configuration, the interaction with your environment. That's one thing. There is another part because our users will be able to run the application they have created on our environment, on our subscription. So that means that we need to provide billing for them. So we have also a second part, which is the billing management, which interacts with a third-party billing platform, etc. And we have created a single sign-on between the two with our OpenID Connect provider, so that user can seamlessly switch from one to another. Most of you, of course, do not have the intention of creating a real platform as a service, so that billing management, that's good to know that we have that, but let's concentrate us on that application management and how that interacts with the Azure platform components that we use, and what you can maybe learn from what we have discovered during the creation of this product the last 18 months. There are three major groups, three major topics that I want to discuss. The first one is on the left side there, everything related to an image, the container registry, and Kubernetes itself. We have created a generic image, so that's one image which can be used for all applications which are uploaded. We could also have chosen for the option that we create on the fly a custom image for each application. But we want to keep it generic as possible, because when you have only one type of image where you know how to handle that, how you can add there the application which is uploaded, then of course that makes it easier to maintain. It's just one image instead of maybe 100,000 images that we need to maintain in that registry. So that generic image is then uploaded in the registry, of course, and is used, as I will explain you later on, by the Kubernetes service to create the environment for you, which is running the application. So one of the things that maybe is which you might try to implement also in your own organization is to have a generic image that you don't have 10, 20, 50 different images if you have 50 different applications, because then it's easier to maintain it afterwards. I agree. At first, you have probably a bit more time and effort to create that generic image and all the scripts to handle a generic image for all those different applications. But afterwards, it's of course much easier because it is uniform in a uniform way. All the applications are handled in the same way, which of course makes it easier later on to maintain them and handle them. The second group is once that application is available, the second group of components all relates to the fact of making your application available to the outside. Application is running within Kubernetes, but then of course you need to expose it through, for instance, the gateway component that we used within the Azure platform to expose it. So combination with the gateway and the ingress controller for that gateway component, we send the required information to all those components, and it is able to make our application available. Also here, what we found out is that it can be tricky. As you can see, you have that ingress controller, you have also the DNS handling, you have the Let's Encrypt, what we use also for providing the SSL certificates. That's a lot of moving parts, and so you have a lot of asynchronous and handling and checking when things are ready or still in progress. So that's one thing that you need to be aware of, that can be some of your attention points. There are also various ways of exposing your application to the outside world. There are various options within the Azure platform, and that's a good thing, of course, that you have to choose what suits you best. But some of them have advantages and disadvantages. Well, each of them has advantages and disadvantages. So the solution that we have chosen, it works fine, as you have seen, but you also saw that there was a little delay before that that application was available, so that the entire gateway and ingress controller was set up and ready to receive requests from the outside. So that's a thing that we are now looking into to see if we can modify it, update it, so that you have, for instance, a smoother experience when you do rolling upgrades of your application, that you don't have a few seconds of downtime, of course, when the old version is taking out of the loop and the new one is made active. As mentioned already, the third part is also very important now, because your application, if you run it on premise or you are using that infrastructure as a service, you can always do a remote shell, remote access to your environment, and you can access whatever you like log files or anything else. With this setup, you no longer have direct access, of course. Everything is shielded away, so you need to make sure that your user, or if you're using it within your company, that people are able to find out if there is going something wrong, or if they can have access to the required logs. And taking threat dumps, for instance, as I've shown in the example. So that log analytic workspace, that's what we used for our product, mainly because when your program crashes for one reason or another, or the pod and the service stops, the log files should still be accessible to see what happened, to find out if there is any clue, probably, and hopefully you have activated enough logging so that you know that you can find any issues if there was an issue. So that log analytic workspace is like the data warehouse where all the log information is then sent to and then can be used for inspection. So you remember that I uploaded that binary and then it was ready for in the cloud. So what are we doing? Maybe some of the things can be interesting for you also, if you want to create such a generic solution as we have did. So after that we upload the binary, we scan that deployment for any kind of config. We find out if you're using microprofile config for the configuration, and present them to the user the option to change those values or create additional values. We also scan the application to see if it uses a database connection, and then we present the end user a screen where they can enter all the parameters to connect to a database. Based on that information, so I changed one of the email addresses, we capture that, and then based on that information, we create config maps and secrets, which then in the next step, the define of the deployment and the service, what we call the provisioner controller also, that basically it is a Kubernetes operator that takes all that information. So it takes that those config maps and secrets, it takes the uploaded binary, which is stored on a volume, and it takes that generic image with Payara Micro that we have defined, and all that information, he creates the required Kubernetes objects out of it so that you have a properly working deployment and service. Based on that information, then the pods are launched automatically. And then we can go to the next step, the setting up of the DNS names, configure the routing and the request of the SSL certificate. They are showing here in a series of steps. We do it in parallel, of course. And then when that is all done, then the last step is that we connect all the logging information, all the log output of the pod. We connect that to the log analytics workspace so that it can capture all the information that is available in the logs there for inspection and monitoring, of course. So what are the things that we have learned that might be useful for other people? although you're not creating a platform as a service, probably. That single image that I mentioned, so not create an image for each application, but a generic one. As I said, more time in the beginning to set it up, but after you have done it, it is easy to maintain. You only have one solution. It is easy to add another application to your entire stack because it plugs in there. You don't need to do anything if everything is done properly, of course. You don't need to do anything specific for that new application. The other thing that we can say is about that routing. Be aware, probably other people have also found it out already, that ingress setup and the exposure of your application can be sometimes tricky. And as I said, we have for the moment a requirement for the downtime in that URL, so the applications are still fine, but the routing is not following up quickly enough to catch up with all those changes. Those log analytics, make sure that you can have diagnostic that are easy to access also when the system is down, because you don't have any direct access anymore to the environment. So make sure that it is accessible outside of the entire system. A general thing, but again, we have hit it. Good documentation, which is up to date. We started with a proof of concept where we thought we had documented everything as it should be, so that we had every step to recreate the environment that we had at the end of the proof of concept. So when we then deleted everything and started over again for the real thing, it appeared that there were still a few things, smaller things, but still a few things missing in the documentation. Also, be aware that you should do regular testing, for instance, for disaster recovery, or if you want to apply the entire solution for a next application, because platforms do evolve. There is evolvement in the Azure APIs. So if you do a regular testing for an acceptance environment, for instance, to see if all your scripts, if all your documentation is still valid today, and that there is not any command or action that requires some changes because the platform evolved. So why should people consider maybe Payara Cloud, especially if you're in that Java Enterprise, Jakarta EE world? And I'm going to say the first three bullets, maybe you think that we don't like Kubernetes, but the last one contradicts that. But first of all, Kubernetes, it is really created for maintaining multiple servers, should I say, multiple applications, scaling. So that's most of the time for larger environments. If you are just having one application that you want to bring to the cloud with Kubernetes, where you don't have any scaling requirements, so you just want to have one pod in this instance to which runs your applications and gives the end user a response, then that's probably not a good case for you to switch to Kubernetes. Also, what I find, what I see with with several people that they struggle with is that Kubernetes is a tool. It's not a finished product. It's a tool that you need to use, that you need to use in scripting, that you need to learn, that you need to adapt for your environment. So it is not a finished thing that you can just use and just follow a guide from A to Z and it is done. So you have to learn a lot about Kubernetes, all the different options, all the different possibilities and how to do things. So it's a large investment in resources and time, and people need to learn it. But don't get me wrong, as I said, Kubernetes is great. So it's one of the best things, the most innovating things of the last 5 years or something. Of course, there are many things, but I find it one of the great things what happened the last years. But sometimes I think, and you see more and more and more of that trend in the last year or something, not always is Kubernetes the solution for your case, and maybe you should use some tools on top of it. So, for instance, I saw that AWS also have something on top of Kubernetes to make it easier to work with Kubernetes for those that don't need all that details and that fine-tuning with using Kubernetes directly. Just a conclusion, not going to spend much time about it. I said Kubernetes is great, but maybe not for everyone. And that means that sometimes I see the case that a lot of several companies are struggling with Kubernetes, and they create a lot of scripts and tools and around it. And actually, if you look at it, they are building their own platform as a service. That's why I chose that title of this presentation. So even if you are only creating a solution for your own company, sometimes it looks like you're building a complete platform based on top of Kubernetes. So be aware of that, if you go that route, then you can end up with a whole new stack of own scripts and tools that you have built for that. If you don't want to do it, or you don't need to do it, then products like Payara Cloud can speed up the move to the cloud. As you saw it, just you need to develop the web application and deploy it on the product, and it is ready to serve to your customers, to your end users. So if you want to get informed when we have more information or when we go live, then you can subscribe on this page. On the URL is on top, the /product/Payara Cloud. You can leave us a message, and then we certainly come back to you with more information and warn you, inform you when you can use Payara Cloud and that you can subscribe it and that it is ready to be used. So that's the application, that's the demo, that's the presentation. We have a few minutes if there are some questions.
All right, Rudy, that was great. I do have a question from the comments. Bhaskar is asking, he says, nice tool. Is this tool only applicable to those who are keeping IaaS from cloud and wanted to create their own PaaS? Where else we can use it?
As I mentioned, if you have a web application and you don't want to invest in all the details of putting that on in any kind of cloud environment, then yes, you can use that Payara Cloud. So it is, as I mentioned, one of the options to deploy your application, and it is depending on each situation, each customer, each company, what is the best solution. So.
Perfect. I don't see any more questions. Someone says excellent presentation. And any final thing, Rudy, you want to plug in? Anything you want to plug in before the end, the part one of last day?
Yeah, no. I would like to thank everyone who took the time to have a look at the presentation and our product, and hopefully, when you're interested, then we can hear from you.
Yeah, thank you so much, Rudy. Once again, thank you so much for you and your company for supporting the event. We'd love to have you back. We do a lot of events. We do all these events for community. We'd love to have you back in all of those. Until then, take good care of yourself and see you soon. Yeah, bye.
Yep.
Take care.
Thank you. Bye.
All right, that was a session by Payara Services. Definitely go ahead and check out all the details are in the description, and also you can find their details and also about a blog on the conference website. Having said that, it's now time to go ahead and announce the winners of part one. And this is the final time I'm announcing. This is the last time, the final winner of part one, because the summit ends today. It's 11 days of summit ends today. Oh my goodness. We have streamed around 100 hours. Can you believe that? We have streamed around 100 hours. I don't know how I'm still alive. And only because I'm young. Never mind. I won't be young always. All right, so let's see who wins it. We have all been asking that whenever you ask any question to speaker or drop any comments, you have to use Cloud Summit hashtag. And now it is time to go ahead and pick some lucky winners, not lucky one winner. So because we give winners 3 winners, we announce 4 winners each day. So here's in the count of 3, 2, 1, let's go. Some drum rolls. I always forget to put some music. Never mind. Who wins it? If you have already won, we don't consider it. Oh my God, that's a very big name. Take a screenshot of this, drop us an email at simon@azuresummit.live and with your shipping address and contact number, and we'll make sure that we ship you the Cloud Summit swag kit next month. This month is very busy. We'll ship you next month. Yeah, having said that, what else? Yeah, the streaming ends over here, right? The streaming ends over here because we take a break. And I'm going to drop the new streaming URL in the... Oh my goodness, why don't I see new streaming URL? Oh my goodness, I think I forgot to make it. No, I don't think so. I'll have to find it. Visit azuresummit.live website and we'll make sure that we meet you over there. It's a break of just about 20 minutes. Until then, see you soon. Tara, bye. And people says thank you, Rudy. Yeah, right. Thank you, Rudy. Yeah, Lakshmi, thank you. Tara, see you soon.
Hi, I'm Anna Hoffman.
Hey friends, I'm Nikolai.
Hi, I'm Mustafa Turaman.
Hi, I'm Tanya Janka.
Hello.
And I'm excited to be the speaker at Azure Summit 2021.
It's a fantastic event that will be 11 days live streaming,
where more than 100 speakers from all over the world.
I'm excited to speak at Azure Summit about Power BI and Synapse Analytics.
And I'm going to talk about security.
And also a Microsoft MVP for Azure.
I'm speaking at Cloud Summit about automated release of .NET application.
And the best part is that this is a free event.
Come join me live at Learn TV on September 17th.
Come join me live on Learn TV on September 14th.
Come join me on Learn TV on the 14th of September this year.
A bunch of other Microsoft and community speakers.
So if you want to learn how to secure Azure, come to my talk.
Join us. It will be a lot of fun.
See you there.
See you there.
See you there.
See you there.